What if everything we know about the universe is merely a fragment of its true essence? The cosmos, vast and enigmatic, harbors secrets that defy our understanding and challenge the very limits of human imagination. In the journey to unravel its mysteries, we venture into the unknown, seeking to comprehend what lies beyond the observable reaches of our universe and pondering what the answers could mean for humanity. The concept of an edge to the universe, as we often understand it, is inherently misleading. Unlike a simple box with clearly defined corners, the universe does not possess a physical boundary that we can approach or touch. Instead, consider the universe as something akin to an inflating balloon. As the balloon expands, every point on its surface remains a part of the balloon, yet the distance between points grows ever wider. When we speak of the edge of the universe, we aren't referring to a definitive endpoint, but rather the limits of what we are capable of observing. This visible boundary is known as the observable universe. Due to the finite speed of light, we can only perceive objects whose light has had enough time to reach us since the birth of the universe, approximately 13 billion years ago. Beyond this observable region, galaxies, stars, and other cosmic structures may exist, yet they lie beyond our current ability to detect them. This creates the illusion of an edge, but in reality, there is no physical boundary where the universe comes to an end. The universe continues to expand, with its true extent remaining a mystery that beckons us to explore further into the cosmos. Scientists define the observable universe as the part of space that we can detect and measure, constrained by the limitations of our technology and the speed at which light travels. Imagine the universe as an immense ocean, and the observable universe is simply the portion that we can currently explore. This region is defined by how far light has traveled since the universe's inception, approximately 13.8 billion years ago. Yet, because the universe is expanding at an accelerating rate, the actual distance to the farthest objects in the observable universe is far greater than the simple calculation based on the age of the universe might suggest. The light we observe from these distant objects has been journeying for billions of years, offering us a glimpse into the universe's distant past. This observable universe forms a vast sphere, with Earth at its center, stretching outward in all directions. While this sphere is colossal, it represents only a fraction of the universe. Beyond the limits of this sphere lies an untold expanse that may extend far beyond what we can currently perceive. Consequently, there remains an immense portion of the universe that is still hidden from view. As a result, scientists are constantly seeking new ways to push the boundaries of what we know, eager to uncover what lies just beyond our reach. The cosmic horizon, an invisible boundary that defines the furthest points we can observe, plays a crucial role in this quest for knowledge. Picture the universe as an immense ocean, with our observations limited by the distance light can travel. Beyond this cosmic horizon lies a region that is effectively unreachable to us, because the light from these distant areas has not yet reached us. This horizon is significant for a number of reasons. It helps to define the size of the observable universe, the part we can study and comprehend, and underscores the limitations of our observational capabilities. It serves as a reminder that the universe extends far beyond what we can currently detect. Moreover, the cosmic horizon offers critical insights into the nature of the universe itself. The expansion of space is ongoing, which means that regions of the universe are moving away from us at ever-increasing speeds. As the universe expands, parts of it may eventually cross this horizon and become inaccessible, forever out of our reach. This revelation is central to our understanding of cosmology, as it implies that certain regions of the universe will remain permanently beyond our grasp. Studying the cosmic horizon raises fundamental questions about the universe's fate and structure, compelling us to consider the possibility that there may be distant regions that harbor different physical laws or unknown forms of matter, phenomena that we have yet to encounter. The cosmic horizon is not simply an edge. It represents the boundaries of our current knowledge, as well as the infinite possibilities that lie beyond our perception. Light, in its many forms, is the key to unlocking these cosmic mysteries. It carries vital information about distant stars, galaxies, and celestial events across the vast expanses of space. The speed of light is incredibly fast, but because it takes time for light to travel across such immense distances, when we observe light from a far-off galaxy, we are essentially looking back in time. The light we see is a snapshot of the galaxy as it was when the light began its journey to us, offering a glimpse into the distant past of the universe. When scientists discuss the cosmic horizon, they are referring to the boundary beyond which we cannot see, due to the finite speed at which light travels. Since the universe is expanding, this boundary is not fixed. As the universe continues to stretch, light from more distant regions will eventually reach us, revealing parts of the cosmos that were previously hidden. The ancient light we observe from distant celestial bodies provides clues about the early conditions of the universe, offering a valuable window into its formation and evolution. Additionally, light reveals the underlying structure of the universe itself. Different wavelengths of light, such as visible, infrared, or ultraviolet, provide unique insights into the cosmos. For example, infrared observations allow us to see cooler, dust-obscured objects that might otherwise remain invisible. This diverse spectrum of light helps scientists piece together a more comprehensive understanding of the universe. Furthermore, light is influenced by the expansion of the universe. This phenomenon, known as redshift, occurs when light from distant galaxies stretches into longer wavelengths over time. By studying redshift, scientists can estimate the distances and velocities of galaxies, enhancing our understanding of the universe's structure and its eventual destiny. Light is more than just a source of illumination. It is an essential tool in answering the profound questions surrounding the universe's size, shape, and history. Through light, we gain a deeper understanding of the cosmos, placing each new discovery into the grand narrative of the universe's ongoing expansion and evolution. The concept of an edge to the universe challenges our traditional perceptions of space and time. We typically envision the universe as an infinite, boundless expanse, where one can travel in any direction without ever encountering a limit. However, when we consider the possibility of an edge, the questions multiply. If the universe has a boundary, what lies beyond it? Is there nothing, or is there something we simply fail to comprehend? This idea forces us to reconsider our understanding of space itself, raising the prospect that space might not be infinite, and that we might be confined to a finite region of the cosmos. Such a scenario compels us to rethink our place within this vast universe. If the universe does indeed have an edge, it implies that our observations and experiences are restricted to a specific region. This raises the possibility that parts of the universe exist beyond our reach, suggesting that there is far more to the cosmos than we can ever perceive. Time, too, is affected by this concept. If the universe has an edge, does time behave differently in those far-off regions? Could time itself be influenced by the very structure of the universe? As we observe distant celestial objects, we witness light that has traveled for billions of years, revealing a finite history of the universe. If the universe has a boundary, it could radically alter our understanding of time, disrupting the flow of events and our relationship with the past, present, and future. As scientists continue to explore the expansion of the universe, they suggest that it may stretch far beyond the limits of what we can observe. This ongoing evolution continually reshapes our perception, leading us to the realization that the universe might be far stranger than we can imagine. The very notion of an edge, then, compels us to confront some of the deepest mysteries of existence: our place in the cosmos, the nature of time itself, and the ultimate fate of the universe. The question of whether the universe has a boundary is one that has captivated philosophers, scientists, and thinkers for centuries. Among the most intriguing theories is that of an ever-expanding universe. Imagine inflating a balloon. As it grows, every point on its surface moves further apart from one another. In this analogy, the surface of the balloon represents the universe, and there is no edge per se, only continuous expansion that creates more space. Another prominent theory suggests that the universe could be curved. Picture a sphere. If you were to travel along its surface, you would eventually return to your starting point without encountering an edge. This concept implies that the universe may be curved in a higher dimension, extending infinitely in some sense without a definitive boundary. The concept of the universe is far from simple. For centuries, We have observed the stars, galaxies, and the vast expanse of space, gradually piecing together an understanding of what it all means. However, as science delves deeper into the nature of the cosmos, the mysteries only seem to multiply, suggesting a reality much more complex than previously imagined. One of the most intriguing ideas to have emerged in this ongoing journey is the theory of the multiverse. The multiverse theory proposes that our universe is just one among countless others. Imagine our universe as one thread in an intricate, vast tapestry of realities. Each of these universes could operate under its own set of physical laws, constants, and conditions. If this is true, then the boundaries of our universe might not be confined to what we can observe. The edges of our reality may be only a local phenomenon, existing until they reach the borders of other realms, universes that stretch beyond the grasp of our current understanding. This idea raises the question, if the universe we live in is just one part of a much larger structure, what exactly defines the boundaries of our existence? Is the universe infinite, or is it just one facet of a multiverse stretching out into dimensions beyond our comprehension? These are the fundamental questions that scientists are grappling with today. One possible solution that has captured the imaginations of many theorists is the existence of singularities at the universe's edge. Singularities are points where the known laws of physics break down entirely. The most famous example is the singularity at the center of a black hole, where gravity is so intense that it warps space and time to the extent that our understanding of physics no longer applies. This concept challenges us to reconsider the very idea of boundaries. Could the edge of our universe be a singularity, a point where space-time itself behaves in ways we can't yet predict or measure? Moreover, the cosmic microwave background radiation, CMB, adds another layer of complexity to this discussion. This faint afterglow of the Big Bang is visible throughout the universe today, offering us a snapshot of the early universe. While the CMB does suggest a beginning, a moment when the universe began to cool and expand, its existence does not necessarily indicate an edge. Instead, it marks a boundary of sorts in time, reflecting a time when the universe began to change from a hot, dense state to the expansive cosmos we observe today. Taken together, these ideas form a picture of the universe that is continually evolving, filled with layers of complexity that challenge our traditional notions of what constitutes a boundary. The theories surrounding the universe's limits are not just academic, they redefine the very nature of existence itself, suggesting that there is much more to the cosmos than what meets the eye. A more familiar way to think about the universe's expansion is through the analogy of a balloon being inflated. If you imagine the universe as a balloon, every point on its surface represents a galaxy. As the balloon expands, the distance between all points on its surface increases. This mirrors the way galaxies are moving apart in our universe. Space itself is stretching, causing galaxies to recede from one another. This inflation is happening in all directions, meaning that there is no central point of expansion and no clear edge to the universe. Every observer, no matter where they are, would feel as if they are at the center of the universe's expansion, experiencing the same effect. If we extend this analogy, it also becomes clear that the universe might not have a definitive end or edge at all. Some theories suggest that rather than having a distinct boundary, the universe could be curved, much like the surface of a sphere. If you were to travel far enough in any direction, you might eventually return to your starting point, as though you had circled back around. In this way, the universe is more accurately described as a three-dimensional space that is constantly growing and evolving, with no concrete limits. In fact, the very idea of an edge in the universe is somewhat flawed when applied to an expanding cosmos. In our three-dimensional experience, edges are typically seen as definitive boundaries separating one thing from another. But in an expanding universe, space itself is stretching and evolving, meaning that the concept of an edge becomes less tangible. Even if you were to travel as far as possible in any direction, you would simply encounter more galaxies, further evidence of the universe's boundless nature. Furthermore, the expansion of the universe isn't just theoretical, it is observable. As galaxies move further away from us, we can see the light they emit stretching or redshifting due to the expansion of space itself. This implies that there are regions of the universe moving away from us faster than the speed of light, creating an observable horizon, a point beyond which light from distant galaxies will never be able to reach us. This doesn't mean that there is an actual edge to the universe, but rather a limit to what we can observe. Beyond this observable horizon lies a region of space that remains forever out of our reach, locked away by the very laws of physics that govern the universe. As we think about the universe's expansion, it is essential to recognize that it implies a reality that is infinitely stretching, ever-evolving, and lacking a defined edge. This expansion encourages us to think of the cosmos as an infinite journey rather than a destination. Instead of a sharp boundary, the universe seems to be an ongoing, boundless process. In addition to the observable universe, there are theories that suggest the existence of the multiverse, a notion that fundamentally challenges our understanding of reality. Imagine the universe as one piece of a complex puzzle, where each individual universe exists alongside others, each with its own unique set of rules. This theory suggests that our universe is not the only one. Rather, it may be part of an infinite collection of parallel universes, each with different physical constants and laws. One way to visualize this is to think of the universe as a garden. Each universe is a separate plant, growing independently but sharing space in the larger cosmic garden. Some universes might operate under completely different laws of nature, and in some cases, they may even harbor different versions of ourselves. These universes might interact with each other or remain completely isolated, beyond our reach and perception. Beyond this, string theory and the concept of parallel universes provide further avenues for exploration. String theory proposes that the fundamental building blocks of the universe are not tiny particles, as we have traditionally thought, but minuscule vibrating strings. These strings exist in higher dimensions beyond the three-dimensional space we experience. Just as the vibrations of a string on a musical instrument produce different notes, the vibrations of these strings create different particles. The possibility that our universe exists in more than 3 dimensions opens up the potential for new physical laws, radically altering our understanding of the cosmos. Parallel universes, often connected to string theory, suggest that other universes could exist alongside ours, each with its own set of physical laws. These universes could be drastically different from our own, or they could be similar, with slight variations in the choices made by individuals or events that have shaped the course of history. Imagine these universes as different plants in the cosmic garden, each growing in isolation, sometimes interacting but often remaining unseen. The multiverse theory, in combination with string theory, presents the universe as a vast, layered tapestry. Each thread represents a different universe, woven together in a grand cosmic design. This vision of reality challenges our perceptions of what the universe is and inspires scientists to explore realms beyond the observable, pushing the boundaries of knowledge further than we have ever ventured before. As we look beyond the observable edge of the universe, we are faced with more questions than answers. What lies beyond the regions we can observe? Could there be other universes with entirely different laws of physics, perhaps ones that are so radically different from ours that life as we know it could not exist? These questions continue to drive exploration and research, prompting us to reevaluate the very nature of existence. The observable universe is just the beginning of the cosmic journey, a starting point in a much larger, more intricate landscape. Whether we are considering the expanding universe, the possibility of a multiverse, or the mysteries hidden beyond the observable horizon, it is clear that we are only scratching the surface of what the cosmos truly holds. The boundaries of the universe, if they exist at all, are far more fluid and complex than we have ever imagined. The exploration of these frontiers is just beginning, and the answers may be far more astonishing than we can yet conceive. Space, an ever-expanding frontier, may harbor properties that elude our full comprehension. Some scientists propose that within its vast expanse, there could be areas where the expansion of space itself occurs at differing rates, creating regions that are in essence disconnected from our universe. These areas might remain completely unreachable, places where light or information can never journey to us, effectively leaving them beyond our perception. While much of this remains speculative, It is clear that these mysterious realms highlight the vast expanse of the unknown that still lies ahead in our quest to understand the cosmos. Our journey into the unknown is far from over. The challenge that scientists face when attempting to observe what lies beyond the observable universe, essentially the portion of space we can currently see, proves to be one of the most captivating riddles of modern science. Light from the regions within the observable universe has been traveling towards us since the very beginning of time, and it is through these signals that we can make sense of the vast cosmos. However, space extends far beyond what our eyes can reach, presenting a puzzle that can only be navigated with indirect methods and sophisticated theoretical frameworks. To tackle this challenge, researchers turn to the cosmic microwave background radiation, an ancient glow left over from the early moments of the universe. This faint light, which permeates the universe, serves as a snapshot of conditions shortly after the Big Bang, providing a way for scientists to glimpse the universe's conditions and structure during its infancy. By studying this radiation, scientists can infer properties of the universe that lie far beyond what we can directly observe. It's like tracing the faint echoes of the past to paint a picture of the distant unknown. In addition to this ancient light, mathematical models and simulations have become indispensable tools in the scientific toolkit. These models extend our understanding of how galaxies, stars, and planets have evolved over time. By applying the laws of physics, including gravity and the behavior of energy and matter, scientists can make educated guesses about regions far beyond the reach of our telescopes. They use these insights to predict what the universe looked like in its infancy and what it might evolve into, shaping our understanding of regions that remain hidden. Advanced telescopes and observational instruments are also crucial in this pursuit. Researchers direct these tools at the edge of the observable universe, striving to catch glimpses of ancient cosmic events, distant galaxies, or cosmic explosions, phenomena that may hold the key to understanding the universe's vast structure. Even the enigmatic forces of dark energy and dark matter, which account for much of the mass and energy content of the cosmos, are studied through their effects on the observable universe. The unexplained gravitational anomalies that dark matter and dark energy create continue to challenge our understanding, hinting at the presence of mysteries yet to be unraveled. With every discovery, scientists push the boundaries of knowledge, seeking to lift the veil on the universe's deepest secrets. The edge of the universe, a place where our observational tools and theories begin to fall short, sparks boundless curiosity. It represents the frontier of our knowledge at the very limits of what we can understand and perceive. As we ponder what lies beyond, several fascinating speculative ideas emerge, each more mind-boggling than the last. One such possibility is that of infinite space. If the universe is indeed infinite, then beyond the boundaries of what we can see, there could simply be more of the same, endless stretches of galaxies, stars, and planets, all continuing indefinitely in every direction. In this scenario, the fabric of space itself would extend without limit, untouched by the constraints of our perception, offering an infinity that is impossible to grasp fully. Another captivating idea revolves around the concept of the multiverse. According to this theory, the universe we inhabit is just one of many, each potentially governed by its own set of physical laws and unique characteristics. Beyond our observable universe could lie countless other universes, each with its own distinct reality. In some of these universes, life might evolve in forms completely different from anything we can imagine. The very possibility that there are multiple universes challenges the way we think about existence itself and opens up infinite realms of exploration. A more intriguing proposition suggests the existence of a boundary or edge to our universe, an actual cosmic skin that marks the limits of space itself. This edge could be home to exotic materials, strange phenomena, or even regions where the laws of physics as we know them no longer apply. At this cosmic frontier, the universe could become a place of unimaginable properties, with entirely new kinds of matter or forces that defy our current understanding. Equally mind-bending is the idea that time and space themselves could warp and distort beyond our visible universe. In these distant realms, the very concepts of time, distance, and reality might not function as we experience them. This notion raises profound questions about how we define the nature of existence and challenges the very foundations of our understanding of the universe. Some theories even suggest that the boundaries of our universe may not be absolute. Energy and matter could spill over from regions beyond our observational limits, interacting with our universe in ways that affect its expansion and evolution. This collision of realms could offer crucial clues, potentially unraveling the mysteries of the unknown and shedding light on what lies in those uncharted domains. Although these ideas are speculative and still largely untestable, they ignite curiosity and wonder about the universe's true nature. Each concept serves as a reminder of how little we truly know and how much more lies hidden in the vast expanse of the cosmos, waiting to be discovered. At the very edge of the universe, black holes offer one of the most intriguing and perplexing challenges to our understanding of space. Imagine standing at the boundaries of the known universe, where the fabric of space-time itself begins to warp and bend. Black holes, the collapsed remnants of massive stars, possess gravitational fields so powerful that not even light can escape their pull. These cosmic giants push the boundaries of physics to their limits, offering a glimpse into realms where the rules we rely on no longer apply. Black holes at the edges of the universe raise significant questions. In these distant regions, the nature of space itself may be influenced by these monstrous objects, stretching and distorting the very fabric of reality. The warping of space-time around black holes may challenge our understanding of space as a consistent and uniform entity. What happens beyond a black hole's event horizon, where not even light can escape, remains one of the most tantalizing questions in modern science. As researchers explore these black holes, they are confronted with profound mysteries. What lies beyond these powerful cosmic objects? Could black holes lead to alternate histories of the universe, or perhaps even to other dimensions? These questions point to the limits of our knowledge, urging scientists to think beyond the boundaries of conventional physics and explore new realms of possibility. Black holes, often perceived as the ultimate cosmic dead ends, are far from being simple voids in space. They hold vast amounts of information about the universe's deepest mysteries, offering clues to the universe's formation and the intricate structure that underpins it. Within the depths of these cosmic giants, researchers believe lies the key to understanding the conditions that shaped the early universe and may even unlock secrets about the birth and evolution of galaxies. For years, scientists have been captivated by the enigmatic nature of black holes, pushing the boundaries of our understanding of gravity. In the extreme environments surrounding them, these strange objects challenge the very foundations of current theories, compelling physicists to rethink the laws that govern the cosmos. As we attempt to contemplate what might lie beyond the event horizon, we find ourselves grappling with the idea that black holes could be gateways to alternate universes or realms, perhaps even beyond our wildest imaginations. This notion forces us to rethink the nature of reality itself, suggesting that the universe is far more complex than our current understanding allows. The allure of black holes lies not only in their ability to reshape our cosmological theories, but also in the profound sense of wonder they inspire. Every new discovery about these mysterious objects opens up fresh avenues of exploration, inviting us to contemplate the infinite possibilities that may exist beyond our observable universe. Black holes ignite a curiosity in the human spirit that is driven by the desire to understand the unseeable, to reach beyond the limits of our knowledge. Equally captivating are the theoretical wormholes, which represent fascinating potential shortcuts through the fabric of space-time. The idea of wormholes offers a tantalizing possibility that they could serve as connections between distant regions of space, or even between different points in time. Picture the universe as an expanding balloon, where the surface represents all of the observable universe. If we were to think of a wormhole as a kind of shortcut, it would be as if 2 points on the balloon were pressed together, creating a bridge between two seemingly distant areas. This conceptualization offers a simpler way to understand how wormholes might function as tunnels through space-time, bypassing the vast distances between distant parts of the cosmos. The concept of the universe's boundary is often tied to the limits of our observational capabilities. places where our understanding and the laws of physics break down. These boundaries could represent the very edge of the observable universe, regions where the known forces of nature cease to operate as we know them. In this context, wormholes suggest a potential means of traversing beyond these boundaries, allowing light and matter to travel to regions that are beyond our present understanding. Such pathways could allow us to explore realms that we once thought to be unreachable, offering a means of bypassing the incredible forces that define the edges of our universe. As we delve deeper into these ideas, the very nature of what constitutes a boundary becomes more fluid. Wormholes raise questions not just about the physical edges of the universe, but also about the larger conceptual boundaries that define reality itself. Could the universe be far more interconnected than we perceive? Could what lies beyond the visible horizon be accessible through these strange cosmic tunnels, revealing regions of space that we have never even dreamed of exploring? Inextricably linked to these mysteries is dark matter, a mysterious and invisible substance that plays a crucial role in the structure of the universe. While we cannot directly observe dark matter, its presence is known through its gravitational effects on the visible matter we can see. Imagine a vast cosmic web, with galaxies like beads strung along invisible threads. These threads are the gravitational influences of dark matter, which holds galaxies together and governs their movement through the universe. Dark matter is also responsible for the observed clustering of galaxies, which tend to group together in specific regions, leaving vast voids in between. This clustering phenomenon is not random, but is a result of dark matter's scaffolding, guiding the formation and evolution of these structures. As we push our observations to the very edge of the universe, dark matter becomes even more crucial in understanding the cosmos. It not only helps us comprehend how galaxies form, but also provides insight into the overall mass of the universe, much of which remains hidden from our detection. The concept of the edge of the universe is deeply tied to dark matter's influence. This invisible substance affects the rate at which the universe is expanding and is a key factor in the phenomenon of accelerated expansion. Current models suggest that the universe is expanding at an increasing rate, a process driven by a mysterious force associated with dark matter. As the universe continues to expand, dark matter provides the gravitational forces necessary to shape the very structure of the cosmos, from the formation of galaxies to the very nature of space itself. Dark matter also plays a pivotal role in reshaping our understanding of the universe's ultimate fate. As the universe's expansion accelerates, it alters the very definition of what we consider to be the universe's edge. Over time, this expansion pushes the limits of the observable universe farther away, fundamentally changing our understanding of space and its boundaries. Dark matter, in its unseen and elusive nature, is a key player in shaping the universe's structure, revealing hidden forces that govern both the known and the unknown. Beyond these forces lies dark energy, the mysterious substance responsible for the accelerating expansion of the universe. Picture the universe as a balloon being inflated, with galaxies moving away from each other as the balloon stretches. Dark energy is like the air filling the balloon, forcing it to expand at an increasingly rapid rate. In the early stages of the universe, gravity was the primary force, pulling matter together and slowing the rate of expansion. But as time passed, scientists discovered that the expansion of the universe was not slowing down, but speeding up. This led to the discovery of dark energy, which provides the negative pressure necessary to counteract gravity's pull. Dark energy seems to permeate all of space, influencing the universe at the grandest scales. Unlike matter, which clumps together, dark energy has a uniform, pervasive presence that causes the universe to expand more quickly. This effect is especially pronounced at the largest scales of the cosmos, where the expansion is no longer being resisted by gravity. As a result, while galaxies continue to interact with each other under the influence of gravity, the overall effect of dark energy is to push them farther apart, altering the very fabric of the universe. This accelerating expansion, driven by dark energy, raises profound questions about the future of the universe. If the rate of expansion continues to increase, distant galaxies will eventually move beyond our observational reach. These galaxies, now moving away faster than the speed of light due to the expansion of space itself, will become invisible to us. As the universe continues to stretch and evolve, dark energy creates a dynamic landscape where portions of the universe slip out of view, rendering them forever inaccessible to our observations. Thus, the study of dark energy is essential not only for understanding the universe's past and present, but also for determining its ultimate fate. As the universe continues to expand at an accelerating rate, the role of dark energy in shaping its future cannot be overstated. What lies beyond the boundaries of what we can see, beyond the edge of the universe, is an open question, one that dark energy may help to illuminate, offering a glimpse into the unknown regions of the cosmos that remain forever out of our reach. Moreover, if dark energy continues to behave as it currently does, it could set the stage for a future where the universe stretches so thin that the vast majority of galaxies we observe today may drift away, eventually disappearing into the distant, isolated reaches of space. As these galaxies move farther apart, they will become increasingly invisible, lost in the vast expanse of an ever-expanding cosmos. This scenario prompts a cascade of intriguing questions about the true nature of our universe, questioning what lies in the regions of space we simply cannot access or observe. Essentially, dark energy is not only a force shaping the present structure of the universe, but also a key player in unlocking the mysteries of the future. As it accelerates the expansion of space itself, it hints at regions beyond our sight, those endlessly distant realms that may remain forever out of reach. Dark energy challenges our conventional understanding of the cosmos, raising profound questions about its long-term fate. What will happen when these galaxies, these cosmic islands, become forever separated from one another? What, if anything, lies beyond the observable universe? The exploration of dark matter and dark energy has fundamentally transformed our understanding of the universe's structure, pushing the boundaries of what we can even conceive. Dark matter, for instance, is an invisible substance that neither emits, absorbs, nor reflects light, making it almost impossible to detect through traditional means. Despite its elusiveness, scientists have deduced its existence by studying its gravitational effects on visible matter, such as galaxies. Dark matter's unseen mass acts as an invisible glue, binding galaxies together and explaining why they spin at velocities that would otherwise cause them to disintegrate. Without dark matter, our models of galaxy formation and motion would collapse, leaving us with an incomplete picture of the cosmos. On the other hand, dark energy is an even more enigmatic force, one that drives the acceleration of the universe's expansion. Initially, astronomers expected gravity to slow this expansion, eventually halting it and pulling everything back together. However, as observations have shown, not only is the universe expanding, but its expansion is actually accelerating. Dark energy is theorized to be the driving force behind this accelerated expansion, and it makes up a significant portion of the universe's total energy content. These discoveries have forced scientists to rethink the very nature of the universe, challenging the notion of an eternal static cosmos and instead suggesting that it has a dynamic destiny. The interplay between the gravitational effects of dark matter and the repulsive force of dark energy suggests that the universe's fate may not be predetermined. Will it continue to expand indefinitely? Will it eventually slow down or collapse? These are questions that could alter our understanding of the universe's ultimate trajectory. The forces of dark matter and dark energy have led to a shift in how we perceive the cosmos, not as a static, predictable entity, but as a dynamic system governed by invisible and mysterious forces that shape its past, present, and future. In this ever-expanding universe, dark matter and dark energy have reshaped our conceptual models, transforming them from simplistic, observable views of the cosmos to more complex, multi-layered perspectives that include unseen, invisible forces. The universe is not just vast in size, but also vast in its complexity, filled with forces that challenge our deepest understanding. These forces demand that scientists and philosophers alike reconsider the very boundaries of the cosmos and the ultimate fate of everything that exists within it. Detecting dark matter beyond the observable universe presents significant challenges, both in terms of technology and our current understanding of physics. Dark matter itself is incredibly elusive. It does not interact with light, either by emitting, absorbing, or reflecting it, making it essentially invisible to traditional observational methods. Our telescopes and imaging tools, which are designed to detect light from distant stars and galaxies, are powerless in detecting this mysterious substance. Dark matter's lack of interaction with electromagnetic radiation means it cannot be seen in the traditional sense, rendering any direct observations impossible. But the difficulty doesn't end there. The observable universe is defined by the farthest light we can detect. The light from distant stars, galaxies, and other cosmic objects has taken billions of years to reach us, providing a snapshot of the universe as it was in the distant past. However, the universe extends far beyond this observable horizon, and any matter, including dark matter, that exists beyond this boundary is inaccessible to us. As a result, we are unable to gather direct evidence of dark matter in those regions of the universe that lie beyond our current observational capabilities. Even if we were somehow able to observe regions beyond the observable universe, we would still face the difficulty of distinguishing dark matter from other cosmic phenomena. Dark matter interacts with ordinary matter primarily through gravity, so the most common way to detect it is by observing its gravitational influence on the motion of galaxies and galaxy clusters. However, at such immense distances, the gravitational effects we observe could be caused by a number of different forces. Distinguishing the effects of dark matter from the gravitational influences of other unseen cosmic phenomena is no simple task, especially when the structures of the universe become increasingly complex and less well understood at these great distances. Moreover, our current models of the universe are based on a limited understanding of cosmic evolution. If dark matter behaves differently in regions beyond the observable universe, it may not conform to the predictions laid out by our existing theories. This introduces the possibility that we may be missing vital clues about the true nature and behavior of dark matter simply because our established concepts may not apply to the uncharted territories beyond our observational limits. Research in this area continues as scientists explore new methods to detect and understand dark matter. One promising technique is gravitational lensing, which occurs when the presence of dark matter bends the light from distant objects, distorting their appearance. This effect provides indirect evidence of dark matter's existence. Additionally, particle detectors are being developed to sense any potential interactions between dark matter and ordinary matter. However, the vastness of space, combined with the limitations of our current technology, makes unraveling the mysteries of dark matter beyond the observable universe a monumental challenge. It will require not only advances in our observational tools, but also significant breakthroughs in theoretical physics. The question of the universe's boundaries has long intrigued philosophers, offering a range of interpretations that reflect diverse worldviews. Some view the universe as infinite, stretching endlessly in all directions, much like space itself, which has no observable edges. This perspective aligns with certain Eastern philosophies, such as Buddhism, which teaches that concepts like emptiness suggest that boundaries are ultimately illusory, encouraging a view that transcends physical limitations. In contrast, Western philosophical thought has often entertained the idea that the universe has defined limits. Ancient Greek philosophers like Aristotle conceived of a finite cosmos encased in celestial spheres with Earth at the center. These ideas suggested that the universe was ultimately knowable and its laws could be understood and categorized. As philosophical thought evolved, so did interpretations of the universe. Enlightenment thinkers began to connect the cosmos to mathematical reasoning, seeing its boundaries not as physical barriers but as concepts to explore. In this view, the vastness of space became a symbol of human curiosity and intellectual pursuit. Modern philosophy continues to explore these ideas, sometimes merging with the field of physics. Some scholars suggest that our understanding of the universe may not only reflect its physical limits, but also the limits of human cognition itself. This perspective raises profound questions. Do boundaries truly exist, or are they constructs of human thought, shaped by our cultural contexts and advances in knowledge? As we delve deeper into the mysteries of the universe, these questions continue to challenge our perception of reality itself. The philosophical inquiry into the boundaries of the universe compels us not only to reflect on the nature of the cosmos, but also to examine our place within it. The limits of our understanding and the infinite possibilities that lie just beyond our reach provoke a profound sense of wonder. This ongoing dialogue reshapes the way we perceive reality, continuously expanding the frontiers of what we consider to be the universe itself. When we contemplate the edge of the universe, we are not just exploring a scientific concept, but engaging with profound existential questions that challenge the very essence of our existence. At the core of this contemplation lies a fundamental question. Does the universe have an end, or does it stretch on infinitely in every direction? This question goes beyond mere curiosity about the physical world. It forces us to question our significance within this seemingly boundless expanse. If we exist in only a small corner of an infinite cosmos, what does that say about our value as individuals and as a species? What role do we play in the vast theater of existence, and how do we reconcile our apparent insignificance with the grandeur of the universe? Another layer of inquiry delves into the very origins of the universe. How did everything we know come into being? Are there limits to our perceptions of reality, or could there be realms of existence that are far beyond our current capacity to perceive or understand? This question stretches into the realm of possibility. What lies beyond the boundaries of human exploration? Could there be other forms of consciousness or civilizations hidden in the folds of the cosmos? Are we the only beings in the universe capable of pondering our existence, or are there others out there grappling with similar existential questions? Time, too, plays an essential role in this contemplation of the universe's edge. When we think about the cosmos, we must consider not only how it began, but also how it might end. Understanding the beginning and potential demise of everything we know can evoke feelings of vulnerability and awe. Are we meant to search for knowledge about the universe's final fate, or is it something beyond our comprehension? These questions expose the limits of human knowledge, emphasizing the mysteries that remain just outside our reach. This journey into the unknown is not just about expanding our understanding of the physical universe, but also about challenging our very conception of what it means to be alive in a cosmos that is as expansive as it is enigmatic. The search for answers to these existential questions forces us to confront the limits of our intellect, pushing the boundaries of human curiosity in ways that we may never have imagined. Ultimately, these questions remind us that in the grand narrative of existence, it is our curiosity, the desire to know more, that connects us to the universe itself. The concept of the universe's edge has evolved dramatically over centuries, reflecting the changing tides of our understanding of astronomy and physics. In ancient times, many cultures held the belief in a flat Earth surrounded by a dome-like sky. This worldview, based on direct observations of the horizon, suggested a finite universe with clear boundaries. The idea of a cosmic sphere wherein the stars were fixed within a celestial dome dominated the thinking of the time. This perspective was most famously articulated by thinkers like Aristotle, who posited a spherical Earth at the center of the universe. As time passed, our understanding of the cosmos expanded. During the Renaissance, groundbreaking astronomers like Copernicus and Galileo challenged the geocentric model, revealing that the Earth was not the center of the universe, but instead orbited the Sun. This heliocentric model expanded the scope of inquiry, sparking a flood of questions about the nature of the universe itself. Could the cosmos be larger than previously imagined? Were there realms beyond the stars we could see? These questions laid the groundwork for an evolving understanding of the universe as something vast, mysterious, and largely unexplored. By the early 20th century, the discovery that the universe was expanding revolutionized our understanding of the cosmos. Astronomer Edwin Hubble observed galaxies moving away from us, suggesting that the universe did not have an edge in the traditional sense. Instead, the boundary we observe is merely the limit of what we can see, the observable universe. Beyond this boundary lies an unknown expanse, potentially containing more galaxies and cosmic structures, perhaps extending infinitely. In contemporary cosmology, the notion of an absolute edge to the universe has been replaced by more complex and speculative theories. Some models propose that the universe could be curved, suggesting that if you were to travel far enough in one direction, you might eventually return to your starting point, much like a journey across the surface of a sphere. Other theories suggest the existence of multiple or parallel universes, further complicating the concept of an outer boundary. These modern ideas illustrate just how far our understanding of the universe has come from the simplistic, ancient images of a dome-covered Earth. As humanity has evolved, so too has our understanding of the universe's edge. What began as simplistic conceptions of a domed sky has grown into profound questions about the nature of infinity, existence, and reality. Each step in this intellectual journey not only expands our knowledge of the cosmos, but also reveals the limitless horizons of human curiosity. It is this curiosity, the relentless desire to understand the unknown, that drives our exploration of the universe, urging us to uncover its secrets and challenge the boundaries of what we know. Human curiosity, the driving force behind our quest for knowledge, has been the catalyst for some of the most remarkable advancements in science and technology. From the earliest days when we gazed at the stars in wonder, dreaming about the world beyond, curiosity sparked a desire to explore and understand. This desire propelled us into space exploration, pushing us further into the vast unknown than ever before. It also motivates scientists to investigate the fundamental laws of nature. Whether observing the behavior of black holes, studying the vastness of galaxies, or investigating the mysteries of dark matter, this insatiable curiosity compels researchers to develop new theories, conduct experiments, and design missions to uncover the universe's secrets. Curiosity does not remain confined to the realm of scientists. It resonates deeply with people from all walks of life, inspiring artists, writers, and dreamers. The wonders of the cosmos have sparked cultural and philosophical reflections that enhance our understanding of what it means to be human. This connection transforms the quest for knowledge from a purely scientific endeavor into a shared human experience, one that binds us together in the pursuit of the infinite. It is in this collective search for answers that we find common ground, as each of us seeks to understand our place in a universe that may be far greater and more mysterious than we can imagine. As we continue to probe the boundaries of the universe, curiosity leads us into the unknown. Whether it is exploring the possibility of other life forms, understanding dark energy, or contemplating the ultimate fate of the cosmos, each step forward represents a new chapter in the ongoing human quest for knowledge. This pursuit is not just about uncovering the secrets of the universe, it is also about understanding ourselves in relation to that vast cosmic tapestry. Through curiosity, we bridge the gap between imagination and reality, reshaping our role in the grand narrative of existence. The very concept of the universe's edge challenges our understanding of boundaries and infinity. Rather than envisioning a solid, finite limit, the edge of the universe can be thought of as a constantly shifting horizon, a concept that is as elusive as it is profound. Imagine standing on a beach, gazing out at the ocean. You can only see so far before the water meets the sky. Yet, you know that the ocean stretches far beyond what your eyes can perceive. In the same way, the universe appears vast, yet it may be even larger or perhaps unending. This idea pushes us to rethink our perception of the universe, encouraging us to consider the vastness beyond what we can observe. Just as ancient explorers once believed that the world ended at the horizon, we too may see the universe as having a limit, one defined by the edges of our current knowledge. As our understanding of the universe deepens, we come to realize that the boundaries of human knowledge are shaped not by the cosmos itself, but by our limited perspective and the technology at our disposal. While we once believed that the universe had defined edges, our growing advancements in science and technology have shown us that these perceived limits are merely products of our own tools and viewpoint. This ever-evolving quest to comprehend the cosmos is not just about answering questions. Rather, each discovery opens the door to new mysteries, propelling us forward in an endless pursuit of understanding. The relationship between our perception of the universe and our exploration of it is inherently connected. The more we learn, the more we realize how much there is yet to uncover. This cycle of revelation and inquiry reflects the boundless curiosity at the heart of human nature. Every breakthrough encourages us to look beyond what we thought we understood, revealing a vast universe teeming with possibilities and challenges. These discoveries push the limits of our imagination, forcing us to reconsider everything we thought we knew about space, time, and our place within it. In contemplating the farthest reaches of the cosmos, we are not just tracing the limits of the universe. We are also recognizing the limitless potential of human thought and exploration. One of the most significant factors driving this exploration is the advancements in telescope technology, which have dramatically transformed our ability to study the cosmos. In the past, astronomers had to rely on basic optical telescopes that collected a limited amount of light. These simple instruments provided only a fleeting glimpse of the universe, restricting our understanding of the vastness beyond. However, with the advent of modern technology, both ground-based and space-based telescopes have greatly enhanced our capacity to peer into the deepest corners of space. The most notable breakthroughs in this field have been the development of larger mirrors and more sophisticated lens designs. These new telescopes can capture much more light, allowing us to see far-off objects that were once invisible to the naked eye. This capability extends our reach into the farthest corners of the universe, allowing us to study ancient galaxies that formed just after the Big Bang. By observing these distant galaxies, we can gain valuable insights into how the universe has evolved over billions of years. Moreover, innovations in infrared and radio wave detection have opened new windows into space. These technologies allow us to observe objects that do not emit visible light, unveiling hidden aspects of the universe that were previously obscured. For example, we can now observe the birth of stars within dense dust clouds, or detect the elusive presence of dark matter woven into the structures of galaxies. Such discoveries have not only expanded our understanding of cosmic phenomena, but have also provided crucial evidence to support theories about the universe's ongoing expansion and its overall shape. The development of adaptive optics, which compensates for atmospheric turbulence, has further enhanced the clarity of images taken from Earth-based telescopes. With this technology, ground-based instruments can now produce images with greater sharpness and detail than ever before. In parallel, space telescopes like the Hubble Space Telescope offer unparalleled resolution by avoiding the distortions caused by Earth's atmosphere. These instruments capture stunning images of galaxies, nebulae, and other celestial bodies, allowing scientists to piece together a more detailed history of the universe. Each of these innovations has dramatically expanded our comprehension of the universe's boundaries, not only revealing objects and phenomena beyond our previous reach, but also enriching our understanding of the cosmos's structure and future. As scientists push the frontiers of discovery, each new finding inspires more questions, challenging our conceptions about the universe and our place within it. Every observation sparks a renewed sense of wonder, emphasizing that the pursuit of knowledge is as boundless as the universe itself. Space missions have played a crucial role in this ongoing exploration, serving as our eyes and ears in the vast expanse of the cosmos. These missions allow us to collect data from regions of space that are simply inaccessible from Earth. By traveling millions or even billions of miles, spacecraft reach distant parts of the universe, gathering valuable information about celestial bodies and cosmic phenomena that would otherwise remain beyond our grasp. These missions provide insights into distant planets, asteroids, and comets, offering a deeper understanding of the origins and evolution of our own solar system. Spacecraft venturing beyond the outer planets and even into interstellar space provide vital information about the forces that govern the universe. They help scientists explore fundamental mysteries such as dark matter, black holes, and the potential for life on other worlds. One of the most significant contributions of space missions has been the ability to observe the expansion of the universe itself. Missions like the Hubble Space Telescope have revealed galaxies that were previously hidden, giving us a clearer picture of the universe's evolution. In addition to their scientific value, space missions inspire the public, particularly the next generation of scientists, engineers, and explorers. The very act of reaching out into the unknown sparks curiosity and wonder, reminding us that the universe is not a static backdrop, but a dynamic, ever-expanding frontier for discovery. Each mission is a step forward in human understanding, reigniting our fascination with what lies beyond the stars. Looking ahead, new technologies promise to take our exploration of the universe even further. One of the most promising advancements is in the design of next-generation telescopes. These instruments will be far more sensitive than their predecessors, able to capture light from galaxies billions of light years away. With these tools, scientists will be able to look deeper into space than ever before, uncovering new celestial bodies and phenomena that have remained hidden from our current view. This will provide a more detailed understanding of the universe's early stages and its future evolution. At the same time, advancements in spacecraft technology are pushing the boundaries of space exploration. New spacecraft will be equipped with cutting-edge instruments capable of reaching previously inaccessible regions of space. These crafts will be designed to travel beyond the solar system, exploring distant cosmic landscapes with unprecedented detail. As they journey through the vastness of space, these missions will gather critical data on the formation of galaxies, the origins of the universe, and the forces that drive its expansion. Artificial intelligence is also set to play a pivotal role in future space exploration. With AI's ability to analyze vast amounts of data quickly and accurately, researchers can process the enormous volumes of information collected by telescopes and spacecraft more efficiently than ever before. AI can identify patterns and anomalies that might be missed by human observers, leading to groundbreaking discoveries about the universe's structure and evolution. This technology has the potential to revolutionize the way we explore the cosmos, bringing us closer to answering some of the most profound questions about the nature of the universe and our place within it. As we continue to push the boundaries of our exploration and understanding, the universe continues to reveal its secrets. With every new discovery, we are reminded that the quest for knowledge is limitless, and the cosmos is far from being fully understood. It is a journey that will continue for as long as we look to the stars, always seeking, always questioning, and always expanding the horizon of human knowledge. Moreover, collaboration among international space agencies has become increasingly common in recent years, with organizations pooling resources and knowledge to work on joint missions that can tackle some of the most ambitious projects humanity has ever set its sights on. By combining their efforts, space agencies are now able to send probes to far-flung celestial phenomena, analyze light from the universe's first stars, and unlock mysteries that were once beyond our reach. These collective advancements in technology, exploration, and interagency cooperation form the backbone of a promising future, one where the boundaries of the known universe are pushed further, and mysteries that have long eluded our understanding are finally unraveled. As we stand at the precipice of this new era, the coming years hold the potential for profound discoveries that could reshape not only our understanding of the cosmos, but the very nature of existence itself. Among the most exciting developments in this field is the rise of quantum computing, a technology that holds the promise of revolutionizing our exploration of the universe, particularly at its edge, where traditional methods struggle to keep up. To put it into perspective, imagine our current computers as classic tools working to solve a massive jigsaw puzzle, each piece scattered across a vast table. These machines can work through the pieces one by one, but the process is slow and inefficient. In contrast, quantum computers are akin to a team of tiny helpers working in parallel, each examining multiple pieces at once, dramatically speeding up the process. At the universe's edge, scientists are grappling with some of the most intricate and complex problems known to science. These challenges include the elusive nature of dark matter, an invisible substance that accounts for a substantial portion of the universe's mass, yet has never been directly observed. The behavior of particles under extreme conditions, far beyond what traditional physics can explain, also poses a great mystery. Quantum computing, with its ability to process vast quantities of data and simulate intricate systems, stands poised to offer solutions to these problems in ways that classical computers simply cannot match. By handling uncertainty and probabilities, quantum computers could unlock deeper insights into cosmic events, such as the mysterious behavior of black holes or the expansion of space itself. Imagine being able to crunch numbers and solve equations on a scale once thought impossible. With quantum computing, researchers could venture into uncharted territories, exploring the universe's edge with a level of precision and speed that was previously out of reach. These powerful machines could lead to breakthroughs that not only clarify the mysteries of the cosmos, but also challenge our fundamental understanding of reality. As quantum technology continues to evolve, it could reveal truths about the universe that were once unimaginable, shedding light on the farthest reaches of space and making the seemingly unreachable both comprehensible and attainable. Recent discoveries made by astronomers have already begun to challenge our understanding of the observable universe. One of the most unexpected revelations comes from the study of galaxies that existed when the universe was still in its infancy, only a fraction of its current age. Research has shown that some of these ancient galaxies were forming stars at a remarkable rate, far exceeding what was previously thought to be possible. This finding suggests that galaxies might mature and evolve much faster than current models predict, forcing scientists to reconsider long-held assumptions about cosmic evolution. Another breakthrough comes from the use of advanced telescopes, particularly those designed to capture images in wavelengths outside the visible spectrum, such as infrared light. These telescopes have revealed distant cosmic objects, including galaxies and quasars, that existed when the universe was still young. This discovery pushes the boundaries of our observable universe, suggesting that there may be far more galaxies waiting to be discovered, galaxies that could challenge our understanding of the early universe and its development. The detection of gravitational waves has also opened a new window to observe the universe, enabling scientists to gather insights into cosmic events that were once beyond our reach. Gravitational waves are ripples in space-time caused by massive cosmic events, such as the collision of black holes or neutron stars. By studying these waves, researchers are able to peer deeper into the past, uncovering events that shaped the evolution of the universe. This technology has provided us with a way to observe the cosmos that is far more nuanced and profound than traditional telescopes could ever achieve. Together, these findings paint a picture of a universe far larger, more complex, and more dynamic than we once imagined. They suggest that there are still many fundamental aspects of the cosmos that we do not yet understand, prompting scientists to rethink some of the core theories in cosmology. With every discovery, we are not merely peering further into space. We are fundamentally altering our understanding of how the universe has evolved over time and how it continues to evolve today. As humanity moves closer to unlocking the mysteries of the universe's edge, we are likely to encounter profound challenges that could completely redefine our place in the cosmos. Perhaps the most compelling question is the nature of the universe's expansion. Observations have shown that galaxies are drifting apart at an ever-accelerating rate, hinting at the presence of a mysterious force, dark energy, that drives this cosmic acceleration. Dark energy, which makes up a significant portion of the universe, remains one of the most elusive and enigmatic phenomena in modern science. Its exact properties are still unknown, and its influence on the fabric of the cosmos is a subject of intense debate. Exploring the edge of the universe could also provide us with a deeper understanding of the true nature of space and time itself. Current scientific theories suggest that space is not merely an empty void, but a complex and dynamic structure that could be influenced by hidden dimensions or alternative realities. If we could gather more data from the farthest reaches of the observable universe, we might be able to uncover clues about these dimensions and how they relate to the formation of the universe. Furthermore, the study of the universe's edge might eventually lead us to discover new forms of life. As we continue to find exoplanets, planets that orbit stars outside our solar system, and analyze their atmospheres, the possibility of extraterrestrial civilizations becomes ever more tantalizing. If we explore regions of space where conditions are vastly different from those on Earth, we may uncover environments that harbor life forms unlike anything we can currently imagine, expanding our concept of what constitutes life. The edge of the universe may also hold the key to understanding the history of the cosmos itself. By studying ancient light that has traveled across space for billions of years, we can gain insights into the origins of galaxies, stars, and planets. This ancient light, sometimes referred to as the cosmic microwave background radiation, provides us with a snapshot of the universe as it was when it was just a few 100,000 years old. Understanding this early history could help us understand how the elements that make up our world were forged in the cores of stars, and how the universe's grand narrative unfolded. As we push the boundaries of what is currently accessible, the mysteries that await us at the edge of the universe promise to reshape our understanding of everything we know. By exploring these mysteries, we stand to gain a deeper understanding of dark energy, the true structure of space and time, the potential for life beyond Earth, and the cosmic events that shaped our existence. These discoveries may not only redefine our place in the cosmos, but also challenge the very essence of what it means to be human in the grand scheme of the universe. The search for extraterrestrial life, in particular, often draws scientists' attention to the vastness of the universe, especially its boundaries. To truly grasp this connection, we must first understand that the universe is not a static, homogeneous entity, but rather a vast expanse filled with countless stars, planets, and potential habitats for life. Some researchers believe that life beyond Earth may exist on distant exoplanets, planets that orbit stars far outside our solar system. Many of these exoplanets lie in regions far from our current observational reach, but the possibility that life exists there continues to spark excitement among scientists. When we refer to the edge of the universe, we are talking about the limits of what we can currently observe. The universe is expanding, with galaxies moving further apart from each other at an accelerating rate. This creates a boundary beyond which we cannot see, not because there is a physical edge, but due to the speed of light and the finite age of the universe. Beyond this observable limit, there could be vast regions that harbor planets capable of supporting life, planets that we simply cannot study at this moment due to our technological limitations. The search for extraterrestrial life often revolves around finding exoplanets located in habitable zones around stars, regions where conditions might allow liquid water to exist, and by extension, life as we know it. As we continue to explore the edges of the observable universe, astronomers hope to uncover new galaxies and planetary systems that differ from our own, expanding the possibilities of where life might exist and what it might look like. The further we venture, the more we realize just how much is still out there, waiting to be discovered. Moreover, studying the edge of the universe provides us with an unparalleled opportunity to unlock the secrets of its origins and ongoing evolution. By examining the universe's early stages and its continuous expansion, we stand on the precipice of revealing clues about the environments that may have once nurtured life. This pursuit, in turn, is intricately tied to our most profound question: are we alone in the cosmos? The search for extraterrestrial life does not stop at our immediate cosmic neighborhood. In fact, by investigating the far reaches of the universe, scientists aim to glimpse possibilities and conditions that stretch far beyond our current grasp, deepening our understanding of life's potential across the ever-expanding fabric of space. At what we consider the boundary of the universe, the phenomena that emerge can radically challenge the very foundations of our understanding of physics. Picture yourself standing at the edge of an unimaginable expanse, where light from countless stars and galaxies has traveled through the void for billions of years to finally reach us. In this extraordinary place, unexpected bursts of energy might appear before your eyes, such as cosmic rays, particles of the highest energy, shooting through space at almost incomprehensible speeds. These rays could have originated from distant supernovae or from enigmatic cosmic entities that remain beyond our understanding. Even more intriguing, there exists a peculiar phenomenon known as the cosmic microwave background radiation. This faint yet persistent glow is a remnant of the Big Bang, offering us a rare glimpse into the universe's infancy. However, this radiation is far from being uniform. It shows tiny, irregular fluctuations, offering clues about the seeds of all the structures we see today, galaxies, clusters, and the vast web of the cosmos that emerged over time. At the universe's edge, the very fabric of space itself undergoes dramatic shifts, yielding strange effects. Galaxies and clusters of galaxies are moving away from us at staggering speeds, so fast, in fact, that the light from some of them can barely reach our telescopes. This results in a phenomenon called redshift, where the wavelengths of light stretch and shift, moving from blue tones to deep reds. Observing this, we find ourselves pondering the universe's ultimate fate. Will it expand forever, slowing down and then speeding up again, or will it eventually collapse in on itself? With every discovery, new questions arise, further extending the horizon of what we know about the cosmos. Among the most profound potential discoveries at the universe's edge is the possibility of new forms of matter. Currently, we categorize matter into familiar substances such as solids, liquids, and gases. Yet, most of what we encounter in the universe is composed of exotic matter, such as plasma. But what if there are forms of matter yet to be imagined? Ones that behave in ways beyond our comprehension? Imagine a substance that could remain stable under extreme conditions or interact in entirely new ways with the forces that govern the universe. Such a discovery would not only challenge our current models of matter and its behavior, but also radically alter our understanding of how matter behaves in extreme environments, such as the cold void of space or near the immense gravitational forces of black holes. Furthermore, uncovering new forms of matter could unlock secrets about some of the universe's greatest mysteries, including dark matter and dark energy. These two phenomena make up most of the universe's mass and energy, yet remain frustratingly elusive. If this new matter interacts with gravity or electromagnetism in ways we have yet to understand, it could explain the peculiar behavior of galaxies and shed light on why the expansion of the universe is accelerating. Beyond this, such discoveries could revolutionize technology, offering new ways to explore space, generate energy, and even travel vast distances. A breakthrough in our understanding of matter could also spark advancements on Earth, leading to entirely new technologies. We could discover ways to create more efficient energy systems, improving renewable energy sources like solar power. By studying extreme environments in space, such as those around black holes or neutron stars, we might develop materials capable of withstanding harsh conditions on Earth. These could include stronger, lighter materials for buildings, vehicles, or everyday electronics. Additionally, advancements in communication technologies could arise from the study of cosmic phenomena. The technology used to study gravitational waves or pulses from distant stars could inspire improvements in our global communications networks, making them faster and more reliable. Furthermore, understanding how to survive in the hostile environments of extraterrestrial worlds could lead to innovations in life support systems and sustainability technologies that we could apply to our own planet. New methods of resource management, water purification, and waste recycling could emerge from these studies, benefiting life on Earth. In a broader sense, discovering new planets or even evidence of extraterrestrial life could profoundly shift our perspective on humanity's place in the cosmos. This sense of connection to the broader universe might inspire a newfound sense of unity, pushing us to work together to address global challenges such as climate change and environmental degradation. As we learn more about the possibilities for life elsewhere, we may also develop a deeper sense of responsibility for the health and well-being of our own planet. The mysteries lying at the edge of the universe offer far more than just scientific knowledge. They hold the potential to transform our daily lives in ways we might not yet fully comprehend. Every new discovery is a door to uncharted territories that could reshape how we live, work, and understand our place in the universe. Imagine the universe as a vast, boundless ocean stretching out into infinity. Now envision the boundary that surrounds this ocean as something entirely different, an enigmatic realm filled with possibilities beyond our wildest dreams. Beyond the observable universe, some scientists suggest that there may be regions governed by entirely different physical laws, where conditions unfold in ways we cannot even begin to imagine. This notion opens the door to the idea of the multiverse, a collection of universes, each with its own unique set of rules. In this scenario, one universe might have a stronger force of gravity, while another could have different particles or forces altogether. Some universes might even give rise to completely different structures unknown to us in our own reality. Another fascinating possibility lies in the realm beyond our universe, an area of chaotic energy where the rules of time, as we understand them, might break down or become entirely irrelevant. This space might resemble an unstable void, a place where new universes are born through fluctuations, like bubbles forming in boiling water, constantly expanding and bursting into new realms of reality. These regions could represent the birthplace of other universes, each with its own laws and possibilities, leading to outcomes that are radically different from the universe we call home. As we venture into the depths of these uncharted territories, the mysteries at the universe's edge challenge not only our understanding of the cosmos, but also our very conception of existence itself. With each discovery, we step closer to answering questions that have baffled humanity for millennia. Questions about the nature of reality, the origins of life, and our place in this vast and expanding universe. The quest to explore the edge of the universe promises not only to unveil the secrets of space, but also to expand the frontiers of human knowledge and possibility, changing the way we see ourselves and the cosmos. Some theories suggest that the boundaries of our universe may not be static, but could evolve over time, potentially giving rise to entirely new forms of matter or energy that are currently beyond our comprehension. If such conditions truly exist, they would be radically alien to the ways we understand the cosmos, unlocking discoveries that might unfold in directions we've never before imagined. The very act of exploring what lies beyond the universe challenges the limits of human imagination, forcing us to confront and question the foundational principles of existence itself. While many of these ideas remain speculative, they still offer us a tantalizing glimpse into the unknown, pushing the edges of our understanding further than ever before. What might be waiting just beyond the reaches of our knowledge? Could there be possibilities we've yet to even dream of? At the heart of modern cosmology is the concept of space-time, an idea that combines the three dimensions of space with the dimension of time into one unified framework. Imagine space-time as a fabric, stretching and warping, responding dynamically to the matter and energy it contains. This framework is not just a theoretical abstraction, but a vital lens through which we can examine the structure of the universe, especially when considering its boundaries or edges. According to established scientific theories, the universe is far more than a vast collection of stars, planets, and galaxies. It is a dynamic, ever-expanding entity, and the very expansion of the universe itself creates a complex relationship between space and time. To illustrate, think of the universe's expansion like the surface of a balloon. As the balloon inflates, the surface stretches, causing points that were once close together to move farther apart. In this way, the edge of the universe isn't a fixed point. It's a moving frontier, influenced by the very fabric of space-time surrounding it. The idea of space-time also helps explain how gravity works. Massive objects like stars and planets create indentations in this fabric, bending it and pulling other objects toward them. In a similar way, the expansion of the universe influences how distant galaxies move, causing them to drift away from one another. This connection between space-time and the expansion of the universe is crucial for understanding the fate of our cosmos. Will it continue to expand forever, slow down, or eventually collapse in on itself? Space-time is not merely a backdrop to cosmic events, but an active participant that shapes the universe's geometry and evolution. By studying how space-time interacts with the universe's expansion and boundaries, we gain deeper insights into its origins, its structure, and its ultimate fate. As we explore this interplay between space and time, we not only seek to understand where the universe's boundaries may lie, but also the mysteries that could exist just beyond them. The edge of the universe remains one of the most compelling and mysterious concepts in modern science. It sparks curiosity and awe, leading to a number of imaginative theories. One of the most captivating ideas is the possibility that the universe itself could be curved, meaning that it may not have a definitive boundary in the traditional sense. Rather than an edge that marks the limit of all that exists, the universe could, in fact, be like a sphere. If you were to travel far enough in one direction, you might find yourself returning to your starting point, much like walking around the surface of a globe. In this model, the universe's boundary would be illusory, a concept that challenges our usual understanding of space and suggests that there might not be an outside at all. Another fascinating possibility is the idea of a multiverse. This theory suggests that our universe is just one among many, each potentially governed by its own laws of physics, distinct dimensions, and unique outcomes for cosmic events. If this theory holds true, the edge of our universe could mark the boundary to other realities, each with its own rules and possibilities. The existence of parallel universes would imply an infinite array of alternate realities, where everything we know could exist in myriad forms, with each universe unfolding according to its own cosmic design. Then there's the theory of cosmic inflation, which posits that in the moments following the Big Bang, the universe underwent an incredibly rapid expansion. If this expansion continues, the edge of our universe may not represent a solid boundary, but instead a dynamic frontier where new regions of space and time are continually forming. In this sense, the edge of the universe might not be an end, but rather a place where new matter and energy are constantly being created, a frontier in constant flux. Some scientists have also speculated about the existence of cosmic voids, vast, seemingly empty regions of space. These voids are often seen as the remnants of ancient energy fluctuations that shaped the structure of the cosmos. Exploring these immense, empty regions could provide new insights into the evolution of the universe, offering a deeper understanding of how galaxies, stars, and planets came into being, and how the cosmic landscape continues to evolve. These theories point to the vastness and complexity of the universe, suggesting that the boundaries of our knowledge are not simply physical limits, but mental constructs shaped by our understanding of the cosmos. As scientists continue to study and explore the unknown, our grasp of what lies at the edge of the universe will surely evolve. With every new discovery, we peel back a layer of the intricate tapestry of existence itself, revealing a universe that is far more mysterious and interconnected than we ever imagined. One of the most puzzling and intriguing phenomena in the cosmos is quantum entanglement. At its core, entanglement refers to a situation where pairs of particles become intertwined in such a way that the state of one particle is instantly connected to the state of the other, no matter how far apart they may be. This phenomenon is as if two dancers, separated by vast distances, continue to move in perfect harmony without any visible connection between them. This instantaneous exchange of information seems to defy the limits of our universe, particularly the speed of light, which is often considered the fastest possible speed at which information can travel. If entangled particles can communicate across such vast stretches of space without any observable delay, it suggests that our understanding of space itself may need to be reconsidered. Rather than viewing space as a rigid, absolute separator between objects, we might think of it as something more fluid, like a web of interconnectedness. In this model, the universe could be more intricately connected than we imagine, with boundaries that are not physical walls, but limitations in our perception and understanding. As we continue to explore the mysteries of the cosmos, the nature of the universe's edge and the deeper connections that bind it together remain some of the most profound questions. These challenges push us to rethink our fundamental assumptions about the structure of reality, urging us to look beyond the known and consider the infinite possibilities that lie just beyond the horizon of our understanding. Furthermore, entanglement raises profound questions that stretch our understanding of the very nature of information within the universe. If information can be shared faster than light through quantum entanglement, it challenges the most fundamental concept of causality, the principle that a cause must always precede an effect. As we journey deeper into the enigmatic world of quantum mechanics, we may find that the universe is not merely a collection of isolated entities, but rather an intricate web of interconnections that transcend the conventional boundaries of space and time. This realization could mark the beginning of a monumental shift in how we perceive reality itself, ushering in a new era of scientific inquiry. In this new era, the limits of the known universe could expand infinitely as our understanding grows ever more intricate and interconnected. Abstract mathematical models serve as indispensable instruments in this pursuit, helping to decode the complex language of the cosmos. These models can be thought of as elaborate blueprints composed of mathematical structures that allow scientists to conceptualize the most abstract ideas concerning space, time, and gravity. They provide a framework that translates abstract observations into measurable concepts we can analyze. When we venture beyond the boundaries of our direct observation, these models help us hypothesize about the uncharted territories of the universe, those regions far beyond what our instruments can detect. By using mathematical equations and theoretical constructs, scientists can predict and simulate phenomena like the evolution of galaxies, the behavior of dark matter, and the formation of cosmic structures over vast expanses of time. Through these models, researchers can test how varying conditions might affect the universe's growth or how energy behaves in extreme environments. These mathematical landscapes extend our imagination, enabling predictions of events that occurred in the universe's earliest moments. For instance, they can help us understand the mysterious process of cosmic inflation, a rapid expansion believed to have taken place just after the Big Bang. With the help of these abstract tools, we can anticipate how the universe might behave under different cosmic conditions, pushing the boundaries of our comprehension further into realms still shrouded in mystery. Ultimately, while we cannot physically explore every nook and cranny of the universe, these abstract models serve as our bridge to the unknown. They allow us to extend our grasp into distant regions, guiding us in our quest for knowledge and unveiling the mysteries of reality itself. At the very edge of the universe, we encounter phenomena that challenge and stretch our understanding of space and time. Imagine being in a region where the fabric of the cosmos is thin, much like the horizon where the vast ocean meets the sky. This is not merely a boundary, but a dynamic frontier brimming with possibilities. One of the most captivating features of this region is the presence of cosmic voids, vast, empty expanses in the universe resembling bubbles where very few galaxies can be found. As you journey toward these voids, the gravitational forces become noticeably different, offering a unique opportunity to study the distribution of matter across the cosmos in ways that are otherwise inaccessible. As we approach the edge, we also witness the effects of cosmic expansion. The universe is constantly stretching, and at the farthest reaches, this expansion appears to accelerate. Some of the galaxies located in these distant regions are speeding away from us faster than their closer counterparts, driven by the enigmatic force known as dark energy. This mysterious phenomenon accelerates the expansion of the universe, suggesting that the universe's edge is far more complex than a simple boundary. It is a region of dynamic change and interaction. Gravitational waves, which ripple through space-time like the surface of a pond disturbed by a stone, are also more prevalent near the universe's extreme edges. These waves are generated by massive cosmic events such as the collision of black holes or the merging of neutron stars. As they travel across vast distances, these ripples carry with them invaluable information about the most violent and energetic processes that occur in the universe. In this way, the universe's edge acts as a portal through which we can gain glimpses into some of its most extreme phenomena. The observable universe's edge also opens the door to deeper mysteries that extend beyond our current understanding. Here, the theory of the multiverse suggests that our universe may be but one of many, each with its own unique set of physical laws. At this boundary, the known meets the unknown, and new scientific theories begin to take shape, pushing the limits of exploration further. The edge of the universe is not just a distant point. It is a dynamic and evolving region where voids, expanding galaxies, rippling gravitational waves, and the possibilities of multiverses converge, offering a fascinating glimpse into the nature of existence itself. Among the most intriguing theoretical constructs in this exploration are cosmic strings. These hypothetical entities are believed to have emerged during the earliest moments of the universe, shortly after the Big Bang. Visualize them as long, thin threads stretching across the vast expanse of space. Cosmic strings are remnants of the rapid changes and cooling processes that occurred in the universe's infancy. They could offer vital clues about the universe's boundaries and suggest that our cosmos may not be infinite in the traditional sense, but could instead have edge-like characteristics. When we discuss boundaries in this context, we do not refer to a solid, immovable wall, but rather a shifting, dynamic region where the conventional rules of physics may not apply. Cosmic strings may represent regions of space where matter and energy interact in fundamentally unique ways, potentially influencing the very structure of the universe on a grand scale. They may act like gravitational scaffolding, shaping the formation of galaxies, or drawing matter together, offering insight into the underlying architecture of the universe. The study of cosmic strings is not merely a theoretical pursuit. It also provides an opportunity to rethink the fundamental nature of space and time. They raise profound questions about how the very fabric of the universe is woven, and whether our understanding of the cosmos needs to be reimagined entirely. In studying these enigmatic strings, we are led into deeper inquiries about the structure of the universe itself, questions that not only expand the boundaries of what we know, but also shape the future of scientific exploration. Moreover, if cosmic strings exist, they could offer a groundbreaking explanation for certain features of the cosmic microwave background, CMB, the faint glow left behind by the Big Bang. Observations of this ancient radiation may reveal subtle patterns, traces that could point directly to the influence of these hypothetical cosmic strings. By studying these strings, we gain not only a deeper understanding of the theoretical boundaries of physics, but also access to observable phenomena that bridge the gap between abstract theory and tangible reality. This, in turn, offers a richer, more detailed picture of the universe and its origins. The edge of the observable universe is a boundary defined by the limits of our current technology. It marks the furthest reaches of the cosmos that we can observe, though it is not a physical edge in the traditional sense. At this boundary, scientists encounter phenomena that challenge our current understanding of the universe and provoke new questions about its structure and evolution. One such anomaly is the existence of large-scale cosmic structures, such as enormous voids and galaxy clusters. These vast regions of space, which can span millions of light years, contain significantly fewer galaxies than other areas of the universe. The immense size and apparent uniformity of these structures suggest that the universe's evolution may not be as straightforward as we once believed. Further complicating our understanding are the peculiar irregularities found within the cosmic microwave background radiation itself. These slight fluctuations in temperature, accompanied by an unexpected alignment, hint at processes in the early universe that we have yet to fully comprehend. Such anomalies challenge our assumptions about the symmetry and uniformity of the cosmos at its inception. How did the early universe evolve into the structured, complex cosmos we observe today? What unknown forces may have shaped its development? Another enduring mystery is the nature of dark energy, the enigmatic force thought to be driving the accelerated expansion of the universe. This mysterious energy has eluded direct detection, but is believed to comprise a substantial portion of the universe's total energy content. The influence of dark energy becomes more pronounced as we observe galaxies at the farthest reaches of space, hinting at a cosmic acceleration that defies traditional explanations. What is the true nature of dark energy, and why does it appear to be increasing over time? Moreover, some researchers have detected potential signals or patterns that could indicate the presence of other dimensions or even entire parallel universes, sparking captivating theories about the existence of a multiverse. These hypotheses suggest that our universe may not be the only one. It may be just one of many, each with its own set of physical laws. While still speculative, these ideas push the boundaries of our knowledge and suggest that the cosmos is far more complex than we ever imagined. Each of these anomalies offers a tantalizing glimpse into the mysteries that lie beyond the limits of our observational capabilities. What lies beyond the edge of the observable universe? What hidden forces and dimensions await discovery? As we continue to explore these anomalies, we may uncover new truths that will reshape our entire understanding of the universe. Gamma-ray bursts represent some of the most powerful and energetic explosions observed in the universe. These explosive events, thought to occur in distant galaxies when massive stars collapse or when neutron stars collide, release an extraordinary amount of energy, enough to outshine entire galaxies for brief periods. Despite their fleeting nature, these bursts provide invaluable insight into the structure and evolution of the cosmos. The timing, location, and characteristics of gamma-ray bursts allow astronomers to investigate the underlying processes driving cosmic phenomena and challenge existing theories about the universe's boundaries. The detection of gamma-ray bursts in various regions of the universe suggests that star formation is an ongoing process, even in the farthest reaches of space. This implies that the universe is dynamic, continually evolving rather than static and unchanging. By studying the light emitted by these bursts, scientists can learn about the expansion of the universe itself. As light travels across billions of light years, it is stretched by the expansion of space, a phenomenon known as redshift. By measuring this redshift, astronomers can determine the rate at which the universe is growing and refine our models of cosmic evolution. On an even larger scale, the study of gamma-ray bursts may offer clues about the ultimate fate of the universe. These extreme events, products of massive energy and matter interactions, could provide valuable insights into the behavior of distant regions of space at the universe's outer limits. By understanding these bursts, we deepen our knowledge not only of the mechanisms driving cosmic explosions, but also of the larger forces shaping the future of the cosmos. Supernovae, the spectacular explosions of dying stars, serve as crucial beacons in the study of the universe's boundaries. When a star exhausts its nuclear fuel, it can no longer maintain the internal pressure required to counterbalance its immense gravity. The star then collapses under its own weight, triggering an explosive release of energy. These events are so luminous that they can outshine entire galaxies for a brief period, making them one of the most striking phenomena in the universe. Supernovae are not only visually captivating, they also play an essential role in measuring cosmic distances. Certain types of supernovae, particularly those known as type 2A supernovae, occur when a white dwarf, a remnant of a star, accumulates matter from a companion star until it reaches a critical mass. This triggers a runaway nuclear fusion reaction, producing a consistent luminosity at the peak of the explosion. Astronomers use this predictable brightness as a standard candle, a reference point for gauging distances across the cosmos. By measuring how dim these supernovae appear from Earth, scientists can estimate their distance and, by extension, better understand the scale and expansion of the universe. The study of supernovae has profound implications for understanding the universe's expansion. In the late 20th century, observations of distant Type 2A supernovae revealed an unexpected finding. The universe is not merely expanding, but the expansion is accelerating. This discovery led to the formulation of the dark energy hypothesis, a mysterious force that drives this acceleration. Supernovae thus provide critical data, helping scientists probe the fundamental forces shaping the universe, including its age, structure, and ultimate fate. Beyond their role in measuring distances, supernovae are vital for advancing our knowledge of the universe's dynamics. The energy they release during their explosive events serves as a cosmic probe, allowing researchers to investigate the underlying processes governing stellar death, galactic evolution, and the expansion of space itself. As such, supernovae are indispensable tools in the cosmic toolbox, helping us explore the deepest questions about the universe. Exploring the edge of the universe presents significant challenges, both in terms of technological limitations and our fundamental understanding of the cosmos. First, consider the vast distances involved. The universe is staggeringly enormous, with the closest galaxies being trillions of miles away. Traveling such distances with our current technology would take an unimaginable amount of time, far beyond the lifespan of any human or spacecraft. This means that any mission aiming to venture beyond the observable universe would require spacecraft capable of sustaining human life over incredibly long periods or advanced automation systems, which are still in development. As we push farther into the unknown expanses of the universe, the conditions we face grow more extreme, testing both the limits of our technology and our resolve. Space, with its vast, uncharted reaches, is an unforgiving and hostile environment. Beyond the relative safety of Earth's atmosphere, radiation bombards everything in its path. Temperatures swing to extremes, from the searing heat near stars to the freezing cold of interstellar space. The ever-present danger of micrometeorites punctuating the void further complicates our attempts to explore and understand what lies out there. Creating instruments and technology capable of withstanding such conditions over the course of long journeys is a monumental challenge. It's not just about surviving the harshness of space, it's about making sure that every piece of equipment, every life form, and every system involved can function and endure for years or even centuries. This alone presents a massive hurdle, one that requires innovative engineering and constant adaptability. But the challenges don't end there. As we journey deeper into space, we face a significant issue with communication. The farther we travel, the longer it takes for signals to travel across the void. A simple message or command, which would take milliseconds to send from Earth to a spacecraft in low orbit, takes much longer as the spacecraft moves farther out. With distances growing exponentially, the time delay between sending and receiving information becomes substantial, causing a gap between real-time events and the ability to react quickly. This means that space missions would need to function with an unprecedented level of independence, as crew members and instruments may not have the luxury of waiting for Earth-based guidance. Understanding the very physics that govern the boundaries of the observable universe presents its own set of unique challenges. As we reach the furthest points that we can measure or observe, we begin to encounter phenomena that defy the current models of physics. The enigmatic concepts of dark energy and the mysteries surrounding the accelerated expansion of the universe still puzzle the brightest minds in the scientific community. What we observe at the universe's edge may hold the key to new laws of physics, discoveries that could revolutionize everything we thought we knew about the cosmos. The extreme environments near the boundaries of the universe may also offer us glimpses of entirely new physical principles that are beyond our current comprehension. These frontiers not only present an intellectual challenge, but also provoke profound philosophical questions. As we venture into these unknown realms, we must pause to reflect on the deeper motivations driving us. What do we truly seek from our exploration? Are we prepared for the consequences of what we may discover? Understanding our place in such an overwhelmingly vast cosmos, with its infinite complexity and mystery, adds even more depth to the challenges we face. This journey toward the edge of the universe encapsulates more than just physical distance. It is a pursuit that involves confronting hostile environments, grappling with communication delays, and exploring unknown scientific phenomena. It's a journey marked by awe-inspiring distances, unimaginable conditions, and the continual expansion of both human knowledge and imagination. Yet the need for creativity, innovation, and cutting-edge technology remains paramount to overcoming the hurdles that stand in our way. As we venture into the unknown, digital simulations are emerging as critical tools for exploring the universe's farthest reaches. Imagine trying to map out an ever-changing, sprawling landscape that is both vast and elusive, where many areas remain unseen or unreachable by direct observation. Real-world observations of the cosmos can be incredibly difficult due to the immense distances separating us from distant celestial bodies and the limitations of our current technology. This is where simulations step in as an indispensable tool. Using advanced computational models, scientists can simulate a variety of cosmic phenomena, helping us predict and understand the behavior of galaxies, stars, dark matter, and even the expansion of the universe itself. Through these simulations, researchers can recreate the formation of galaxies, the interactions between celestial bodies, and the complex merging of cosmic structures over billions of years. They can test hypotheses, examine different scenarios, and adjust variables to predict the outcomes of different cosmic conditions. Moreover, these simulations serve as a bridge between theoretical physics and actual observations. When astronomers detect strange signals or witness unusual cosmic events, they can use simulations to explore the potential causes or predict future developments. This feedback loop between real-world observations and virtual modeling allows scientists to refine their theories, gradually enhancing our understanding of the universe one simulation at a time. As technology advances, these simulations will become increasingly sophisticated. With each new advancement, the virtual models will incorporate more data, becoming more detailed and accurate, offering us a clearer and more comprehensive view of the cosmos. In time, these simulations may even lead us to new regions of the universe that have never been explored physically. By virtually navigating the universe, scientists can uncover mysteries that have long remained hidden in the depths of space, illuminating the darkest corners of the cosmos. Exploring the edge of the universe is an alluring prospect, but it is fraught with challenges that stretch the limits of our imagination and technology. The edge of the universe, as it is commonly referred to, is not a solid physical boundary. It is an observable horizon defined by the furthest light that reaches us. This light comes from the early stages of the universe, from a time when the cosmos was still in its infancy, a period known as the dawn of time. Reaching this distant boundary, however, is far from simple. Space itself is not only unfathomably vast, but it is also expanding, and this expansion complicates the idea of traveling toward the edge. As we send probes deeper into space, we are not merely moving toward a stationary destination. We are chasing after a horizon that is itself moving away from us, constantly receding as the universe stretches. This means that any attempt to reach the edge of the observable universe might feel like a pursuit of a mirage, a goal that always seems just out of reach, growing ever more distant as time goes on. Even if we could find a way to send a spacecraft in that direction, the limitations of current technology make such a journey a near impossibility. The fastest spacecraft ever built would take thousands of years just to reach a fraction of the distance to our nearest stars. To travel even further toward the universe's edge, we would need to imagine new propulsion methods, ones that go far beyond what we are currently capable of. Perhaps we could one day harness the energy of stars or even develop theoretical technologies such as warp drives, capable of bending the fabric of space-time itself. Then there's the fundamental question of what we might find at the universe's edge. As we peer deeper into space, we observe galaxies forming, stars igniting, and the aftermath of massive cosmic collisions. Each new discovery enriches our understanding of the universe's history and its ongoing evolution. However, as we venture toward the outermost limits, we may encounter regions where light has yet to reach us, dark, unexplored areas that remain shrouded in mystery. What lies in these regions could change everything we know about the cosmos. Could we uncover traces of ancient civilizations, previously undetected cosmic phenomena, or events that have never been observed by human eyes? The possibilities are limitless, and perhaps one day, with the right technological advancements, we could explore these far-off realms, sending robotic explorers or even humans to witness firsthand the secrets that lie at the very edge of the universe. Such discoveries would be groundbreaking, potentially altering the course of human history. Ultimately, the quest to explore the universe's edge is an endeavor that blends scientific curiosity, boundless ambition, and the indomitable human spirit. As we take each new step into the unknown, we expand not only our understanding of where we are, but also our place within the greater cosmic framework. This relentless pursuit pushes the boundaries of our knowledge, constantly raising new questions and unveiling the wonders that lie in the dark void beyond our current reach. As nations and private organizations move forward in their space explorations, future space policies will play a pivotal role in shaping how we approach the unknown. Clear, well-thought-out regulations will guide the efforts of various groups and foster international collaboration, an essential component in overcoming the monumental challenges of space exploration. When countries work together, pooling their resources and technologies, they can solve problems more effectively and accelerate the pace of discovery. The universe, in all its vastness and mystery, is waiting to be explored. With each new mission, we come closer to uncovering the secrets it holds, and who knows what we might find at the very edge. When humanity looks toward the cosmos, the possibilities are boundless, and the pursuit of knowledge in space becomes an ever-expanding frontier. One of the most fundamental elements in this pursuit is the idea of peaceful exploration, an approach that fosters collaboration and understanding among nations. In a world where borders and politics often divide us, space offers a unique opportunity for unity. By committing to peaceful exploration, we ensure that all nations are respectful of one another's rights and interests in space. This cooperation becomes even more essential as we set our sights on ambitious goals, such as sending missions to the farthest reaches of our solar system, or even venturing beyond into the vast, uncharted territories of interstellar space. The importance of cooperative policies cannot be overstated, especially when considering the profound responsibilities that come with space exploration. These policies must not only encourage collaboration, but also promote sustainable practices that prevent environmental degradation in space. As humanity advances its reach, it becomes crucial to preserve the integrity of space environments, ensuring that they remain safe and viable for future generations of explorers. Sustainable exploration helps protect these celestial frontiers, preserving them as we push further into the unknown. At the heart of these efforts lies investment in technology. Strong, supportive policies are the catalyst for innovation, unlocking advancements that make exploration possible. As the boundaries of the universe unfold before us, the need for advanced spacecraft, cutting-edge technology, and state-of-the-art tools becomes ever more critical. Government funding and scientific research often drive this innovation, enabling the creation of the next generation of space exploration instruments. With strategic investments in research and development, groundbreaking discoveries become more accessible, allowing us to push the frontiers of our knowledge about distant galaxies, the nature of space, and even the very fabric of the cosmos. Equally important is public engagement, ensuring that space exploration is not confined to a select few, but is shared with the world. Educating and inspiring the public through outreach programs and educational initiatives is a crucial part of the process. Policies that foster interest and awareness in space exploration have the power to inspire the next generation of scientists, engineers, and visionaries. As more people become deeply invested in space science, the momentum for exploration grows, driving us further into the unknown. Every decision made, whether it focuses on international collaboration, sustainability, technological advancement, or public outreach, helps shape the path forward in our ongoing journey through the cosmos. International cooperation is a cornerstone of space exploration. By joining forces, nations can bring their unique strengths, resources, and expertise to the table, creating a synergy that accelerates progress. Space exploration is a global endeavor, and just as scientific knowledge is cumulative, the collaboration between scientists from different nations builds on itself, creating an ever-expanding pool of understanding. By sharing data, resources, and ideas, countries can make faster advancements and develop more innovative solutions to the complex challenges of space. Space missions, by their very nature, are costly and complex. The financial burden of these undertakings can be overwhelming, but by pooling resources and expertise, countries can fund larger, more ambitious projects. The result is a collaborative effort that makes what was once impossible, possible. A prime example of this is the International Space Station, ISS, a magnificent symbol of cooperation where multiple nations contribute to the infrastructure, research, and daily operations in low Earth orbit. The ISS not only serves as a launch pad for scientific discovery, but also strengthens political and cultural ties between countries. Working together in space exploration also brings with it a diversity of perspectives. Different cultural backgrounds and worldviews lead to varied approaches to scientific inquiry, and this diversity enriches the entire exploration process. When designing a mission to explore a distant planet, for example, differing ideas about what constitutes valuable data can help shape a more comprehensive and well-rounded mission plan. Through this international cooperation, humanity can tackle the vastness of space as a united front, maximizing the potential for discovery and innovation. Central to our understanding of the universe is the study of its origins. The quest to understand how the cosmos began is deeply connected to our exploration of its outer limits. Scientists tirelessly investigate the earliest moments after the Big Bang, seeking to understand how the universe transformed from a hot, dense state into the vast and complex entity we observe today. By exploring the origins of the universe, we can also begin to understand its evolution, from the formation of the first galaxies to the birth of stars and planets. This understanding offers valuable insights into how the universe works and what the future may hold. But the search for cosmic knowledge extends beyond the past. It reaches toward the very edges of space itself. Imagine, if you will, the universe as a balloon inflating over time. As this balloon expands, the surface representing the universe stretches ever outward, and the galaxies move further apart. The study of cosmic origins sheds light on the early conditions that initiated this expansion, and gives us a framework to understand how distances between galaxies have changed over time. But what lies beyond the observable universe? This question captivates scientists, as beyond the observable horizon lies an expanse that remains shrouded in mystery. We can only study the light that has traveled to us since the beginning of time, and beyond that point, the universe's true limits remain unknown. The discovery of cosmic microwave background radiation provides a snapshot of the early universe, offering essential clues about its origins and setting the stage for our understanding of its limits. This radiation is a remnant of the Big Bang and serves as a cosmic map, guiding our efforts to understand the universe's birth and its eventual fate. By studying these remnants, scientists can form a better understanding of the boundaries of space itself, how far we can see, and what might exist beyond the furthest reaches of our perception. This journey of discovery is not only about understanding the history of the cosmos, but also about contemplating its future. As theories about the universe's ultimate fate continue to evolve, questions arise about whether the universe is boundless or whether it will eventually end. Some scientists believe that the universe will continue expanding indefinitely, suggesting that it may have no edge at all. Imagine walking on the surface of a balloon. No matter how far you travel, you would never fall off, as each step takes you further along the curve of the balloon. This analogy suggests that the universe, while expanding, may still be a closed system, without a definitive edge. Other theories present more dramatic possibilities. Some envision the universe contracting in a big crunch, while others speculate that the universe could eventually be torn apart in a big rip. The Big Crunch proposes that the expansion of the universe will eventually reverse, causing everything to collapse back into a singular point. The Big Rip, on the other hand, imagines a force so powerful that it tears apart galaxies, stars, and even atoms. These theories raise profound questions about the nature of the universe, suggesting that understanding its boundaries might involve more than just pinpointing a physical location. It might also require a deeper exploration of the very nature of existence itself. Ultimately, the study of the universe's fate brings us to questions about the fundamental nature of reality, existence, and time. Each theory, whether it posits an expanding universe, a collapsing one, or one ripped apart by cosmic forces, challenges us to rethink our assumptions about the cosmos. The quest to understand the edge of the universe is not just about geography. It is about the profound journey of cosmic discovery that will continue to unfold across time. As we look back at the early galaxies that emerged after the Big Bang, we gain a glimpse into the universe's past, a window into the earliest moments of cosmic evolution. The light from these distant galaxies carries vital information about the conditions that existed in the infancy of the universe. By analyzing this ancient light, scientists can uncover the composition of the early universe and learn how matter began to clump together, eventually forming stars and galaxies. This process sheds light on the fundamental elements that were present in the universe's earliest stages, offering valuable insights into how cosmic evolution began and how it continues to shape the universe today. In the end, the study of early galaxies is not just about looking backward into the past. It is about piecing together the timeline of cosmic evolution and using that understanding to inform our exploration of the future. Through these discoveries, we continue to unravel the mysteries of the universe, gaining a deeper understanding of its structure, its origins, and its boundless potential for discovery. Moreover, studying the earliest galaxies offers an invaluable opportunity to uncover the mysteries of dark matter and dark energy, two phenomena that make up the vast majority of the universe, yet remain elusive and poorly understood. These ancient galaxies hold crucial clues that allow scientists to explore how these invisible components exert influence over the universe's expansion and its ultimate fate. By analyzing the characteristics of these early galaxies, we gain profound insights into the rate of star formation, the mechanisms behind galactic evolution, and the processes that drive the continual transformation of cosmic structures. This knowledge serves as a key to refining astronomers' models of the universe, helping them predict how it might evolve in the future and providing a clearer picture of the universe's structure today. Understanding where galaxies first formed and mapping their distribution across space is essential for defining the boundaries of the universe, both in terms of physical space and our comprehension of cosmic history. As we peer into the depths of space, we encounter a sprawling tapestry of galaxies extending across unimaginable distances, offering us a snapshot of what is observable within the known universe. Yet beyond these observable regions lies a mystery, a boundary that separates what we can see from the unknown. The observable universe in many ways functions like a window into the cosmos, framed by the limits of light travel. We can only see as far as light has had time to reach us, which means that the farthest light we detect is coming from events that took place billions of years ago. This phenomenon allows us to look not just into space, but also backward in time. Beyond the so-called cosmic horizon, the universe could have undergone dramatic transformations. Perhaps it contains more galaxies, stars, and even entirely new realms beyond the reach of our detection methods. One intriguing possibility is that the universe stretches beyond the observable horizon, potentially into regions where galaxies, stars, and worlds exist but cannot be seen. This limitation is due to the finite speed of light, which means that some regions of the universe are simply too far for their light to have reached us. This means that as we look deeper into space, we are also looking deeper into time, gazing upon events from a distant past. But what lies beyond the visible universe is still unknown. There could be entirely new structures and cosmic phenomena that have evolved beyond our detection capabilities. Another tantalizing theory suggests the existence of a multiverse, multiple separate universes each governed by its own set of physical laws. If this idea holds true, the observable universe might only be one bubble within an infinitely larger cosmos, with each bubble operating independently of the others. This would mean that beyond our current understanding, other universes may exist with entirely different rules of physics, each with its own stars, galaxies, and perhaps even life forms, all following distinct cosmic rules. The concept of a multiverse invites profound questions about the fundamental nature of reality itself and opens up new, fascinating avenues of scientific inquiry. In addition to these possibilities, modern theories in physics suggest that the universe may not be a flat, infinite expanse, but could be curved or looped in some way. Imagine traveling in one direction far enough that you eventually find yourself back at the point from which you started. This is one potential model for the shape of the universe. Such a theory challenges our basic understanding of space and time and raises questions about how interconnected or isolated different regions of the universe might be. Could the universe in its entirety be a vast connected network? Or is it an endless series of isolated pockets, each evolving independently of the others? These possibilities push the boundaries of our knowledge and invite deeper exploration. Even with these tantalizing hypotheses, our understanding of the universe's true extent remains limited by the observable edge, the point at which light from distant galaxies has not yet reached us. However, the potential that lies beyond this boundary is filled with an endless array of possibilities. Perhaps entire new galaxies or even completely different realms of existence await discovery, governed by entirely unknown forces. While we may never fully penetrate this veil of the unknown, the prospect of what could be out there continues to spark curiosity and drive scientific exploration forward. Cosmic timelines play a fundamental role in understanding the universe's evolution and structure. These timelines can be thought of as a vast, dynamic map that charts the key milestones in the universe's long history, from the Big Bang to the present day. By breaking down this immense history into distinct epochs, scientists can investigate how the universe has changed over time. The formation of the first stars, the birth of galaxies, and crucial periods like the Age of Reionization. Each one of these events represents a significant moment in the universe's ongoing narrative. By studying these timelines, astrophysicists can not only uncover the sequence of events that shape the universe, but also gain valuable insights into how galaxies and other cosmic structures evolved. The gravitational forces created by galaxies as they formed and matured helped to arrange the matter in space, shaping the vast cosmic landscape we observe today. This understanding allows scientists to trace the limits of our knowledge about the universe, helping to define the boundaries of the known cosmos. Through the study of light emitted from distant galaxies, astronomers can peer back in time to witness what the universe looked like billions of years ago. This light, rich with information, reveals the universe's age and provides clues about the state of cosmic structures at various points in its history. By carefully analyzing when and how these structures formed, astronomers can define the edges of the observable universe. Furthermore, the study of cosmic expansion over time reveals how the universe itself has grown and evolved, offering clues about its future. Will the universe continue expanding forever, or will it eventually reach a dramatic end? Cosmic timelines provide the framework for answering such profound questions. These timelines also give scientists crucial insights into how the universe's expansion has changed over time. The rate of expansion is not constant, it evolves, and understanding this change is key to predicting the ultimate fate of the universe. By piecing together these critical moments in the universe's history, scientists can construct more accurate models of how the cosmos behaves and how it might continue to evolve in the future. Mathematics plays an essential role in understanding the universe's boundaries, particularly when we consider the concept of its edge. Defining the edge of the universe is far from straightforward. Instead of imagining the universe as a simple, flat space with a definite boundary, scientists use a variety of mathematical models to describe its shape and expansion. One fundamental concept is the idea of space expanding, much like the surface of a balloon stretching out. As the balloon inflates, points on its surface move farther apart, and in a similar way, galaxies in our universe move farther apart as the universe itself expands. Using geometry and mathematical equations, scientists can model how galaxies shift positions over time and predict how far light can travel. These mathematical models help to describe not only how galaxies move, but also how the fabric of space itself is curved. The universe is not flat, but rather it exhibits a form of curvature that can be modeled mathematically, much like the surface of our balloon. By applying equations from geometry and calculus, scientists can calculate distances, shapes, and movements within this expanding universe. This allows them to establish a boundary, not as a physical wall or barrier, but as a boundary of observable information, the limits of what we can see and detect, shaped by the speed of light and the universe's age. Einstein's theory of relativity underpins much of our understanding of space, time, and gravity, offering crucial insights into how the universe behaves. According to Einstein, mass and energy influence the curvature of space-time, creating a dynamic relationship between these three components. Imagine space-time as a flexible sheet. When you place a heavy object like a star or planet on it, the sheet bends, affecting how objects move through space. These equations help scientists understand how this bending creates the force of gravity and governs the movement of objects within space-time. In the context of the universe's boundary, Einstein's equations reveal how space itself expands and contracts. These equations describe how the universe is continually evolving, helping scientists understand how objects behave near the edge of our observable universe. This edge is not a physical wall, but a limit based on what we can observe, dictated by the speed of light and the age of the universe. This boundary marks the farthest reaches of our current understanding, but it also points toward the vast, uncharted territory that lies beyond, offering endless possibilities for discovery. Moreover, these equations point to the possibility that the universe could be either finite or infinite. If the universe is finite, it suggests that at a certain distance, the very fabric of space might loop back on itself. This means that if you were to travel far enough in one direction, you could end up back at your starting point, much like a traveler on Earth moving in a straight line and eventually circling back to where they began. On the other hand, if the universe is infinite, it stretches endlessly in all directions, presenting a unique challenge in understanding what lies beyond our observable limits. Einstein's equations play a pivotal role in revealing the structure of the cosmos. They guide our quest to understand the vastness of our cosmic landscape, pushing us to consider its boundaries and the potential realities that lie beyond them. Every scientific revelation in this field builds upon the work of those who came before, encouraging us to think of the universe not just as a collection of distant stars, but as a dynamic, ever-changing interplay of time, space, and energy. To theorize about the edge of the universe, scientists employ a variety of sophisticated mathematical models. One of the most prominent among these is the concept of cosmic inflation, a theory that suggests that shortly after the Big Bang, the universe expanded at an unimaginable rate. This rapid expansion occurring in the blink of an eye helps to explain why galaxies are distributed so uniformly across the sky. The idea of inflation provides an essential key to understanding the early moments of the universe and its large-scale structure. Another crucial mathematical framework is the Friedmann-Lemaitre-Robertson-Walker FLRW metric, which describes a universe that is either expanding or contracting over time. This model explores different shapes and forms the universe could take, such as flat, open, or closed configurations. By analyzing these possibilities, scientists are able to refine our understanding of the universe's overall geometry and speculate about its potential boundaries. The concept of the observable universe is also central to understanding its limits. This model highlights the constraints of our observational capabilities, which are bound by the finite speed of light. Because light takes time to travel, we are only able to observe regions of the universe that are within a certain distance from us. This does not mean the universe has an edge in the traditional sense. Rather, it means that there are vast stretches of space beyond our current observational reach. These unseen regions may hold mysteries far beyond anything we can imagine. In addition to these models, some theories propose the existence of a multiverse, an idea that suggests there might be an infinite number of universes, each with its own set of physical laws and properties. This notion of multiple universes adds a new layer to our understanding of the concept of edges, not just in terms of the boundaries of our own universe, HUD, but also in the context of potentially infinite other realms. The possibility that our universe is just one of countless others challenges our traditional understanding of existence and opens up entirely new avenues for scientific exploration. Mathematical models, in this sense, act as essential tools that help astronomers and physicists to visualize and predict the behaviors of the universe, particularly at its outermost reaches. Each of these models, whether they focus on the rapid expansion of space, the curvature of the universe, or the concept of an observable limit, contributes to the broader understanding of the cosmos. Together, they help us imagine the universe not as a static, closed system, but as a dynamic, evolving entity with an unknown future. Mathematics has played an integral role in reshaping our understanding of the universe and its boundaries. Think of mathematics as the blueprint for deciphering the most complex puzzle imaginable. Without it, many of the most fundamental principles of the cosmos would remain beyond our grasp. From the moment we began grappling with abstract concepts like infinity or the curvature of space, mathematics provided the necessary framework to move forward. The introduction of calculus, for instance, revolutionized how scientists understood motion and gravity. It allowed us to describe not just the movement of planets, but also the intricate relationship between mass and the fabric of space-time itself. This laid the foundation for theories like Newton's laws of motion and Einstein's theory of general relativity, both of which reshaped our understanding of space and time. These theories showed that space and time are not fixed, independent entities, but are interconnected and curve in the presence of mass. As we continue to explore the cosmos, we encounter even more specialized branches of mathematics. One of these is topology, the study of shapes and spaces. Topology allows scientists to think about the structure of the universe in a more abstract way, focusing on its overall form without worrying about exact measurements. This mathematical approach has opened up discussions about the very shape of the universe and the possibility of multiple dimensions, ideas that were once the domain of science fiction but are now seriously considered by physicists. Mathematics has also given us the tools to explore some of the universe's most mysterious phenomena, such as black holes. Equations derived from mathematical principles have provided insights into how black holes form, how they interact with surrounding matter, and their relationship to the fabric of space-time itself. These revelations have significantly impacted our understanding of cosmic boundaries, suggesting that certain regions of space, such as the inside of a black hole, might be entirely beyond our reach, existing outside the scope of our observational capabilities. The evolution of mathematical thinking has thus fundamentally changed how we perceive the universe's limits. It has equipped us to better understand the subtleties and complexities of the cosmos, showing us that what we often consider to be boundaries may in fact be portals to entirely new realms of knowledge. Concepts like chaos theory, for instance, have helped us grasp the inherent unpredictability of cosmic events. Chaos theory suggests that just as the weather is sensitive to initial conditions, so too are cosmic phenomena. Small fluctuations can lead to vastly different outcomes. This unpredictable nature of the universe is most evident when we examine cosmic events like galaxy mergers or the behavior of hypothetical entities such as cosmic strings. These phenomena may not follow a straightforward, predictable path, but instead could be influenced by chaotic interactions, leading to unpredictable results. This chaotic aspect shifts our understanding of the universe's boundaries. Rather than seeing them as rigid, well-defined limits, we come to appreciate them as dynamic and constantly evolving regions, where even the smallest changes can lead to significant shifts in our understanding. In this light, chaos theory offers profound insights into the way the universe operates. It challenges us to see cosmic boundaries not as fixed barriers, but as areas filled with infinite potential for discovery. The chaotic interactions that define the cosmos give rise to an ever-evolving, ever-expanding universe where surprises and mysteries lie around every corner. Science fiction often explores the concept of the universe's edge through creative storytelling, pushing the boundaries of our imagination. In these fictional narratives, the universe's edge is often depicted as a literal boundary, a place where the known laws of physics break down and the very nature of space and time begins to unravel. Some stories imagine the edge as a portal to other dimensions, a threshold between our universe and countless alternate realities. In these tales, travelers who venture to the universe might encounter worlds governed by different physical laws, or find themselves in realms where time itself behaves in strange and unpredictable ways. These speculative ideas challenge our current understanding of the universe and force us to reconsider the very nature of existence and reality. While these concepts may seem fantastical, they are rooted in scientific exploration and invite us to imagine a cosmos that is far more complex and mysterious than we ever thought possible. The concept of an edge has long captivated the human imagination, evolving into a powerful metaphor for exploration and the relentless pursuit of knowledge. It represents the boundaries of our understanding, the limits of what we know, and the courage required to challenge and push beyond these confines. In literature and film, characters often embark on epic journeys, driven by a profound desire to seek out the edge of reality itself. These journeys are fraught with danger, uncertainty, and the unknown, mirroring humanity's inherent urge to venture into uncharted territory and confront what lies beyond the grasp of perception. At the core of many of these narratives is the idea that the edge of the universe is more than just a physical boundary. It serves as a nexus of possibility, where alternate realities, infinite voids, and interconnected dimensions might exist. It is within these speculative realms that the mysteries of existence come to the forefront, allowing authors and filmmakers to explore profound questions about the nature of reality, existence, and the future. Some stories depict the edge as an insurmountable wall, while others suggest it as a gateway connecting different universes, highlighting themes of interconnectedness and parallel existences. These creative depictions not only entertain, but also invite audiences to reflect on the vast unknown that lies beyond our current comprehension. Science fiction plays a pivotal role in expanding the limits of human imagination. Through its creative storytelling, it challenges the boundaries of scientific knowledge and pushes the envelope of what is conceivable. While many of the ideas presented are purely speculative, they spark real-world curiosity and inspire further inquiry. One of the most notable concepts explored in science fiction is faster-than-light travel. Often depicted in literature and films, the idea of reaching distant stars at speeds exceeding that of light has inspired numerous advancements in theoretical physics and space engineering. These works provoke scientists and engineers to think creatively about propulsion methods and technologies that could one day turn these fictional ideas into reality. For instance, the concept of warp drives and wormholes has long captured the imagination of both writers and researchers. These speculative ideas offer the possibility of bending or bypassing the limitations of space-time itself, suggesting that vast distances might be traversed in an instant. Though these concepts remain theoretical, they have inspired significant scientific inquiry, prompting research into the very fabric of space-time and the possibilities of interstellar travel. The exploration of such ideas not only ignites curiosity, but also propels the scientific community forward, urging researchers to expand their understanding of the universe and the technological means by which we might one day explore it. Moreover, science fiction has the unique ability to capture the public's imagination, generating widespread enthusiasm for scientific discovery and exploration. When audiences engage with compelling narratives about space and the cosmos, they are more likely to form connections with real-world science and its potential applications. Films like Interstellar and television series such as Star Trek have not only entertained millions, but have also sparked the interest of new generations in fields such as astrophysics, cosmology, and engineering. These stories have ignited passions, encouraged further exploration, and inspired countless individuals to pursue careers in the sciences, particularly in space exploration. Beyond the allure of futuristic technology and interstellar travel, speculative science fiction also serves as a platform for grappling with the ethical and societal implications of advanced scientific progress. By imagining possible futures, these stories address the potential consequences of pushing the boundaries of human knowledge and the risks associated with venturing into the unknown. As humanity contemplates its future in the cosmos, science fiction raises important questions about responsibility, ethics, and the potential dangers that come with harnessing advanced technologies. These narratives prompt us to consider not only what we might discover, but also what responsibilities we may hold in shaping the future of our exploration. Through its blend of creativity, inquiry, and philosophical contemplation, speculative science fiction acts as both a source of inspiration and a catalyst for real-world scientific exploration. By asking what if and venturing into new realms of possibility, science fiction encourages dreamers and researchers alike to break free from the constraints of current knowledge and imagine new frontiers. It sparks curiosity, encourages scientific innovation, and provides a means of reflecting on humanity's place within the vast expanse of the universe. It challenges us to confront our own limitations and to push the boundaries of what we can know. Historically, writers have used the concept of the universe's edge to explore not only the physical limits of existence, but also to ponder deeper existential questions. In the early days of speculative fiction, the universe was often depicted as a finite space, bounded by an invisible wall or a mysterious boundary. This concept led to speculation about what might lie beyond. Some imagined a divine realm inhabited by gods or supernatural forces overseeing the human experience. As scientific understanding progressed, so too did the narratives, evolving alongside the discoveries of physics and cosmology. In the early 20th century, authors such as H.G. Wells began to incorporate emerging scientific theories into their works, exploring concepts like time travel and parallel worlds. These ideas reflected a more fluid understanding of space and time, challenging the traditional view of the universe as a static, bounded entity. As knowledge of the cosmos expanded, so did the scope of science fiction, leading to the rise of the concept of the multiverse, the idea that multiple universes, each governed by its own set of physical laws, coexist alongside our own. The multiverse concept gained significant traction in the late 20th century, with authors such as Arthur C. Clarke and Isaac Asimov creating stories in which characters ventured beyond the boundaries of our universe, encountering entirely different forms of life, civilizations, and realities. These works not only captivated the imagination, but also introduced profound philosophical questions about the nature of existence, the meaning of life, and humanity's place in the grand scheme of the cosmos. As our scientific understanding of the universe has advanced, the concept of the edge of the universe remains as enigmatic and fascinating as ever. Today, even as we probe the farthest reaches of space, the edge of the universe continues to be a source of speculation and wonder. Writers and filmmakers still use the edge as a canvas for their imaginations, exploring the limits of reality and the possibilities of what lies beyond. This interplay between fiction and science is a constant reminder that the boundaries of knowledge are not fixed. They are constantly expanding as we push the limits of our understanding. Cinematic portrayals of the universe further fuel our fascination with its boundaries. Films and documentaries, using breathtaking visuals and imaginative storytelling, delve into the concept of the universe's edge, offering viewers a sense of awe and wonder at the vastness of the cosmos. These representations often depict spacecraft journeying into the depths of space, exploring regions where the very laws of physics appear to break down or become distorted. Such depictions are not merely physical explorations, they are philosophical voyages, raising questions about the nature of reality itself, the limits of human knowledge, and the implications of encountering the unknown. Whether through the fantastical imagery of distant galaxies, the shimmering glow of nebulas, or the infinite expanse of stars, cinematic representations of the universe's edge inspire curiosity and reflection. They invite us to imagine a universe far greater than our own understanding, one where the boundaries of reality are constantly shifting and evolving. And as we continue to push outward, venturing ever closer to the unknown, the edge remains a symbol of possibility. A reminder that no matter how far we travel, there will always be more to discover beyond the horizon. Filmmakers often depict the universe's edge not just as a physical boundary, but as a concept, an abstract mental construct that represents the limits of human knowledge and understanding. In many films, the portrayal of this edge goes beyond simple space. It explores the boundaries of our perception. Directors and storytellers weave in ideas of black holes and wormholes, suggesting that what we perceive as the end might simply be a doorway to new dimensions, parallel realities, or even realms of existence that lie far beyond our comprehension. This blending of speculative science with narrative art pushes audiences to confront not only the limits of our knowledge, but also the tantalizing possibilities that await just beyond the horizon of what we can understand. It invites viewers to ponder, what lies beyond our grasp? What is the true scope of the cosmos? And how much more can we discover if we dare to venture beyond the edges of our current understanding? Through this artistic lens, cinema does more than entertain. It becomes a tool for critical thought, encouraging audiences to question the very fabric of reality, to explore human curiosity, and to imagine the untold possibilities that may lie at the universe's edge. Speculative fiction, through its imaginative stories, has long shaped the way people think about the universe. The genre delves into the unknown, offering narratives about space exploration, alien civilizations, and futuristic technologies that stretch the boundaries of our imagination and instill a sense of wonder. These stories create vivid, often otherworldly landscapes where the impossible is made possible, urging readers and viewers to think outside the confines of our planet and consider the possibility of life beyond Earth. A recurring theme in speculative fiction is the concept of infinite worlds, where the universe is an ever-expanding space full of galaxies yet to be discovered and territories that remain uncharted. This concept presents space as limitless, challenging our assumptions about the finite nature of our knowledge. It stirs in us a sense of awe, suggesting that perhaps the universe is far larger and more mysterious than we can imagine. This concept pushes us to dream beyond our current capabilities, prompting the idea that one day, humanity could venture beyond our solar system, journeying to distant stars. Speculative fiction not only broadens our imagination, but also sparks a deeper curiosity about the unknown. Moreover, the genre often introduces advanced technology and alien life, concepts that allow people to visualize futures where communication with intelligent beings from other planets is possible, or where we could travel at extraordinary speeds across the galaxy. These ideas not only stimulate our imagination, but also shape public perception about the potential for such endeavors, contributing to real-world scientific pursuits like space travel and the search for extraterrestrial life. In doing so, speculative fiction acts as a bridge between the world of science and the world of imagination, making complex scientific theories more approachable while also fueling public interest in the ongoing pursuit of knowledge. This unique blend of science and storytelling encourages audiences to reflect on the future, to question history, and to grapple with the boundless expanse of the universe. It serves as more than just an entertainment genre. It is a means of fostering a deeper connection with the cosmos. The exploration of these questions about existence, the nature of reality, and the vastness of space, becomes not just a scientific endeavor, but a journey of human creativity, aspiration, and imagination. The intersection of art and science offers a fascinating lens through which we can probe the mysteries of the universe. Art, in this context, transcends the realm of mere aesthetics. It possesses a remarkable ability to convey complexities and invoke emotions in ways that raw scientific data cannot. When artists collaborate with scientists, they interpret discoveries through imaginative visuals, sounds, and narratives, translating abstract scientific concepts into forms that are accessible, relatable, and, most importantly, emotionally engaging. For example, an artist might depict a black hole or the birth of a star, transforming these scientific phenomena into awe-inspiring visual masterpieces. These representations help the public not only grasp difficult concepts, such as the scale of the universe or the strange behavior of time near massive objects, but also to emotionally connect with them. Additionally, science itself often relies on creativity to formulate theories and design experiments. Both artists and scientists share a vital commonality. They are driven by curiosity and innovation. When these two fields come together, the result is a fusion of ideas that can lead to new insights that neither discipline could have achieved alone. Imagine an exhibition that combines images from deep space, sculptures, and interactive installations, inviting participants to experience the wonders of the cosmos in a multi-dimensional space. This collaboration deepens our questions about existence, sparking philosophical contemplation about the universe and our place within it. Furthermore, art compels us to reflect on what the universe means not just in scientific terms, but in deeply personal ways. It invites us to contemplate the intangible, the philosophical, existential, and emotional dimensions of our understanding of the cosmos. The intersection of art and science, then, becomes a powerful medium for exploring the profound, often philosophical implications of what lies beyond the observable universe, what lies at the universe's edge. Philosophy, too, plays a significant role in shaping our understanding of the universe's boundaries. At its core, philosophy asks the fundamental questions about existence, reality, and the nature of knowledge. When scientists explore the edges of the universe, they do not rely solely on empirical data. They also engage with philosophical questions that guide their inquiry. These questions help define what we mean by the universe itself, whether it is simply the observable sky, or if it extends far beyond our perception. Such distinctions are not trivial. They shape the direction of scientific research and influence the methods we use to study the cosmos. Philosophers also tackle concepts like infinity and the nature of time, which are essential when considering whether the universe has a true edge, or if it is, as some theories suggest, boundless. These ideas challenge our current understanding and push the limits of what we can know. Different philosophical perspectives lead to varying scientific hypotheses. Take, for example, the debate surrounding determinism, the question of whether all events are predetermined or shaped by random factors. This philosophical inquiry directly influences scientific theories about the universe's origins, its evolution, and its ultimate fate. The way we frame questions about the Big Bang, the origin of the universe, stems from long-standing philosophical ideas about causality and existence. Moreover, philosophy raises essential questions about the limitations of scientific inquiry itself. What can we truly know or measure? Can we rely solely on observation? Or is there more that cannot be witnessed directly? These questions encourage scientists to reconsider their methods and tools and challenge the very essence of what is knowable. Philosophy provides a foundation for scientific exploration, guiding and shaping the questions that drive our curiosity and the ways in which we seek answers. The history of humanity's understanding of the universe profoundly shapes contemporary theories about its boundaries. In ancient times, humans looked to the stars and created mythologies to explain celestial phenomena. The sky was seen as a dome or ceiling, providing a framework that helped people make sense of the world around them, but it also limited their understanding of the cosmos. As civilizations advanced, thinkers like the ancient Greeks began to develop more formal theories, suggesting that the Earth was spherical and that celestial bodies moved in orbits around it. This shift marked a significant turning point, propelling humanity toward a more refined view of the cosmos. During the Renaissance, the revolutionary ideas of figures like Copernicus and Galileo challenged the long-held belief that Earth was the center of the universe. They proposed instead that the planets orbited the sun, sparking a seismic shift in our understanding of space. This realization that Earth was just one of many worlds in a vast, interconnected cosmos opened the door to new ideas about the universe's true size. This recognition of a broader universe planted the seeds for future scientific inquiry and exploration. The invention of the telescope during this period further expanded our view of the universe. As astronomers observed distant galaxies and stars, it became increasingly clear that the universe had no easily discernible edge. This ambiguity persisted with the advent of Einstein's theory of relativity in the early 20th century, which introduced radical new ideas about space and time. Relativity suggested that the universe was not static, but expanding, raising new questions about its limits and the ultimate fate of the cosmos. Contemporary scientific theories, such as those surrounding dark energy and cosmic inflation, reflect this rich historical context. These theories emerged from a growing body of evidence and the need to explain observed phenomena like the accelerating expansion of the universe. Today, scientists are not only exploring the universe's boundaries, but are also considering the possibility of parallel universes or dimensions beyond our current understanding. In this way, history continues to influence our current theories, providing a foundation of curiosity, challenging paradigms, and expanding the scope of our cosmic understanding. Ultimately, the quest to understand the universe's limits is not merely a scientific endeavor. It is a journey through humanity's intellectual history, shaped by cultural interpretations and beliefs. Different cultures have unique perspectives on the cosmos, often influenced by their histories and religious or spiritual views. For example, some cultures see the universe as a living, dynamic entity, with stars and planets regarded as ancestral spirits or gods. These perspectives shape how the edge of the universe is perceived, sometimes as a sacred space rather than just a physical boundary. In modern science, the edge of the universe is often defined by the limits of what we can observe, a concept influenced by technological advancements. Thus, the journey to explore the universe's edge is not simply about expanding scientific knowledge. It is also about engaging with the profound, multifaceted questions that shape our existence. Through art, science, philosophy, and culture, we continue to push the boundaries of what we know, constantly seeking to uncover the mysteries that lie just beyond our reach. However, the cultural perspective can offer a profound layer to our understanding, imbuing the stark realities of scientific facts with rich, nuanced narratives. This depth is especially visible when we turn to creation myths, legends, and religious beliefs that many cultures hold dear. These stories, passed down through generations, give shape to the very idea of how the universe came into being. They often serve as a starting point for our contemplation of the cosmos, providing a framework through which we attempt to understand our existence. For example, some cultures envision the universe's origins as a divine act, while others see it as the result of cosmic cycles or the actions of celestial beings. These diverse worldviews shape our intellectual pursuits, blending the realms of mythology, philosophy, and science in ways that enhance our exploration of the unknown. Furthermore, our perception of the universe's edge is not a uniform concept. Different cultures and traditions imagine it in varying ways, depending on their historical, philosophical, and spiritual contexts. Some envision it as a vast, boundless horizon stretching infinitely into the distance, while others picture it as a deep, uncharted ocean, teeming with unknown potential. This symbolic representation profoundly influences how we approach scientific exploration. The concept of the universe's edge is not merely a geographical or spatial boundary, but a reflection of our collective imagination, a place where the known meets the unknown, a boundary that we constantly strive to transcend. This cultural framing can inspire us to view scientific inquiry not as an isolated pursuit of facts, but as a conversation between science, culture, and imagination. In doing so, we foster a deeper connection with the cosmos, enriching our sense of place within it. As we continue to probe the vastness of space, the fusion of scientific understanding with cultural interpretations creates a more comprehensive and multifaceted view of our world and beyond. This dynamic relationship allows for a richer, more holistic perspective, one that moves beyond simple facts and explores the deeper meanings that lie beneath them. When we view the universe through the lens of both science and culture, we engage in a dialogue that enhances our curiosity and appreciation for the mysteries that still elude us. This combined approach does not only broaden our intellectual horizons, but it also sparks inspiration. It encourages individuals to look beyond the ordinary and venture into the unexplored, driven by a desire to understand the true nature of the universe. Such an expansive approach often leads to breakthrough discoveries. Interdisciplinary collaboration, the coming together of experts from various fields, proves to be a powerful catalyst for innovation in our understanding of the cosmos. When specialists in different areas of study unite, they offer unique perspectives and methodologies that collectively tackle complex questions and challenges. For instance, when astronomers work alongside engineers in the development of space programs, the results are often more robust and effective. The engineers bring their technical expertise to the table, while the astronomers provide essential knowledge of the cosmos, ensuring that space missions are designed with both precision and possibility in mind. Moreover, when astrophysicists collaborate with biologists, the potential for groundbreaking discoveries in the search for life beyond Earth is amplified. Astrophysicists, with their understanding of celestial bodies and the conditions of distant exoplanets, can offer invaluable insights into where life might exist. Meanwhile, biologists can contribute their knowledge of life on Earth, speculating on how organisms might adapt to alien environments. This merging of perspectives allows the team to propose more effective experiments, enhancing the probability of finding extraterrestrial life. Similarly, the involvement of artists and communicators in scientific endeavors should not be underestimated. Their ability to take complex scientific data and transform it into engaging, accessible stories can captivate the public, generating enthusiasm and inspiring future generations of scientists. By simplifying the technicalities and highlighting the wonder of space exploration, they play a critical role in making these concepts resonate with the general populace, fostering public support for funding, policies, and initiatives that propel further exploration. The power of interdisciplinary collaboration lies not just in the practical benefits it yields, but also in the creative synergy it fosters. When professionals from diverse fields come together, they often think outside the confines of their individual specialties. This fusion of ideas can lead to unexpected solutions, often pushing the boundaries of what was once thought possible. Consider, for example, the development of new propulsion technologies that allow spacecraft to travel further and faster, or the creation of advanced instruments capable of delving deeper into space than ever before. These innovations are the result of collaboration between scientists, engineers, and even artists, each bringing their unique knowledge and skills to the table. Through this collective effort, we are able to unlock new potentials in our exploration of the cosmos, continually pushing the limits of our understanding. Public education plays a pivotal role in enhancing our collective grasp of the universe and its boundaries. One effective way to make complex scientific concepts more accessible is through the use of visual aids, such as documentaries, interactive planetarium shows, and digital simulations. These tools help people of all ages grasp the immense scale of the universe, allowing them to visualize phenomena that are otherwise abstract and intangible. For instance, seeing a simulation of the solar system in motion can give people a better understanding of planetary orbits, while exploring a digitally rendered galaxy might help them comprehend the vast distances between stars. In addition to these digital tools, incorporating hands-on activities into educational programs can further deepen understanding. Organizing stargazing events, for example, allows participants to connect directly with the night sky, observing celestial objects through telescopes and learning about their properties. Workshops where participants build models of galaxies, solar systems, or black holes provide another avenue for tactile engagement, helping to solidify abstract concepts through physical interaction. These types of activities strengthen the connection between the curriculum and real-world exploration, making learning more dynamic and participatory. Moreover, educators can foster a deeper appreciation for the scientific process itself. Rather than merely presenting students with established facts, teachers can encourage critical thinking and inquiry. Students should be inspired to ask questions about the observable universe and the mysteries that lie beyond it, such as the elusive nature of dark matter and dark energy. Collaboration with local astronomical societies, science museums, and universities offers opportunities to bring expert knowledge into the classroom through guest lectures, workshops, and outreach programs. These collaborations allow students to engage with professionals in the field, gaining first-hand experience and insight into the cutting-edge research being conducted by astronomers and cosmologists. Incorporating technology, such as virtual reality experiences that simulate space travel, is another powerful way to spark interest and curiosity. Virtual reality allows students to travel to distant parts of the universe, exploring the surface of planets, orbiting stars, or flying through nebula, all within the classroom. This immersive experience makes distant cosmic phenomena feel more tangible and accessible, inviting students to engage with the universe on a deeper emotional and intellectual level. Furthermore, fostering scientific literacy within the wider community is crucial. Public events, social media campaigns, and outreach programs can bring exciting discoveries directly to people's attention, inviting them to participate in the ongoing conversation about space and exploration. By sharing the latest advancements in astrophysics and cosmology, we can increase public awareness and inspire a broader audience to take an interest in the universe. This collective curiosity can cultivate a sense of wonder and a deeper appreciation for the scientific efforts that shape our understanding of the cosmos. Museums and planetariums, as central hubs for learning, play an essential role in making the universe's wonders accessible. They serve as gateways for people to explore the mysteries of space and time, offering interactive exhibits, immersive experiences, and educational programs that make the cosmos feel within reach. In museums, visitors can examine artifacts from space missions, view models of celestial bodies, and learn about the history of astronomical discovery. Planetariums take this experience to the next level, immersing audiences in the night sky and creating a breathtaking visual journey through the stars, galaxies, and beyond. The expansive domed screens transport viewers into a world where cosmic events unfold before their eyes, bringing the mysteries of the universe into sharp focus. These institutions not only offer knowledge, but also inspire future generations of scientists, engineers, and explorers. Programs for both children and adults spark a sense of wonder and curiosity, encouraging participants to explore questions about the origins of the universe, the search for extraterrestrial life, and the ethics of space exploration. Through workshops, lectures, and hands-on events, museums and planetariums foster a sense of community among those who share a passion for space science, creating spaces where people can engage in meaningful discussions about the wonders of the cosmos. Finally, documentaries are a powerful medium for bringing the vast, often mysterious edges of the universe into focus. By presenting complex scientific ideas in an engaging and accessible way, documentaries allow audiences to grasp difficult concepts with ease. These films often begin with stunning visual imagery of space, gleaming galaxies, swirling stars, and distant nebula, capturing the viewer's attention and sparking curiosity. Through narration, these films guide audiences through the intricacies of cosmic phenomena, helping to unravel the mysteries of the universe's boundaries. By blending scientific discoveries with storytelling, documentaries create a narrative that is both informative and emotionally compelling, allowing viewers to connect with the subject matter on a personal level. These films transform abstract scientific knowledge into a journey of exploration, offering viewers the chance to experience the universe in a way that feels immediate and real. By combining personal stories of scientists, historical milestones, and revolutionary theories, documentaries humanize the pursuit of knowledge, making the quest to understand the universe's edges not just a scientific endeavor, but a shared human experience. Through the art of storytelling, these films invite us to contemplate the vastness of the cosmos and our place within it, inspiring us to continue pushing the boundaries of exploration. Documentaries offer a unique stage for exploring some of the most profound and philosophical questions about the universe, questions that challenge the very limits of human knowledge. These films delve into complex topics such as the nature of black holes, the mystery of dark matter, and the possibility of other dimensions. By presenting these vast and often abstract ideas in an engaging and accessible way, documentaries not only provide valuable information, but also inspire viewers to think critically about the boundaries of what we know. The combination of stunning visuals, compelling narratives, and insights from experts creates an environment that fosters wonder and curiosity. These elements come together to motivate audiences to reflect on their place in the universe and to consider the many mysteries that remain unsolved. Through this powerful blend of entertainment and education, documentaries spark imaginations, foster dialogue, and ignite discussions about our cosmic journey. They remind us that while we may face limits in our understanding, the pursuit of knowledge is an unending adventure. Engaging the public in conversations about the universe's edge is not only enlightening, but also thrilling. One highly effective approach is to create visually captivating experiences, such as exhibitions or planetarium shows that highlight the grandeur and complexity of the universe. These events often feature dramatic images and animations that visually represent the vastness of space, encouraging curiosity and inviting personal stories about how people relate to the cosmos. These awe-inspiring visuals become the starting point for deeper questions about humanity's connection to space, both personal and collective. Another way to spark interest in the cosmos is through storytelling. The lives of astronomers and explorers who have made groundbreaking discoveries are rich with intrigue and drama, and sharing these stories can make science feel more relatable. Personal narratives about the human quest for knowledge resonate deeply with audiences, providing a sense of shared adventure that crosses time and space. These stories bridge the gap between complex science and everyday human experience, fostering an emotional connection to the mysteries of the universe. Interactive activities also play a crucial role in engaging the public. Science fairs, workshops, and hands-on demonstrations, such as building small-scale models of galaxies or discussing concepts like dark matter, offer a tangible way to understand abstract ideas. This hands-on involvement allows participants to directly interact with the subject matter, transforming theoretical concepts into concrete experiences. As people engage with these activities, they are not merely passive observers. They become active participants in the pursuit of knowledge, solidifying their understanding of cosmic phenomena. In addition to traditional forms of engagement, social media has become an essential tool for sparking curiosity and conversation about space. Engaging posts or videos that challenge misconceptions about the universe or showcase mind-boggling space phenomena can quickly capture the public's attention. These bite-sized, visually appealing pieces of content often prompt further exploration and deeper discussions. Simple questions about the edge of the universe can spiral into profound conversations that challenge the way we view the cosmos. Early education plays a crucial role as well. By collaborating with schools to incorporate topics about space into curriculums, we can foster a lifelong interest in the universe. Children who learn about the wonders of the cosmos at a young age are more likely to continue exploring these concepts as adults. This early engagement shapes how we think about the universe throughout our lives, cultivating a deep-seated curiosity about the natural world. Public lectures and panel discussions featuring scientists also serve to demystify complex ideas about the universe. These events offer the public an opportunity to interact with experts who can explain advanced concepts in straightforward language. They invite questions from the community, making science feel more accessible and encouraging a sense of connection to ongoing research. The power of such events lies in their ability to combine education, interaction, and storytelling to ignite passion and curiosity in people of all ages. In recent years, virtual reality (VR) has emerged as an exciting way to explore the vastness and intricacy of the universe. Imagine being fully immersed in a three-dimensional simulation that allows you to float through space, observing celestial bodies like stars, planets, and galaxies in real time. This immersive experience is far more engaging than traditional methods of learning, and it allows users to interact with and manipulate the universe in ways that were once unimaginable. For example, in a VR simulation, you could virtually travel to the edge of the observable universe, witnessing the light from the earliest stars and galaxies, an experience that brings the wonders of the cosmos into vivid reality. This hands-on visual approach not only enhances understanding, but also makes abstract concepts more accessible and memorable. The interactivity offered by VR allows users to actively engage with cosmic phenomena. Whether it's exploring a black hole, interacting with distant stars, or observing the dynamics of galaxy formation, VR turns passive learning into an active adventure. The ability to manipulate elements of the universe helps solidify concepts that might otherwise be difficult to grasp. This level of engagement can dramatically enhance retention, making the learning process an exciting journey rather than a passive activity. Teachers can guide students through these virtual experiences, explaining the intricate theories of cosmology as they explore the virtual cosmos. As learners navigate through this virtual space, they acquire knowledge about the universe's structure, size, and the laws that govern it, combining deep education with thrilling exploration. Virtual reality has the potential to revolutionize how we perceive and understand the universe's boundaries. By bringing abstract cosmic concepts to life in an immersive and engaging way, VR ignites curiosity and deepens understanding in ways traditional classrooms cannot match. It allows us to experience firsthand the scale, complexity, and beauty of the universe, transforming learning into an unforgettable adventure. The quest to understand the edge of the universe reflects humanity's intrinsic drive for knowledge. This drive is fueled by our innate curiosity, a fundamental trait that defines our species. Early humans, gazing up at the night sky, must have wondered what lies beyond the horizon and whether we are alone in the vast expanse of the cosmos. As our scientific and technological capabilities have grown, so too has our ambition to explore the boundaries of the universe. Venturing to the outermost reaches of space raises profound questions about existence itself and the laws that govern our reality. Scientists and astronomers push the limits of human exploration, sending spacecraft to distant planets and deploying powerful telescopes to capture the faintest glimmers of light from ancient galaxies. Each new discovery at the fringes of the known universe unravels mysteries not only about space, but also about our place within it. The more we learn, the more we are compelled to understand how we fit into this vast, complex cosmos. This constant drive to push beyond the known universe fuels our collective spirit, reminding us that exploration is about more than just acquiring knowledge. It's about connecting with something greater than ourselves. The challenges we face in these explorations showcase humanity's resilience and determination. Every mission, whether it's launching a probe to the outer reaches of the solar system or attempting to observe cosmic events that happened billions of years ago, carries risks. These endeavors demand cooperation, innovation, and an unwavering belief in our ability to extract knowledge from the unknown. Each mission teaches us valuable lessons about how to adapt and persevere in the face of uncertainty. At its core, the pursuit of exploring the universe's edge mirrors our deepest desires: to discover, to learn, and to find meaning in the vastness of existence. Contemplating the boundaries of the universe forces us to grapple with fundamental questions about reality, the origins of everything, and what lies beyond. If the universe is infinite, it suggests that there are endless possibilities, not only for other worlds, but also for the experiences we can have. On the other hand, if the universe has a boundary, it implies there may be something beyond it, a larger framework, or even other dimensions or realities. These thoughts also raise questions about the origins and ultimate fate of the universe. What was the driving force behind the Big Bang, and what will become of our universe billions of years from now? As we contemplate these vast cosmic events, we also reflect on our own lives and our place within the larger timeline of existence. The contemplation of these questions cultivates a sense of unity with the cosmos. When we acknowledge the immensity of the universe, we realize how small we are, yet we also recognize how significant our lives are within this grand framework. This realization can foster a greater connection to each other and to the natural world. As we seek to understand our place in the cosmos, we are also reminded of our responsibility to protect our planet and one another. Contemplating the universe's boundary enriches our understanding of existence, urging us to think more deeply about reality, our origins, and the connections we share with everything around us. The journey of exploration and inquiry becomes an essential part of what it means to be human, shaping our beliefs, values, and future. The quest to understand the edge of the universe is not just a scientific pursuit. It's a reflection of humanity's deepest instincts and resilience. As we study cosmic phenomena from the faintest stars to the dark, unknown depths of the universe, we confront the most fundamental questions about existence itself. This search reveals our innate curiosity and our determination to seek answers, even to the most unsettling and incomprehensible questions. When scientists consider scenarios like the ultimate fate of the universe, whether it will continue expanding forever, collapse upon itself, or reach some other conclusion, they are also probing the limits of human understanding. These theories push us to think beyond our immediate experiences and imagine timescales that stretch billions of years into the future. This ability to envision the far future reflects our resilience. Despite the uncertainty that surrounds us, we are inspired to understand and adapt, knowing that the pursuit of knowledge is an unending adventure that will shape humanity for generations to come. Furthermore, examining the future of the universe draws us closer as a species, encouraging collaboration on monumental projects such as the development of cutting-edge telescopes and the execution of ambitious space missions. These collective efforts foster a shared sense of purpose, uniting humanity in our quest to unravel the mysteries of existence. As we delve deeper into the unknown, we come to realize that although the universe may appear vast and indifferent, our exploration of it binds us together in a shared journey of inquiry, hope, and discovery. This pursuit is a powerful reminder that, even in the face of potential cosmic endings, the drive to understand, adapt, and persevere reflects the very essence of what it means to be human. It teaches us that resilience is not merely about survival. It is about our unwavering pursuit of knowledge and connection to one another, despite the immense challenges before us. Exploring the boundaries of the universe has profoundly shaped our philosophical understanding of what it means to be human. As we look outward into the vastness of space, we are forced to confront our place within it. Throughout history, humans believed they occupied the center of existence, with the Earth at the heart of the universe. However, groundbreaking discoveries of distant galaxies, the vast scale of cosmic structures, and the realization that there are countless stars, many of which could host planets with conditions suitable for life, have drastically shifted this perspective. We are now seen as a small part of a much larger, infinitely complex cosmos, and this awareness has sparked profound questions about our purpose and meaning. If our planet is but a speck in the grand expanse of the universe, what significance do our lives truly hold? Philosophers grapple with these existential questions, contemplating the very essence of life and the nature of humanity. Many argue that life as we know it may be a rare phenomenon in a universe brimming with inhospitable environments, and this understanding compels us to consider the responsibility we bear toward our planet and one another. It urges us to cherish the fragile conditions that make life possible and to protect the delicate balance that sustains it. Furthermore, the idea that there may be life elsewhere in the universe adds an additional layer of complexity to these philosophical musings. The possibility that we are not alone forces us to reconsider what it means to be intelligent or advanced. If extraterrestrial life exists, what criteria should we use to define intelligence, and how would we position ourselves relative to other beings who may have evolved in ways we cannot yet imagine? This line of inquiry also brings ethical considerations to the forefront. If we were to encounter extraterrestrial life, how should we approach such contact? What moral responsibilities would we bear toward other sentient beings? The very act of exploring cosmic boundaries evokes a sense of unity, especially when viewed from afar. Seeing Earth as a tiny pale blue dot suspended in the vastness of space can evoke a deep sense of shared humanity, highlighting the reality that we all inhabit the same fragile planet. This perspective makes discussions about ethics, cooperation, and stewardship not just important, but imperative. The more we explore the universe, the more we are compelled to rethink our values and consider the broader implications of our actions, not only for ourselves, but for the cosmos as a whole. Our ongoing adventure into space encourages us to explore the very tenets of existence, identity, and morality. As we seek to understand the universe's limits, we are continually challenged to broaden our views, to embrace a deeper appreciation for life in all its forms. The quest to reach, or even comprehend, the edge of the universe is viewed by many as a profound journey into the unknown. This endeavor embodies humanity's insatiable curiosity and relentless desire to discover our place in the cosmos. For many, exploring the boundaries of the universe is not just about scientific discovery, but also about unlocking secrets that could shed light on the very origins of existence. It holds the promise of providing answers to fundamental questions about who we are, where we come from, and how everything in the universe began. Reaching the universe's edge is often regarded as the pinnacle of human achievement in science and technology. It represents the ultimate challenge, a quest that pushes the limits of human ingenuity, determination, and imagination. The pursuit of this goal captivates countless individuals, inspiring them to dream bigger and pursue careers in science, engineering, and other fields that advance human knowledge. The idea of an edge in a vast and continuously expanding universe suggests the potential to uncover new dimensions of reality, new insights into the fundamental nature of life, time, and space. In addition, our quest to understand the universe's boundaries holds profound implications for our future here on Earth. As we confront the ever-looming threats of climate change, resource depletion, and environmental degradation, looking outward provides a sense of hope, a belief that solutions may lie beyond our planet. The exploration of space is not only seen as essential for scientific advancement, but also as a means of ensuring the survival of the human race. By venturing into the cosmos, humanity has the opportunity to foster greater international cooperation as nations come together to pursue shared scientific goals, acknowledging that the universe belongs to everyone. However, there are also deeper philosophical considerations that arise from this pursuit. Some question the wisdom of dedicating resources to space exploration when so many pressing issues remain unresolved on our own planet. Is it justifiable to invest in the search for extraterrestrial life when we have yet to address poverty, inequality, and environmental destruction? This dilemma leads to debates about priorities and the ethical allocation of resources, as society grapples with the balance between exploring the cosmos and addressing the needs of the world around us. Ultimately, society tends to view the quest to understand the universe's edge as a dual journey, one that is both scientific and philosophical. It is about expanding our knowledge of the universe while simultaneously reflecting on what it means to be human. In this sense, the pursuit of cosmic understanding offers a unique opportunity to explore the nature of existence, the limits of human potential, and the responsibility we bear for our planet. This journey highlights the delicate balance between the quest for knowledge and the urgent need to make meaningful choices in the present moment. Quantum tunneling, a remarkable phenomenon in the realm of quantum physics, exemplifies the unpredictable nature of the universe. In quantum tunneling, particles manage to pass through barriers that, according to classical physics, they should not be able to cross. To visualize this, imagine a ball rolling toward a hill. If it doesn't have enough energy, it would simply roll back. But in the quantum world, particles can defy such classical constraints, passing through the hill as if the barrier didn't exist. This mind-bending behavior challenges our fundamental understanding of the laws of physics, underscoring just how much we still have to learn about the universe's underlying principles. However, in the quantum realm, a particle doesn't behave in ways we might expect. Instead of following predictable paths, it has a chance of appearing on the other side of a barrier, as though it had slipped through without ever needing to climb over. This concept, known as quantum tunneling, has profound implications for our understanding of the universe. When applied to theories about the edge of the cosmos, this idea suggests a tantalizing possibility that the boundaries of our universe, if they exist, might act like that barrier, with quantum tunneling allowing particles or even information to escape what we can observe. The observable universe, the vast expanse that we can see and measure with our telescopes and instruments, may not be the full story. If particles can tunnel through such barriers, could it be that there are regions of the universe that lie just beyond our sight? The notion opens a door to the idea of dimensions or parallel universes that exist just outside our current view, waiting to be discovered. Some theories suggest that every time a particle undergoes tunneling, it may establish connections between different regions of space-time, implying that the structure of reality is far more intricate than we have ever imagined. This exploration challenges our fundamental understanding and pushes the boundaries of scientific inquiry. It invites us to think beyond the familiar, to speculate about what might lie beyond the observable, and to question whether we are truly seeing the full picture of existence. Even though we cannot directly observe these tunneling events or peer beyond the edge of the universe, the mere possibility sparks a sense of wonder. Perhaps as research in quantum physics and cosmology continues, these ideas will evolve, forever shifting the limits of what we know and understand about the cosmos. Schrödinger's cat paradox, a thought experiment devised by physicist Erwin Schrödinger, offers a striking parallel to these ideas. In the scenario, a cat is placed inside a sealed box where it is subjected to a random quantum event that could kill it. Until the box is opened, the cat exists in a state of uncertainty, simultaneously alive and dead. This paradox illustrates the peculiar behavior of particles on the quantum scale, where states of being are not fixed but exist in superposition until an observation is made. Now, let's consider how this paradox might help us understand what lies beyond the universe's boundary. Imagine that the universe itself is like Schrödinger's sealed box. Just as the cat is both alive and dead until we open the box and observe it, the nature of reality beyond our observable universe might exist in a similar state of uncertainty. We have many theories about the multiverse, suggesting that other dimensions or universes might exist, but since we cannot yet observe these regions directly, they remain speculative. In much the same way the cat's fate is undetermined until the box is opened, the existence of realities beyond our universe could depend on our ability to measure or observe them. Without observation, these other realms might exist only in a state of potential, full of endless possibilities, that only take shape when we develop the tools to observe or understand them. Schrödinger's cat serves as a reminder of the limits of human knowledge and the complexities of existence. Understanding the boundary of the universe might not be as simple as looking at it or measuring it. It could involve entirely different rules of reality, rules that challenge our conventional perceptions and our understanding of what's possible. In this sense, Schrödinger's cat encourages us to stay open-minded, to accept that the unknown may be far more complex and strange than we can imagine. Just as the cat's fate remains uncertain until we open the box, the true nature of the universe and what lies beyond it may only reveal itself when we find ways to look beyond the limits of our current understanding. Quantum fluctuations offer another layer of complexity in our understanding of the universe. At the heart of quantum mechanics is the idea that empty space is not truly empty. Instead, it is a seething cauldron of activity, with particle pairs constantly popping in and out of existence. Even in the vacuum of space, there is a constant ebb and flow of particles, creating tiny fluctuations in energy levels. These fluctuations challenge our traditional notion of space as a vast, uniform expanse. When we apply this to the concept of the universe's edge, quantum fluctuations suggest that such a boundary might not be as clear-cut as we once thought. Instead of a hard stop, the edge could be an area of continuous activity, with particles fluctuating in and out of existence. If the universe has an edge, it may not be a fixed point, but a region full of dynamic possibilities. These fluctuations may even offer clues to the origins of the universe itself. Some scientists believe that the tiny quantum fluctuations in the early moments of the universe played a crucial role in shaping the conditions that led to the Big Bang. These minute variations in density eventually formed the galaxies and cosmic structures we see today. Thus, rather than seeing the universe as a vast, homogeneous space, quantum fluctuations suggest that its boundary is more dynamic, constantly shifting, full of unpredictable activity. The universe may not simply be expanding, but also undergoing a constant, chaotic reshaping of its edges. This invites us to explore the cosmos in ways we have not yet imagined, offering new insights into its true nature. Quantum computing represents a remarkable leap in technology, harnessing the very principles that govern the quantum world. Unlike classical computers, which use bits as the smallest unit of data, quantum computers utilize qubits. These qubits can exist in multiple states simultaneously, allowing quantum computers to process vast amounts of information in parallel. This ability makes them ideal for tackling complex problems that would be impossible for even the most powerful classical computers to solve. In the realm of scientific research, quantum computing holds tremendous promise. For example, simulating the fundamental forces of nature, such as gravity and electromagnetism, requires calculations that are so intricate that they can take years to complete. Quantum computers could drastically reduce the time needed to perform these simulations, allowing scientists to study the behavior of particles and forces with unprecedented accuracy. Additionally, quantum computing has the potential to revolutionize data analysis. Telescopes and other instruments that study distant galaxies, black holes, and other cosmic phenomena gather enormous amounts of data. Analyzing this data is an overwhelming task, but quantum computers could help identify patterns and correlations much more quickly, leading to new discoveries about the universe and its origins. By unlocking new ways of processing information, quantum computing could open doors to understanding the universe at a much deeper level. The impact of quantum computing on our exploration of the cosmos is still unfolding. As we continue to develop this technology, it promises to accelerate our quest for knowledge, helping us solve some of the most profound mysteries of existence. The universe, with all its complexity and wonder, may be more within our grasp than ever before. Moreover, it could unlock groundbreaking advancements in material science, paving the way for the development of new technologies that could revolutionize space exploration. The discovery of novel materials capable of withstanding the extreme and unforgiving conditions of deep space could lead to the creation of far more robust spacecraft and advanced life support systems. These innovations would be vital for ensuring the safety and sustainability of future generations of space travelers. Quantum computing, for example, could serve as the key to unlocking doors that were previously thought to be inaccessible in our quest to unravel the mysteries of the universe. Its extraordinary ability to process vast amounts of data and perform complex calculations with unmatched speed could soon allow us to delve deeper into the most profound secrets of space. By pushing the boundaries of human knowledge, quantum computing could bring us closer to understanding the cosmos in ways we are only beginning to imagine. The uncertainty principle, a cornerstone of quantum mechanics, tells us that there are fundamental limits to how precisely we can know certain pairs of properties of a particle, such as its position and momentum. To understand this, imagine attempting to capture a fleeting moment in time, striving for a perfect snapshot. The more precisely we focus on one aspect, like the exact location of an object, the less clarity we have about how fast it's moving or in which direction. This principle reveals that, at the most fundamental level, Our grasp of the universe is inherently limited by these constraints on precision. When we consider speculation about the very boundaries of the universe, the uncertainty principle raises intriguing questions. If particles and their interactions are the foundational building blocks of everything that exists, then the uncertainties in their properties could suggest that the boundaries of the universe itself are not as well defined as we might imagine. Instead of having a hard, discernible edge, the universe could be more like a foggy horizon, where regions exist where the typical rules of space and time break down. This uncertainty drives us to explore whether the universe has a true limit, or if it is an ever-expanding, constantly shifting entity, where the boundaries are in a perpetual state of flux. It encourages scientists to question whether our universe is boundless, its boundaries always in motion, or if the very nature of space-time is far more fluid and unpredictable than we realize. The more we uncover about the fabric of reality, the more we are reminded that some questions may forever remain unanswered. The boundaries of the universe could be as uncertain as the particles that form the very foundation of everything around us. Our understanding of light has undergone a dramatic evolution, transforming it into a powerful tool for unraveling the mysteries of the universe, particularly in its most distant and enigmatic reaches. Initially, light was thought of as nothing more than a simple source of illumination. However, as scientific inquiry progressed, it became clear that light is part of a broader spectrum, one that includes not only the visible light we see, but also a variety of other types of light, such as infrared and ultraviolet, which are invisible to the human eye. With the advancement of technology, telescopes began to capture light emitted by distant stars and galaxies, and this light became a kind of cosmic messenger, conveying essential information about the distant objects it had traveled from. By studying the light emitted or absorbed by these celestial bodies, scientists have been able to learn a great deal about their composition, temperature, distance, and even their motion. The color variations within the light spectrum offer clues to these fundamental properties. For example, a redshift in the light indicates that a galaxy is moving away from us, supporting the theory that the universe is expanding. The study of light has also provided key insights into some of the universe's most mysterious phenomena, such as black holes. When light encounters a black hole, it behaves unpredictably. Some of it gets absorbed by the black hole's immense gravity, while some is bent and redirected, creating a shadow-like region. These strange effects give scientists valuable clues about the extreme gravitational forces at play within black holes, offering a glimpse into their structure and behavior. As researchers continue to study the light that interacts with these cosmic giants, they are slowly unraveling the complex mechanics behind their function, pushing the boundaries of our knowledge of these mysterious objects. The examination of light even extends to the study of the cosmic microwave background radiation, the faint glow left over from the Big Bang. This ancient light offers a unique window into the very early universe, allowing scientists to probe its age and evolution. By analyzing this light, scientists gain a deeper understanding of the universe's birth, its infancy, and how it has developed over the course of billions of years. Every discovery tied to the study of light enhances our understanding of the universe's edges, emphasizing the role that light plays in revealing the deepest secrets of the cosmos. It is through this fascinating phenomenon that we are able to build a richer narrative of the universe, linking human curiosity with the vast, mysterious sky above. One of the farthest light sources ever observed by astronomers originates from a galaxy called GNZ11. This galaxy is located so far away that the light we see today actually began its journey over 13 billion years ago. Looking at this distant light is like looking back in time to an era when the universe was still in its infancy, only a few 100 million years after the Big Bang. The study of this ancient light offers critical insights into the early universe and its development. By analyzing it, scientists can gain a clearer picture of how galaxies formed and evolved over billions of years. Moreover, the vast distance this light has traveled underscores the immensity of the universe, stretching far beyond our own galaxy. As we peer into the depths of this ancient light, we are confronted with the vastness of the universe. which continually challenges our perceptions of scale and distance. As we explore the concept of the universe's boundary, it is crucial to recognize that the universe is not static, it is continually expanding. There is no definitive edge or limit in the traditional sense. Instead, the observable universe is defined by the farthest light that we can detect, which sets a horizon for our observations. Beyond this limit, there may well be more universe waiting to be explored, but it remains beyond our reach, as the light from those regions has not had enough time to reach us. In this way, studying the light from distant galaxies not only enriches our understanding of the universe's past, but also hints at the enduring mystery of what lies beyond our observable limits. Redshift and blueshift are fascinating phenomena that provide astronomers with vital clues about the universe and its expansion. Imagine standing on a busy street watching cars whiz by. When a car approaches, the sound of its horn appears to rise in pitch, and as it drives away, the sound lowers. This shift in pitch is analogous to what we observe with light in the universe. When astronomers observe distant galaxies, they notice that the light from those moving away from us shifts toward longer wavelengths, a phenomenon known as redshift. This shift to the red end of the light spectrum indicates that those galaxies are moving away from us, suggesting that the universe itself is expanding. The farther a galaxy is, the greater its redshift, meaning it is moving away from us at a faster rate. This relationship provides valuable insight into the rate at which the universe is expanding, helping scientists better understand its size, shape, and ultimate fate. Conversely, blueshift occurs when an object is moving toward us. The light from such an object shifts toward shorter wavelengths, moving from the red end of the spectrum to the blue end. While most galaxies exhibit redshift due to the expansion of the universe, there are notable exceptions, such as the Andromeda Galaxy, which is actually moving toward our own Milky Way. By studying both redshift and blueshift, astronomers can piece together the dynamics of the universe, determining the velocities of galaxies and estimating their distances. These phenomena help us understand how celestial objects are organized within the vastness of space and provide essential clues about the universe's underlying structure. While the universe may appear limitless, the study of redshift, blueshift, and the movement of galaxies brings us closer to understanding its boundaries. By studying the ancient starlight emitted by distant stars, we are effectively peering back in time, gathering clues about the conditions that existed in the early universe. This ancient light carries information about the universe's expansion and development, revealing how the cosmos has grown and evolved over billions of years. As we analyze this light, we uncover not only the history of the universe, but also its future trajectory, helping us understand its continued expansion and the forces that will shape it in the coming eons. Ancient starlight is not just a glimpse into the past, it is a time machine that transports us to the very origins of the universe. Through the faint glow of cosmic microwave background radiation, we can peer into the aftermath of the Big Bang, a moment that occurred around 13.8 billion years ago. This radiation, often referred to as the echo of the Big Bang, offers a snapshot of the universe in its infancy, revealing the conditions from which the cosmos emerged. Studying this ancient light gives us insights into the primordial state of the universe, how galaxies formed, and the intricate structures that evolved from this initial chaos. By analyzing this light, scientists can trace the timeline of the universe's formation and use it to hypothesize about the universe's shape, composition, and ultimate fate. In this way, ancient starlight serves as one of the most powerful tools at our disposal. It not only illuminates the distant reaches of space, but reveals critical information about the nature of time and space itself. However, the journey to understand these distant stars is constrained by a fundamental law of nature, the speed of light. The speed of light, an unyielding barrier, governs the pace at which information can travel through space, setting a limit on how quickly we can explore the universe. Light moves at an astonishing speed, approximately 186,282 miles per second. Yet even at this speed, it takes time for light to reach us from distant stars. This means that when we observe a star or galaxy that is millions or even billions of light years away, We are not seeing the object as it is now, but as it was when its light first left. For example, if a star is located 100 million light years away, the light we see today began its journey 100 million years ago. This simple fact profoundly affects our understanding of the cosmos, as it implies that the farther we look into space, the further back in time we are able to peer. The light we detect from the distant reaches of the universe serves as a cosmic time machine, allowing us to observe the past as it was, frozen in the photons that traveled across vast distances. This time delay in light travel means that our ability to interact with distant regions of the cosmos is limited. If an event were to occur in a galaxy billions of light years away, the information about that event would take billions of years to reach us. Thus, the further we look, the more we are confined to an era long past, and the harder it becomes to witness or influence the present conditions in distant regions of space. The speed of light, therefore, plays a crucial role in shaping our perception of the universe and our ability to explore it. The speed of light is not just a number. It represents the very structure of the universe. It shapes our understanding of time and space, dictating the flow of events and governing the interactions between matter and energy. As we venture further into the cosmos, this constant reminds us of how vast and intricate the universe is, and how far we remain from fully understanding its nature. While the speed of light limits our exploration, it also forces us to confront the realities of the universe's vastness and the mysteries that remain hidden within its farthest reaches. At the edge of the universe, time itself behaves differently. To fully appreciate this, we must first understand how space and time are intrinsically linked. On Earth, time is a constant, measured by clocks and divided into hours, minutes, and seconds. It flows steadily with little variation, but as we venture into the farthest corners of the universe, this sense of time begins to unravel. The expansion of the universe itself causes distant galaxies to recede from us, and as they do, time is perceived differently. This phenomenon is known as redshift, where the light from these far-off galaxies stretches, causing it to shift toward longer wavelengths. This shift is not just a visual effect. It has profound implications for how we understand the passage of time. As we observe distant galaxies, the redshift reveals that time, as measured from Earth, appears to slow down for observers in these far-flung locations. In regions of intense gravitational fields, such as near massive objects like black holes, time might behave even more strangely. In these areas, time passes more slowly relative to the pace we experience here on Earth. The closer we approach these extreme environments, the more warped our perception of time becomes. In such regions, a moment could stretch out, making time feel elastic and malleable. This effect is particularly pronounced at the edges of the universe, where the most distant galaxies are moving away from us at extraordinary speeds due to the expansion of space itself. This stretching of time, known as time dilation, plays a crucial role in how we understand the universe's boundaries. It alters our perception of the universe's scale and age, and can even challenge our very notion of what constitutes the edge of the cosmos. The observable universe is not defined by a physical boundary, but rather by the furthest distance that light has traveled since the Big Bang. The further we look, the further back in time we peer, and the more the effects of time dilation become apparent. An observer on a galaxy moving rapidly away from us might experience time very differently from someone on Earth, leading to a warped perception of the universe's limits. This interplay between time and space continues to challenge our understanding of the cosmos. As we push the boundaries of space exploration, we must also reconsider our assumptions about time. The relationship between time and motion and the effects of gravity suggests that time is not a simple, unchanging flow, but a dynamic element of the universe itself, shaped by the fabric of space. Time is not just a clock ticking away. It is a product of the universe's very structure, and its behavior can shift depending on location and speed. Cosmic timelines offer a framework for understanding the history and evolution of the universe, providing clues about when life might have arisen in different epochs. By studying these timelines, we can identify periods when conditions may have been favorable for life, such as the formation of stars like our Sun, which created the elements necessary for life on planets. These timelines not only shed light on the history of our own solar system, but also suggest the possibility of life elsewhere in the universe. As we examine the history of the universe, we can also trace the paths of supernovae, whose explosive deaths distribute heavy elements across space. These events play a crucial role in the formation of new stars and planets, and by studying their remnants, we can better understand the conditions required for life to emerge. This knowledge encourages scientists to look beyond our own galaxy, searching for planets around distant stars that might have evolved under similar conditions. Through advanced telescopes and space missions, astronomers are discovering new exoplanets that lie within the habitable zones of their stars, increasing the likelihood that life may exist elsewhere. The search for life beyond Earth is an ongoing endeavor, one that relies heavily on the study of cosmic timelines. These timelines help us understand not only the age of celestial bodies, but also the diverse conditions that might support life in different corners of the universe. While our solar system has produced life as we know it over billions of years, these timelines suggest that other stars could have hosted life forms under different circumstances. The fluctuations in cosmic conditions, the birth of galaxies, and the evolution of planetary systems all hint at the potential for life to arise in ways we've yet to imagine. The universe, which is roughly 14 billion years old, provides a rich timeline for everything we observe around us. It is within this immense time frame that the stars, planets, and galaxies we see today were born and evolved. This cosmic history is not just a record of the past, but a living story that continues to unfold, with each new discovery adding to our understanding of the universe and our place within it. Through the study of cosmic timelines, we are not only learning about the past, but also expanding our search for life, pushing the boundaries of human knowledge and exploring the vast, unexplored frontiers of the cosmos. When we contemplate the edge of the universe, it's essential to clarify a fundamental misconception. The universe does not possess an edge in the traditional sense, as one might imagine the edge of a flat piece of paper. Instead, the concept of the universe's boundaries is deeply connected to its ongoing expansion. As the universe expands, everything within it, galaxies, stars, and planets, moves away from everything else. This expansion is not just an observable phenomenon, but a defining characteristic of our cosmic reality. It means that the light we see from distant galaxies has traveled for billions of years to reach us, offering a glimpse into the past. The further away a galaxy is, the older the light we observe, providing us with a visual timeline of the universe's history. The farthest we can see today is often referred to as the observable universe. Picture this observable region as a vast sphere of light, its surface marking the limit of what we can detect. This sphere doesn't represent a physical boundary or edge of the universe. It simply indicates how far light has been able to travel since the beginning of time. Beyond that region, the universe continues to stretch outward. We cannot see what lies beyond, not because there's an edge, but because the light from these distant regions hasn't had enough time to reach us. This limitation arises from the finite speed of light, not from any physical boundary. In fact, the expansion of the universe suggests that areas far beyond our observable universe are receding from us so quickly that their light will never reach us. The universe's age, therefore, shapes our understanding of the limits of what we can observe. But it is crucial to recognize that these limits do not imply a physical edge to the cosmos. The universe stretches as infinitely beyond our sight, encouraging us to push the boundaries of exploration further, even as we grapple with the overwhelming scale of space and time. Time is another crucial element in how we understand the universe. It's not just a measure of when events occur, but a fundamental concept that interacts deeply with the very fabric of reality. Time allows scientists to sequence the cosmic events from the birth of stars to the collision of galaxies, providing a timeline that is essential for understanding the universe's evolution. It helps us piece together a coherent narrative of the cosmos, explaining how everything, from subatomic particles to massive galaxy clusters, evolved over billions of years. In the early moments of the universe, everything existed in a tiny, extremely hot state. Time itself traces the path of cosmic evolution from that singular beginning as the universe expanded rapidly in what we call the Big Bang. This ongoing expansion is intertwined with time, as time itself provides the context for measuring how far along we are in this grand cosmic process. Time also plays a pivotal role in our understanding of gravity and space. According to Einstein's theory of relativity, time is not separate from space, but rather a part of a four-dimensional continuum known as spacetime. Mass, such as that found in planets and black holes, warps spacetime, and this warping affects the flow of time itself. The presence of massive objects influences the passage of time, causing it to slow down in stronger gravitational fields. This relationship between gravity and time complicates our understanding of the universe's boundaries. As we consider the observable universe, time helps define how far we can see by tracking the journey of light from distant galaxies. But time itself becomes even more fascinating when we consider whether it has a beginning or an end. Some theories suggest that time began with the Big Bang, while others entertain the idea that time stretches infinitely into the future, or even loops back on itself in a cyclical manner. Each of these theories alters how we perceive the universe's boundaries, deeply intertwining time with our understanding of existence. Time shapes our theories about the universe's limits, allowing us to create a narrative that connects events, cosmic structures, and the fundamental laws of physics. It influences how we perceive the vastness of space and guides our relentless quest to explore what lies beyond. At the edge of our knowledge of the universe, dramatic cosmic collisions shape the landscape of space. Picture the outer reaches of the cosmos as a chaotic region where galaxies, propelled by the ongoing expansion of the universe, move at breathtaking speeds. In these distant realms, galaxies collide, their gravitational forces drawing them together in a cosmic dance. These encounters can lead to the formation of new stars, as the gas and dust within the galaxies compress, reigniting the process of stellar birth. Equally awe-inspiring are the collisions of neutron stars, remnants of supernova explosions. These stellar remnants are incredibly dense, with masses greater than that of the Sun, all compressed into a sphere no larger than a city. When two neutron stars spiral toward one another, their collision creates a cataclysmic event. This collision can unleash a brilliant explosion called a kilonova, brighter than entire galaxies, scattering heavy elements across the universe. This process also generates gravitational waves, ripples in spacetime that travel across vast distances, offering us a unique way to observe the most extreme events in the cosmos. Perhaps the most dramatic of all are the collisions of black holes. These cosmic giants possess gravitational forces so intense that they pull everything around them, including light, into their singularity. When two black holes collide, they create an explosion of energy, equivalent to the power of countless suns. This violent event sends out gravitational waves that ripple through spacetime, detectable across vast distances. These collisions provide us with crucial data about the nature of gravity and spacetime, offering insights into the universe's most fundamental forces. At the edges of the universe, these violent collisions act as both destructive and creative forces. They rearrange the cosmic landscape, leading to the birth of new stars and galaxies. Each collision tells a story, unveiling the dynamic and ever-evolving nature of the cosmos. These cosmic interactions help scientists refine our understanding of the universe's structure and boundaries, encouraging us to think beyond what we can currently observe and pushing us toward new frontiers in cosmic exploration. As we peer into the vastness of space, the ongoing interactions between galaxies offer invaluable clues about the nature of the universe. Many galaxies are in motion, drawn toward one another by the pull of gravity. When these galaxies collide, they don't simply pass through each other. Instead, they merge, creating new celestial bodies and triggering spectacular cosmic events. These galactic collisions offer insight into the distribution of matter and energy across the universe. Analyzing these interactions can help scientists determine whether the universe is truly infinite or if it has some form of boundary. If galaxies continue to move apart, it might suggest that the universe is expanding indefinitely. However, if collisions and mergers are common, this might imply a more intricate structure with gravitational boundaries. The data from these cosmic events also deepens our understanding of dark matter and dark energy. mysterious substances that influence the dynamics of galaxies. These invisible components shape the behavior of galaxies during collisions, affecting the universe's expansion and potentially its ultimate fate. The chaotic yet mesmerizing nature of galactic interactions allows us to glimpse into the very fabric of the universe. By studying these collisions, scientists can refine their models of the cosmos and improve our understanding of its ultimate shape and boundaries. This cosmic turmoil also illuminates dark matter's role in the universe's structure. Although dark matter cannot be directly seen, its gravitational influence is undeniable. It forms the unseen scaffolding of the universe, holding galaxies and clusters of galaxies together. When dark matter clumps together, its gravitational pull can significantly affect the evolution of the universe. These interactions can create regions of higher density, which may attract more ordinary matter, potentially sparking the formation of new stars and galaxies. This process may extend beyond the observable universe, influencing the creation of structures that we have yet to detect. As the universe continues to expand, dark matter's effects will play a crucial role in determining the fate of galaxies, whether they drift farther apart or collide, and how they shape the cosmos in ways we have yet to fully comprehend. In this way, the universe's edge is not just a physical boundary, but a dynamic, ever-changing region that continues to unfold as we explore its mysteries. Each cosmic event, each collision, and each discovery brings us closer to understanding the true nature of the universe and its infinite possibilities. As dark matter collides and interacts, it might give birth to gravitational waves, ripples in the very fabric of space-time, created by massive movements in the universe. These waves, though invisible to our conventional observation tools, carry invaluable information across vast stretches of space, offering insights into cosmic events occurring far beyond the limits of our current observational reach. The hidden dance of dark matter, despite being nearly undetectable, plays a critical role in shaping the future landscape of the cosmos, hinting at new realms and untapped possibilities that await discovery. Gravitational waves, known scientifically as cosmic ripples, act as messengers from the deepest corners of the universe. Picture a serene, still pond. When a stone is thrown into its surface, ripples spread outward, moving away from the point of impact. In a similar way, ripples in space occur when massive celestial objects, such as black holes or neutron stars, collide or accelerate rapidly. The immense gravitational forces generated by these events disturb the very structure of space-time, causing waves to travel across the cosmos. At the farthest reaches of the universe, these ripples tell the stories of violent cosmic phenomena, unveiling secrets that would otherwise remain hidden from our gaze. For example, when two black holes spiral toward each other in a deadly cosmic dance, they send out waves that carry vital information about their masses, energies, and motions. These gravitational waves, detected here on Earth, allow scientists to reconstruct the details of these cataclysmic events, details that are often invisible to traditional light-based telescopes. Gravitational waves act as a form of cosmic hearing, offering a new dimension to our understanding of the universe, as they reveal events that are often obscured from sight. This ability to listen to the cosmos enriches our grasp of the universe's most extreme environments, unveiling the dynamics of phenomena far beyond our immediate sensory reach. The ripples we detect are more than just echoes of cosmic chaos. They offer a glimpse into the birth and evolution of the universe itself. Just as the thunder follows the lightning, gravitational waves offer us insight into the cataclysmic events that shaped our existence. These cosmic signals guide our exploration of the universe's most violent processes, shedding light on the fundamental laws of physics that govern everything from the formation of galaxies to the behavior of the smallest particles. In this sound of the universe, we come to understand the dramatic and energetic events unfolding at the very edge of existence, providing a deeper comprehension of the cosmos and its complex workings. Gravitational waves are disturbances in the fabric of space-time, originating from some of the most violent events the universe can produce. These include black hole mergers, neutron star collisions, and other extreme phenomena. When such colossal objects interact, they send ripples through space-time, similar to the waves that spread out from a stone tossed into a pond. By detecting these waves, scientists can peer into events that would otherwise remain unseen. Imagine trying to understand a battle at the edge of the universe, where massive forces clash with one another, forces so intense that their light might not even reach us, either due to their immense distance or because they occur in regions obscured by thick clouds of dust and gas. Gravitational waves, however, break through these barriers, carrying crucial data across unimaginable distances. Through highly sensitive detectors placed on Earth, we can capture these ripples as they pass through our planet. The very fabric of space-time stretches and compresses slightly as a gravitational wave passes by, creating minuscule changes in distance that can be measured with extreme precision. By analyzing these shifts, scientists can infer properties such as the masses, spins, and other characteristics of the objects involved in the collision, providing a detailed picture of these events. Beyond this, gravitational waves give us valuable insight into the nature of gravity itself, revealing how it behaves under the most extreme conditions imaginable. In doing so, they bridge gaps in our understanding of both astrophysics and fundamental physics, providing clues to the universe's most profound mysteries. Through gravitational waves, we are not merely listening to echoes from the violent edges of the universe. We are being invited to explore the origins and behaviors of cosmic phenomena that shape the very fabric of everything we observe. These waves act as messengers, guiding us toward a deeper understanding of the fundamental principles that govern the cosmos. The constants of physics are fundamental values that dictate how the universe functions. They are the rules of the game, setting the parameters for everything from the smallest atoms to the vast expanses of the cosmos. Understanding these constants is essential for building theories that explain the behavior of the universe, both at the microscopic scale and at the cosmic level. One of these constants is the speed of light, which serves as a limit on how quickly matter and information can travel. This constant has far-reaching implications, influencing everything from our understanding of time to the distances we can observe across the universe. These constants also play a crucial role in defining the structure of space-time, the very fabric that binds together space and time. If even one of these constants were to differ, even slightly, the entire nature of the universe could change in dramatic ways. Such a change might affect the formation of galaxies, the burning process of stars, or even the existence of life as we understand it. In the theories surrounding the edge of the universe, such as the concept of an expanding universe, these constants determine how fast the universe expands and influence its ultimate fate. Will the universe continue to spread infinitely, or will it eventually collapse back in on itself? As scientists delve into these cosmic boundaries, understanding the behavior of these constants becomes crucial to shaping our comprehension of the universe. Among these constants, the fine structure constant plays a pivotal role. This fundamental number governs the strength of electromagnetic interactions, which are essential for understanding how particles interact and form the building blocks of matter. You can think of it as a key parameter that sets the scale for a range of physical processes. The fine structure constant directly influences the behavior of atoms, affecting properties such as their size and the energy levels of their electrons. This constant is especially important when considering the universe's boundaries. When we explore the edge of our knowledge, the fine structure constant plays a key role in how stars and galaxies form. By dictating how atoms bond and how light interacts with matter, it helps shape the very structure of the universe we observe today. Researchers continuously probe whether the fine structure constant, a crucial value in physics, maintains its stability across the vast expanse of the universe. They wonder whether this fundamental constant, which governs atomic interactions, behaves consistently over enormous distances. Any deviation in this value could point to a profound shift in the very fabric of the laws of nature, or it might reveal regions of the universe that function under different principles than those we observe in our local environment. Understanding the behavior of this constant opens a window to deeper, unexplored mysteries, such as the true composition of the universe, its ongoing expansion, and the elusive nature of its boundaries. As we dive into these questions, the possibility arises that there could be entire dimensions or realms that exist outside the ones we currently perceive. Imagine the universe as a grand, cosmic game with its rules set by constants, specific values that define how everything behaves. These constants are not arbitrary. They determine the very limits of possibility in the universe. Just as adjusting the rules of a game can completely change its outcome, altering these physical constants would dramatically reshape the universe's behavior. Consider, for instance, the gravitational constant. This constant governs the attraction between objects with mass. If this value were even slightly higher, gravitational forces would be more powerful, leading to a denser formation of galaxies. The types of stars that could form, their size and behavior would shift, fundamentally altering the life cycle of these stars, and possibly impacting the entire evolution of galactic structures. Similarly, the speed of light, a constant fundamental to our understanding of time and space, exerts a profound influence over everything, from the birth of elements in stars to how we perceive the universe itself. If the speed of light were slower, the implications would be far-reaching. The way information travels would change, affecting everything from how structures in space are formed to the very concept of time. Distances across the cosmos might feel greater, and the passage of time would stretch differently, altering how we interact with the universe at the most fundamental level. This shift could have profound effects on how matter and energy behave on a universal scale. Changing the constants would not only alter the physical conditions of the universe, but also what could exist within it. Take the electromagnetic force, for example. If this force were much weaker, atoms might not bind together in the way they currently do. This would lead to a radically different universe, one in which stars, planets, and life as we know it could not exist. It's a captivating thought, a universe where the very foundation of existence is foreign to anything we can imagine. Such a change in the constants would likely lead to entirely new forms of matter and energy, and perhaps even new laws of physics, each shaping a unique cosmic reality that we cannot yet fathom. This exploration of the constants pushes the boundaries of not just what is possible within our universe, but also what constitutes reality itself. Constants like Planck's constant, though small, are essential to our understanding of quantum mechanics, the branch of physics that deals with the tiniest scales of matter. These constants are the bridge between the minuscule world of subatomic particles and the vastness of the cosmos. Planck's constant helps define the scale at which quantum effects, such as energy quantization, become significant. Without it, our understanding of radiation, energy emission from stars, and the behavior of particles in space would be incomplete. Planck's constant also plays a crucial role in defining the Planck length, which is the smallest measurable unit of space that holds physical meaning. This tiny length suggests that there is a limit to how much we can know about the universe at extremely small scales. Below this boundary, traditional physics might break down, and we would need a new framework to understand how matter and energy behave. The very fabric of space and time may be fundamentally different at these infinitesimally small scales, suggesting that the laws we rely on today are only part of a much bigger picture. As researchers study the boundaries of the universe, they focus on places where extreme conditions, like those near black holes or in the early moments after the Big Bang, render conventional physics ineffective. In these places, Planck's constant becomes a vital tool for predicting what might happen when the known laws of physics cease to function. Understanding constants like Planck's is essential for exploring the deepest mysteries of the cosmos, as they guide theoretical models and provide a foundation for experimental investigations. These constants form the backbone of everything we understand about how the universe operates. They are not merely theoretical ideas, but are instrumental in the study of the cosmos. Constants such as the speed of light, the gravitational constant, and the electric charge of particles are universal. They apply everywhere, from the farthest reaches of space to the most infinitesimal particles. They create a stable framework that scientists use to probe the deepest corners of the universe. The speed of light, for instance, isn't just the speed at which light travels. It represents the ultimate speed limit of the universe. Nothing can move faster than light. and this constant governs how we measure distances across space. It shapes our understanding of how light from distant stars and galaxies reaches us, revealing insights into their properties, behaviors, and histories. Without this constant, it would be impossible to gauge the vast distances that separate us from the most distant reaches of the universe. Similarly, gravity, another cornerstone constant, dictates the interactions between mass and space. It's the force that binds planets in their orbits around stars, that shapes the structure of galaxies and governs the motion of celestial bodies. By understanding the strength of gravity, scientists can infer the composition and structure of the universe on the largest scales. For example, by calculating the gravitational influence of objects that lie beyond our observable horizon, they can predict the presence of hidden matter or even entire galaxies that we cannot yet see. These constants are not just abstract numbers, they are the very essence of our universe. They form the underlying rules that govern everything from the smallest particles to the largest galaxies. Through studying these constants, scientists are piecing together the puzzle of the cosmos, unlocking the secrets of its past, present, and possibly its future. The exploration of these constants could one day reveal whether there are realms or dimensions we have yet to comprehend, and perhaps even offer us a glimpse into the true nature of existence itself. These constants, fundamental to the laws of physics, play an indispensable role in shaping the theories that govern the universe. They are the cornerstones upon which we build our understanding of the cosmos, acting as the glue that holds together the very fabric of our scientific inquiry. These constants help to articulate the behaviors and interactions of particles at the most microscopic scales. Through their influence, scientists can decipher how the fundamental forces, gravity, electromagnetism, the strong nuclear force, and the weak nuclear force, shape everything around us. These theoretical frameworks, grounded in the constants of nature, allow us to predict a wide range of cosmic phenomena, from the birth and death of stars to the enigmatic properties of dark matter and dark energy. The constants provide a firm foundation for not just observing the universe, but for venturing into its most mysterious corners with a sense of confidence and certainty. With these tools, humanity can peer into the farthest reaches of space and time, pushing the boundaries of knowledge and understanding. The constants represent the very essence of nature's laws, guiding our quest to unravel the profound secrets that lie beyond our observable world. One of the most captivating phenomena in the universe is the life cycle of a star. A star's journey begins in the cold, empty stretches of space, where a cloud of gas and dust, known as a nebula, slowly begins to collapse under its own gravity. As the material condenses, the temperature increases exponentially, reaching a point where nuclear fusion ignites in the star's core. This marks the birth of a new star. During the majority of its existence, a star is locked in a delicate balance. It fuses hydrogen into helium, releasing vast amounts of energy. This energy creates an outward pressure that counteracts the inward pull of gravity, preventing the star from collapsing under its own weight. This phase, known as the main sequence, can stretch across billions of years, with the star continuing to burn hydrogen into helium. For larger stars, however, this phase is brief. These stars burn through their fuel at a much faster rate, and once their hydrogen is exhausted, they enter the later stages of their life cycle. Massive stars expand into red giants, sometimes culminating in a dramatic explosion known as a supernova. The death of a massive star in this way leaves behind either a neutron star or a black hole, depending on its size and the specifics of its collapse. Smaller stars like our Sun follow a different path. When they exhaust their hydrogen, they expand into red giants. However, instead of exploding, they shed their outer layers, creating a stunningly beautiful planetary nebula. What remains behind is a dense, cooling core, a white dwarf, that will gradually fade away over billions of years. Stars play a fundamental role in shaping the universe, particularly at its edges. New stars are born from the remnants of older, dying ones. As they form, they enrich the surrounding environment with heavier elements, carbon, oxygen, iron, that are crucial for the creation of planets and even life. The process is cyclical, with the death of a star leading directly to the formation of new ones. Through this constant renewal, the universe remains dynamic, constantly evolving and changing. This cycle of stellar birth, evolution, and death offers deep insights into the structure of the universe, its continuous growth, and the origins of the very elements that make up life. Understanding this process brings us closer to understanding not just the past of the universe, but its future. The birth of stars is intricately linked to the expansion of the universe itself. To visualize this, think of the universe as a vast balloon with dots scattered across its surface. As the balloon inflates, the distance between the dots increases. In a similar manner, the universe is expanding, causing galaxies to move farther apart. Gas and dust, the raw materials for stars, are spread across the universe, and when these clouds accumulate enough mass, their gravity causes them to collapse inward. The collapse heats the material until nuclear fusion begins, signaling the birth of a star. As the universe continues to expand, conditions for star formation change. Distant regions of the universe may become increasingly inaccessible, with gas clouds drifting too far apart for new stars to form. Yet, this expansion does not hinder all star formation. In fact, when galaxies collide or draw near to one another, the resulting compression of gas can trigger bursts of new star formation. Thus, even as galaxies move apart, some may experience moments of new creation, where stars are born amid the vastness of intergalactic space. This intricate relationship between the universe's expansion and the cycles of star formation reflects the complex, ever-changing nature of the cosmos. Each new star adds to the universe's diversity, furthering the ongoing process of cosmic evolution. As the universe grows, it does not become stagnant. Instead, it continues to evolve, like with stars, galaxies, and black holes participating in an eternal dance that spans eons. The death of a star is far from a simple ending. In many ways, it is a dramatic and crucial event in the shaping of the universe. When a massive star runs out of fuel, it explodes in a supernova, a cataclysmic event that sends shockwaves through space, scattering heavy elements like carbon, oxygen, and iron across the cosmos. These elements, essential for the creation of new stars and planets, are spread across the vast emptiness of space, enriching the interstellar medium and paving the way for future generations of stars and planets. In this way, the cycle of stellar life, birth, evolution, death, mirrors a larger universal process of continuous renewal. It suggests that the universe is in a constant state of transformation, and that each death brings with it the potential for new beginnings. It's a reminder that even as we lose stars and galaxies, we are simultaneously witnessing the birth of new cosmic entities, each contributing to the grand unfolding story of the universe. Beyond our visible universe lies an unknown expanse that invites speculation. The observable universe as we see it is limited. The light from distant galaxies has not yet had time to reach us, and thus we are blind to vast regions of space. Yet, just as the death of a star leads to the birth of a new one, it is possible that beyond our sight, regions of the universe are in various stages of evolution. Perhaps there are stars forming from clouds of gas and dust, or maybe there are dying stars on the brink of supernova explosions. If the universe is indeed expanding as we observe, then it's possible that distant regions are moving away from us so quickly that their light will never catch up. This could mean that vast, uncharted realms of space exist, full of unknown properties and phenomena that could challenge and expand our current understanding of the universe. These unseen regions may contain not just distant galaxies, but entirely new forms of cosmic structures that we are yet to imagine. Thus, the death of stars in our observable universe is just a piece of a larger, more complex puzzle. It suggests a broader process of cosmic evolution that stretches beyond our comprehension. The dynamic interplay between the observable and unobservable universe hints at the richness of what lies beyond the boundaries of our sight. These uncharted territories may hold answers to questions we haven't yet asked, containing the keys to mysteries that could transform our understanding of the cosmos. In the heart of most galaxies, including our own Milky Way, reside supermassive black holes, monstrous objects weighing billions of times more than our sun. These enigmatic entities remain at the core of many astrophysical theories, yet they also pose intriguing challenges. Their presence at the farthest reaches of the universe raises fundamental questions about how they formed and how they evolve. Traditional models of galaxy formation often assume a gradual buildup, with stars forming first and merging over time to create larger black holes. However, observations of supermassive black holes challenge this view. Some of these massive black holes appear to have formed much earlier than expected, suggesting that their growth might be much more rapid and complex than previously thought. If supermassive black holes existed shortly after the Big Bang, this would imply that their formation process might have been different from what we currently understand. Instead of the gradual accumulation of matter, black holes might have grown rapidly through mechanisms such as the collapse of massive gas clouds or the merging of smaller black holes. This possibility raises important questions about the very processes that govern the growth and evolution of galaxies. In the end, the presence of supermassive black holes at the outermost edges of the universe challenges our current understanding of cosmic formation. These celestial giants may not simply be the end products of slow and steady evolution, but may instead represent a more intricate, accelerated process. Their existence pushes the boundaries of our knowledge and suggests that the universe, in all its complexity, has many more secrets to reveal. The rapid expansion of knowledge in cosmology has led to some extraordinary revelations, particularly concerning the role of supermassive black holes scattered across the distant reaches of the universe. These colossal entities, found at the centers of galaxies billions of light years away, challenge our understanding of cosmic evolution in profound ways. The growth of supermassive black holes at such extreme distances suggests that their influence might extend far beyond what we currently understand. These behemoths exert powerful gravitational forces that could alter the surrounding cosmic environment in ways that we are only beginning to comprehend. For instance, their immense gravity could potentially affect star formation rates, warp the behavior of neighboring galaxies, and impact the way entire clusters of galaxies evolve. This realization forces us to reconsider our models of the universe, urging us to incorporate the effects of black holes not only as central features of galaxies, but as crucial players in shaping the overall dynamics of the cosmos across vast expanses of time. As we continue to refine our understanding of these distant cosmic giants, we may need to rethink the very framework of our cosmic models. It is no longer sufficient to view black holes simply as isolated objects at the core of galaxies. Instead, these supermassive black holes seem to be intricately woven into the very fabric of cosmic development, influencing processes at scales we had previously not considered. In fact, understanding the formation and growth of these black holes could require innovative approaches to existing theories, ideas that stretch the boundaries of current physics, pushing us to think about the universe in entirely new ways. As astronomical observations using increasingly sophisticated telescopes capable of capturing light across a range of wavelengths continue to provide valuable insights, we are moving ever closer to unraveling the mysteries of these extraordinary objects. Through these efforts, we will undoubtedly reshape our models of the cosmos, redefining the way we view its origins and evolution. Supermassive black holes, particularly those located at the very edges of the observable universe, represent more than just a challenge to existing scientific beliefs. They serve as catalysts for a paradigm shift in the field of astrophysics, opening up new avenues for discovery and reconfiguring our understanding of the universe's development. Pulsars, neutron stars, and other remnants of stellar evolution also contribute to this ever-evolving picture. These fascinating objects, born from the death of stars, serve as important tools in our quest to understand the limits of the universe. A pulsar, for example, is a rapidly rotating neutron star with a highly magnetized core. As it spins, it emits beams of radiation that sweep through space like the light from a lighthouse, offering us a rhythmic signal that can be observed from Earth. These regular pulses allow scientists to probe the extreme conditions under which matter behaves in some of the most densely packed environments known to exist. Pulsars, along with other stellar remnants like white dwarfs and black holes, provide a unique window into the life cycle of stars, offering invaluable insights into the physical laws that govern their evolution. Each type of stellar remnant comes with its own set of characteristics and behaviors, challenging our understanding of physics, particularly in extreme environments. The gravitational fields surrounding black holes, for instance, offer a test bed for the limits of our theories on gravity and the nature of space-time. Pulsars, through their regular emissions, help scientists measure cosmic distances, offering an indirect method for mapping the structure of galaxies. These cosmic clocks also allow researchers to refine theories related to the expansion of the universe. Beyond this, the interactions between pulsars and the surrounding material in their environments can reveal the presence of vast quantities of energy and matter, leading to further speculation about the nature of the universe's boundaries and what might exist beyond them. By studying how stars evolve into these remnants, we gain a deeper understanding of the conditions that existed in the early universe, shedding light on the mechanisms that led to the formation of galaxies and other large-scale cosmic structures. Far from being mere curiosities, pulsars and stellar remnants are indispensable to modern astrophysics. They offer us crucial pieces of the puzzle regarding the nature of the universe's boundary and the fundamental laws that govern all of existence. Through continued study of these celestial objects, we not only learn more about their unique properties, but also enrich our appreciation for the broader cosmic tapestry, full of mysteries yet to be explored. The quest to understand the nature of the universe's edge has been a central theme in human culture throughout history, with various societies imagining its boundaries in ways that reflect both their scientific curiosity and spiritual beliefs. In ancient Mesopotamia, for example, the universe was conceived as a flat disk floating on an infinite chaotic sea. Above this disk, the sky was thought to be a solid dome, with stars embedded in it like jewels. For the people of Mesopotamia, the edge of the universe was seen as a boundary that separated the familiar terrestrial world from the vast, unknown waters that encircled it. In contrast, ancient Greek philosophers offered a more abstract conception of the cosmos. They envisioned a spherical universe with celestial bodies moving in perfect circles. The edge of this universe was imagined as a place of nothingness, a void beyond which lay the infinite unknown, a concept that would heavily influence later philosophical and scientific thinking. Across the Atlantic, many Native American traditions feature elaborate mythologies that depict the cosmos as a series of realms or layers, each with its own characteristics. For these cultures, the edge of the universe was not seen as a strict boundary, but as a sacred space where spiritual beings dwelled. These traditions emphasize the interconnectedness of the earth, the sky, and everything in between, suggesting that the universe's edge is not so much a final limit as it is a gateway to spiritual realms, where the forces of nature and the divine coexist in harmony. Similarly, in ancient Chinese thought, the universe was often envisioned as a dynamic, cyclical system governed by the principles of yin and yang. The edge, in this view, was not a hard limit, but a space where opposing forces balanced one another, symbolizing the continuous flow and transformation of cosmic energy. As civilizations evolved, so did their perceptions of the universe's edge. Some imagined it as a terrifying void inhabited by monstrous creatures, while others envisioned it as a celestial paradise, a garden, or a place of divine peace. These varying narratives speak to a universal human desire to make sense of the unknown, blending elements of wonder, fear, and reverence in our search for understanding. Despite the diversity of beliefs, a common thread runs through them all: the quest to understand what lies beyond the observable universe. This pursuit has driven humanity forward from ancient myths to modern scientific exploration, revealing the enduring significance of the universe's edge in our collective imagination. Today, as scientific knowledge expands, our understanding of the universe's boundaries has become more sophisticated. Theories of the multiverse, for example, suggest that our universe may be just one of many, each with its own set of physical laws and realities. This concept challenges traditional notions of an infinite bounded universe, instead proposing a vast and varied cosmic landscape where the limits of space and time may be vastly different from anything we can imagine. Despite this scientific progress, however, the ancient cultural beliefs surrounding the universe's edge continue to offer unique perspectives on the mysteries of existence. They remind us that while our understanding of the cosmos may evolve, the fundamental human impulse to explore the unknown remains unchanged. Throughout history, the various depictions of the universe's edge have not only shaped our view of the cosmos, but also influenced our approach to scientific inquiry. From the ancient myths to modern cosmological theories, the concept of the universe's boundaries has served as both a challenge and an inspiration, pushing humanity to expand the limits of our knowledge. The rich tapestry of cultural beliefs surrounding the universe's edge, whether seen as a physical boundary, a spiritual realm, or a cosmic mystery, continues to enrich our understanding of the universe today, providing valuable insights into the fundamental nature of existence. Through these explorations, both scientific and cultural, we continue to seek answers to one of the most profound questions in human history. What lies beyond the edges of the known universe? Across the ages, many cultures have gazed upon the stars, captivated by their mysteries and beauty. Civilizations such as the Egyptians, Babylonians, and Greeks sought to understand the vastness of the heavens, developing early systems of astronomy that mapped the night sky. They created celestial calendars, predicting the movements of planets and stars, all in an attempt to make sense of the universe. Yet these observations were never merely academic or idle curiosity. They were deeply woven into the fabric of daily life, serving purposes far beyond the abstract. Astronomy was integral to agriculture, navigation, and religion. For example, the Babylonians were among the first to systematically record the motions of celestial bodies, studying the cycles of the planets and recognizing the rhythms that underpinned astronomical events. This practice laid the groundwork for understanding the predictable nature of celestial phenomena, an understanding that would later influence both modern astronomy and the very idea of time itself. The Greeks, on the other hand, brought a philosophical dimension to the study of the cosmos. They posed fundamental questions about the nature of the universe and humanity's place within it. Figures like Aristotle, for example, offered early models of the cosmos, attempting to frame the structure of the heavens and the earth. Yet it was later thinkers, such as Aristarchus of Samos, who would challenge the geocentric view of the universe, proposing instead a heliocentric model in which the Earth revolved around the Sun. This radical shift in thinking would forever change our perception of Earth's position in the cosmos. Over time, humanity's understanding of the universe expanded alongside technological advancements, from the invention of the telescope to the launch of space probes that have allowed us to peer deeper into the universe's farthest reaches. The spirit of curiosity ignited by the ancient astronomers is very much alive today, driving the modern exploration of the universe's boundaries. Concepts such as dark matter and dark energy, once speculative, now form the core of astrophysical research, linking directly back to the questions and observations of early astronomers. Indeed, the influence of ancient civilizations on modern science cannot be overstated. Their methods, observations, and frameworks provided the foundational knowledge that would shape the future of scientific exploration. The same sense of awe and wonder that spurred ancient astronomers continues to drive us forward into the unknown, propelling us to explore the limits of the universe with ever greater precision. Whether we are observing distant galaxies or searching for signs of life beyond Earth, the curiosity sparked by these early cultures is still the heartbeat of our cosmic inquiries. Throughout history, myths and legends have been woven into the human effort to comprehend the enormity and mystery of the cosmos. Across many cultures, a common theme arises: the concept of a cosmic ocean or void. These stories often describe the universe as an endless, boundless expanse, with celestial bodies floating within it, like islands in a vast and mysterious sea. This imagery reflects the human fascination with the infinite and the unknown. In ancient Egyptian mythology, for example, the sky goddess Nut was depicted as a vast, overarching canopy draped over the earth, representing the limits of the universe. The stars, in this worldview, were seen as the scattered pieces of her body, tagged with her daily journey through the sky, symbolizing the cyclical nature of life, death, and rebirth. Similarly, many Native American creation myths center on the notion of a primordial void, a darkness that existed before the world was formed. These narratives often present the universe as a living, interconnected entity, with the Earth and its inhabitants deeply intertwined with the cosmos. Such stories are rich with themes of respect for the natural world and an acknowledgement of the cosmos as both the origin and sustainer of life. In Norse mythology, the universe is structured into 9 realms, all connected by the great tree Yggdrasil. This mighty tree reaches from the deepest depths of the underworld to the heavens, symbolizing the intricate relationships between different worlds and the vastness of existence itself. Yggdrasil serves as a reminder that life and death coexist within the framework of a larger, infinite universe, each influencing the other. These various myths, whether they depict the universe as a life-giving source, an ocean of chaos, or a vast tree that links all realms, reflect humanity's innate desire to understand the cosmos. They mirror our curiosity and our need to understand the boundaries of existence. The ancient narratives echo the very questions that modern science continues to pursue. What lies beyond the edge of the universe? What is the nature of the cosmos, and how does humanity fit within it? These stories, though born of ancient cultures, continue to shape our scientific endeavors and our understanding of the universe's limits. As time has progressed, these cultural narratives have continued to influence how we approach the cosmos. They help frame our questions, guiding what we perceive as possible or impossible. For example, in some cultures, the night sky is imagined as the domain of ancestors, their spirits watching over the living. This view fosters a sense of connection with something greater, inspiring curiosity about the existence of life beyond Earth and what that might mean. In other cultures, the night sky is approached more scientifically, prompting humanity to seek answers through observation, mathematics, and experimentation. These differing perspectives drive the myriad ways in which we explore the universe, whether through storytelling, mythology, or rigorous scientific inquiry. Moreover, as our understanding of the universe grows, so too do our cultural narratives. With each new discovery, whether it be the existence of black holes, the realization of the vast distances between galaxies, or the strange behavior of quantum particles, our stories adapt and evolve. Artists, writers, and scientists are all influenced by these revelations, pushing the boundaries of human knowledge and imagination even further. New cultural interpretations emerge, offering fresh perspectives on our place in the cosmos. Cultural narratives, in this way, serve not only to reflect our curiosity about the universe, but also to ignite it, stoking the fires of exploration and discovery. They become the framework through which we understand and question the unknown, helping us navigate the infinite possibilities that lie before us. In the realm of art, the concept of the edge of the universe has long been a source of fascination. Artists often depict the universe as a vast, shimmering expanse, filled with galaxies, nebulae, and stars, invoking a sense of mystery that calls viewers to venture further into the unknown. One common approach is to show the universe as a glowing sea of light, fading gradually into the dark, symbolizing the limits of human understanding. These visual representations capture the essence of the cosmic unknown, the idea that as we travel further into space, light itself becomes increasingly scarce, and the familiar laws of physics begin to break down. The fading light often symbolizes the edge of known reality, a threshold where our comprehension of space and time starts to stretch and warp in ways that defy our understanding. Some artists take a more abstract approach, delving into the concept of infinity and the possibility of multiple dimensions. They might depict portals or gateways leading into chaotic, vibrant realms, suggesting that what lies beyond the observable universe is not emptiness, but something more. Perhaps alternate realities, parallel universes, or dimensions beyond our perception. These imaginative depictions challenge the viewer to confront the limitless potential of existence and the constraints of human understanding. What lies beyond the universe in these representations is not just an empty void, but a realm of infinite possibilities waiting to be explored. Such images push the viewer to contemplate the mysteries that lie just beyond our grasp, inspiring further curiosity and fueling the quest for knowledge that continues to drive us forward. Artists have long been inspired by the vast, uncharted realms of the universe, drawing from scientific concepts to push the boundaries of their creative expressions. By weaving scientific theories into their work, they create powerful visual dialogues that bridge the gap between the tangible and the mysterious. This unique synthesis of science and art invites audiences to reflect on profound existential questions about life, the universe, and our place within it. Through their imaginative renderings, these artists draw us to the farthest reaches of space, where we are encouraged to explore the unknown, to look up at the night sky, and to contemplate the very nature of reality itself. The exploration of cosmic boundaries becomes not just a thematic focus, but a source of wonder and philosophical inquiry. Surrealism, in particular, plays an instrumental role in capturing the ethereal vastness of the cosmos. As a movement, surrealism delves deep into the subconscious, challenging the constraints of everyday reality by presenting fantastical, dreamlike visions. When applied to cosmic themes, surrealism invites the imagination to break free from the known universe, urging viewers to consider the limitless possibilities that lie beyond. This approach allows artists to combine objects, scenes, and concepts in unexpected ways, creating visual paradoxes that suggest a reality beyond our comprehension. These works may depict worlds where gravity seems absent, where celestial bodies interact in improbable ways, or where time itself behaves in strange and unpredictable manners. Such images stir questions about the very essence of existence, offering both intellectual and emotional engagements with the unknown. Moreover, surrealism touches upon the human experience by translating abstract cosmic phenomena into emotions, feelings of awe, wonder, and even anxiety. It serves as a bridge between the rational world of science and the emotional landscapes of the viewer. In this way, surrealist art does not merely represent the cosmos. It serves as a means of reflecting on humanity's search for meaning within this vast, mysterious universe. It transforms scientific hypotheses about space and time into visual stories that resonate with viewers, encouraging them to reflect on their own place in the universe and the ongoing quest for knowledge. Modern artists, too, have drawn inspiration from the far reaches of space, translating the mysteries of the cosmos into compelling visual narratives. The concept of the edge of the universe has become a central theme in many works, prompting contemplation about what lies beyond the observable universe. Through expansive canvases filled with swirling galaxies, radiant stars, and nebula, artists evoke the enormity and awe-inspiring beauty of space, inviting us to consider our insignificance in the grand cosmic order. These works often encourage reflection on our place within the universe, prompting viewers to question the very nature of existence. Other artists, exploring more abstract interpretations of the cosmos, may use forms and shapes that suggest the invisible forces at play within the universe, such as gravity or dark matter. For example, the powerful presence of black holes might be represented through swirling dark patterns, symbolic of the force that pulls everything into its depths. These dynamic and evocative visuals challenge viewers to confront the unknown, forcing us to question the very nature of reality. By rendering such abstract concepts in visual forms, artists create spaces where personal interpretation and intellectual engagement can flourish. With the advent of new technologies, modern artists now have even more tools at their disposal to explore cosmic themes. Digital media, in particular, has expanded the possibilities for artistic expression, enabling artists to simulate cosmic events or even create interactive installations. These immersive experiences allow viewers to engage with the cosmos in ways that were previously unimaginable. Through virtual environments, visitors can travel through space, witness astronomical phenomena, and explore the very boundaries of our knowledge. These new digital mediums invite us to experience the universe not just as a distant theoretical concept, but as a tangible, interactive experience that fosters a deeper connection to the cosmos. In all these forms, modern art functions as a bridge between science and creativity, sparking dialogues about the universe's edge and the infinite possibilities that lie beyond. Through their works, artists ask us to consider questions of life, space, and the unknown. They challenge us to expand our perspectives on the universe and encourage us to look beyond the confines of our limited knowledge. Art enriches our understanding of both the scientific and emotional dimensions of existence, transforming the cosmos from an abstract concept into something that we can experience on a personal, profound level. Art, in this context, offers a distinct lens through which we can engage with scientific theories. While science relies on empirical evidence, mathematical precision, and data to describe the cosmos, art taps into the emotional and conceptual resonance of those same ideas. For example, a painting of a starry night or a sculpture symbolizing a black hole can evoke profound feelings that bring complex scientific theories to life. These artistic representations of cosmic phenomena help viewers grasp abstract concepts like the Big Bang or quantum mechanics, transforming them from cold mathematical ideas into experiences that stir the imagination. Take, for instance, the portrayal of space-time, one of the most complex and fascinating theories in modern physics. Through artistic interpretations, space-time can be visualized as a malleable fabric that bends and warps under the influence of massive celestial bodies. By using colors, shapes, and textures, artists can convey the idea of reality itself being warped, helping viewers conceptualize the strange and often counterintuitive nature of our universe. These artistic renderings not only make these theories more accessible, but they also allow us to engage with the more existential questions they raise, such as the meaning of existence or humanity's place in the grand cosmic tapestry. Furthermore, art plays a critical role in bridging the communication gap between scientists and the public. Complex scientific concepts can often seem inaccessible or abstract to the general public, but through visual storytelling, art makes these ideas more approachable and relatable. By merging emotion with fact, art fosters a deeper connection with the audience, inspiring curiosity and encouraging exploration. Whether through stunning visual imagery or compelling narratives, art brings the universe closer to us, allowing us to engage with science on a deeply personal level. Together, science and art enrich our understanding of the cosmos, showing us that the universe is not only a place defined by scientific theories and equations, but also a vast, awe-inspiring realm full of beauty and inspiration. Art possesses a unique power to translate complex scientific ideas into tangible experiences that resonate emotionally and intellectually with the viewer. When we contemplate the edge of the universe, concepts like infinity, dark matter, or the curvature of space-time can seem overwhelming. Yet, through artistic expression, these abstract ideas can be shaped into visual narratives that spark our curiosity and broaden our comprehension of the cosmos. Imagine, for instance, a painting that captures the limitless vastness of space, where colors flow seamlessly into one another, symbolizing the transition from light to dark. This gradient of colors can represent the endless expansion of the universe, drawing us to question what lies beyond the observable limits. Similarly, sculptures or installations made from glass, metal, or other materials might mimic the idea of light curves or gravitational waves, making these otherwise invisible phenomena more tangible and accessible. Through such artistic expressions, artists offer new ways to engage with the universe's most abstract and perplexing concepts. Art also inspires imagination, pushing us to think beyond the constraints of what we know. It encourages us to consider our place in the cosmos, to reflect on the mysteries of space and time, and to ask profound questions about the nature of reality. By blending scientific concepts with creativity, artists cultivate a sense of wonder that motivates us to explore the universe's vast unknowns. Art is not merely decoration. It is a vital tool for understanding the universe, allowing us to engage with both the intellectual and emotional aspects of the cosmos. Through art, we can expand our perception of the universe, fostering a deeper appreciation for the beauty, complexity, and mystery that lies beyond. As humanity continues to gaze into the depths of space, the pursuit of knowledge raises important ethical considerations. Chief among these is the question of responsibility. If we venture to explore the far reaches of space, do we have a duty to protect any potential life forms we might encounter? The risk of disrupting alien ecosystems, possibly leading to extinction or irreversible damage, looms large. Likewise, the extraction of resources from asteroids or other celestial bodies raises difficult questions about ownership, stewardship, and the impact on both the environment of other worlds and the balance of life on Earth. The desire to expand our reach into the cosmos must be carefully weighed against these ethical dilemmas. As we push the boundaries of exploration, we must consider the potential consequences of our actions, not just for Earth, but for any other planets, moons, or ecosystems that may be affected by our presence. Additionally, As we uncover new scientific knowledge about the universe, it is crucial that we ensure this information is used ethically. The technologies developed for space exploration could have far-reaching implications, and it is our responsibility to prevent their misuse for harmful purposes. In this complex and ever-evolving relationship between art, science, and exploration, we are reminded that our journey into the unknown must be guided by both curiosity and caution, responsibility and imagination. Moreover, the pursuit of space travel prompts deep reflection on the future of humanity. As we look toward expanding into the cosmos, one must ask, will we leave behind a planet in disarray? Should the efforts to colonize other worlds come at the expense of addressing the critical issues here at home, such as poverty, inequality, and the looming threat of climate change? This question underscores a fundamental dilemma in our exploration of the universe. How do we balance the need for progress beyond Earth with the responsibility to safeguard our home? A profound ethical challenge emerges in this context, one that questions our very understanding of humanity's place in the universe. How do we reconcile the search for answers beyond our atmosphere with the spiritual and philosophical inquiries that inevitably arise from it? Exploring the universe is not simply a journey of scientific discovery, but a journey of humanity itself. It's a delicate balancing act. Ambitious exploration tempered by the profound responsibilities we hold as stewards of our planet and potentially, one day, the cosmos. The pursuit of space not only presents an exciting opportunity, but also invites us to face significant challenges that test our commitment to cosmic preservation. Currently, our efforts are focused on understanding and protecting celestial bodies within our own universe, planets, moons, and asteroids. Yet, if we were to venture beyond the boundaries of what we know as our universe, it could open new realms of existence. These realms might contain entirely different types of matter, energy, and possibly life forms. The implications of such exploration are far-reaching, offering not just new frontiers to conquer, but vital lessons for our ongoing quest to preserve our cosmic environment. One potential impact of exploring beyond our universe is the opportunity to gather knowledge and experience that could inform better practices for preserving our own cosmic habitat. For example, discovering how other realms function, how their ecosystems thrive or coexist under entirely different conditions, could provide insights into how we might sustain our own planet. The possibility of understanding alternative ecosystems offers hope that, by studying other forms of life and existence, we may find new ways to address the environmental challenges we face on Earth. However, the risks of venturing beyond our universe cannot be ignored. Should we encounter new materials or phenomena, there is the potential for negative interactions with the elements of our universe. The introduction of foreign matter could disrupt the delicate cosmic balance in much the same way that alien species, when introduced into new ecosystems, often wreak havoc. The consequences of such contamination could be catastrophic, a scenario that calls for careful consideration and respect for the unknown. Moreover, as we push the boundaries of exploration, we are forced to confront ethical dilemmas about our role in the larger cosmos. Would it be our responsibility to ensure that other realms remain untouched, preserved? This question parallels our efforts to protect endangered species on Earth, leading us to reflect on the broader implications of our actions. Should we venture into uncharted territories, we must ask ourselves, are we prepared to bear the weight of such responsibility, and what legacy do we wish to leave behind? Ultimately, the exploration beyond our universe is likely to transform our understanding of cosmic preservation. It will reveal the fragile interplay between discovery and responsibility, emphasizing the need to balance the pursuit of knowledge with the imperative to protect the wonders we already hold in our universe. In navigating these challenges, humanity's stewardship of the cosmos may one day become as crucial as our stewardship of Earth itself. As scientists embark on their journeys to explore the limits of the universe, they carry with them a profound set of responsibilities. First and foremost, they must commit to the pursuit of knowledge with unwavering integrity. This means conducting experiments, making observations, and sharing findings honestly, without exaggeration or distortion. The quest for understanding is delicate, and it is essential that scientific reporting remains accurate, transparent, and grounded in truth. Such rigor is vital for maintaining public trust in science, which is central to our collective ability to explore the mysteries of the cosmos. Additionally, scientists must always be mindful of the ethical implications of their work. As they delve deeper into questions of space, time, and existence, they must consider how their discoveries could affect humanity's understanding of itself and our place in the universe. For instance, breakthroughs in the study of black holes, genetic manipulation in space, or the search for extraterrestrial life could provoke ethical dilemmas. Such discoveries challenge not just scientific boundaries, but the moral frameworks we use to understand the world. As these frontiers expand, scientists have a duty to engage with society, educating the public about potential impacts and fostering informed, open discussions on these profound issues. In addition to ethical responsibility, scientists must prioritize safety. The pursuit of knowledge should never come at the cost of human lives or environmental destruction. Whether sending probes to distant planets or studying the powerful energies of stars, scientists have an obligation to minimize any risks associated with these endeavors. The balance between progress and precaution is critical to ensuring that the quest for knowledge remains a force for good. Finally, collaboration is paramount. The universe is vast, and no single scientist or nation can fully unravel its secrets alone. Researchers must work together, sharing expertise, resources, and perspectives across disciplines and borders. This collective approach not only deepens our understanding of the universe, but also fosters the kind of innovative breakthroughs that can benefit all of humanity. By working together, we can tackle the profound challenges posed by space exploration, ensuring that the benefits of our discoveries are shared widely and equitably. The responsibilities of scientists exploring the universe's edges are multifaceted. Integrity, ethics, safety, and collaboration each play a crucial role in ensuring that our pursuit of knowledge is meaningful and beneficial to the world. As we look toward the cosmos, these guiding principles must illuminate the path ahead, ensuring that our exploration remains grounded in responsibility, humility, and care for the world we call home. The quest to understand the universe's boundaries, where the known collides with the unknown, has profound implications for our global resources. This pursuit demands significant investment in technology and research, often fueled by both national space agencies and private companies. As these entities develop increasingly advanced tools and missions to explore distant celestial bodies, they also drive technological innovations that have the potential to benefit life on Earth. Materials and technologies developed for space exploration could enhance communication systems, improve data processing capacities, and contribute to renewable energy solutions, among other applications. Yet, as we reach for the stars, we must also confront the practical realities of resource allocation. Scientific funding directed towards space initiatives could potentially divert attention and financial support away from pressing issues here on Earth, such as poverty, education, or climate change. The tension between the ambitious goals of space exploration and the urgent needs of the planet is undeniable. To balance these priorities, nations must carefully consider how to allocate resources, ensuring that while we strive to unlock the secrets of the cosmos, we do not neglect the needs of our citizens. In conclusion, the pursuit of space exploration is a journey that brings both profound opportunities and significant challenges. It invites us to look beyond the confines of our planet and expand our horizons, but it also compels us to consider the ethical, environmental, and social responsibilities that accompany such ambition. The exploration of the universe requires not only scientific ingenuity, but a deep commitment to stewardship, ensuring that our quest for knowledge enhances both our understanding of the cosmos and our responsibility to protect the world we call home. Moreover, the search for resources beyond our planet, such as mining asteroids for rare materials, could have profound implications for global economies if the concept proves to be feasible. This endeavor holds the potential to alleviate some of the mounting pressure on Earth's finite resources. By tapping into the vast wealth of materials scattered across our solar system, we could open the door to new industries and job creation. However, this ambitious exploration raises significant ethical concerns. Who owns the resources we extract from celestial bodies? What impact will our extraction efforts have on the pristine environments of these distant worlds? As we push forward into the cosmos in search of new wealth, we must consider these questions carefully. While the technological breakthroughs that accompany such exploration could enrich our lives, we must also balance this drive with a commitment to solving the pressing challenges we face here on Earth. Exploring the outer reaches of the universe may provide us with insights that can transform our way of life, but this journey comes with the responsibility of making thoughtful decisions about how we allocate our resources and prioritize our global needs, ensuring that our efforts to venture into space do not undermine the well-being of humanity here on Earth should be a guiding principle. As we set our sights on the unknown, ethical principles should act as the compass that guides our actions. These principles offer us a framework for navigating the vast expanse of space responsibly, ensuring that we move forward with a sense of duty to the future of both our planet and the universe at large. Central to any ethical exploration of the cosmos is the idea of respect. Respect for the celestial bodies we study, for the potential life forms that may exist beyond Earth, and for the very environment of space itself. One of the key ethical principles in this regard is stewardship. Stewardship urges us to take responsibility for our cosmic surroundings. As we send spacecraft to distant planets, moons, and other celestial bodies, we must ensure that we do not contaminate these pristine environments with earthly microbes. Our exploration should be conducted with the utmost care, preserving these alien worlds for scientific study and for future generations. This responsibility to preserve the integrity of space environments is essential not only for advancing our understanding of the cosmos, but also for maintaining the delicate balance of these distant ecosystems. Another crucial aspect of ethical space exploration is inclusivity. As we venture further into the unknown, it is vital to involve a wide range of perspectives from across the globe. Space exploration should not be the sole domain of any one nation or group, but should be a collective endeavor that brings together diverse cultures and communities. By incorporating these varied perspectives, we enrich our understanding of the universe and foster collaboration. Discoveries made in the farthest reaches of space should not belong to a select few, but should resonate with people from all walks of life. This inclusive approach ensures that the human spirit, with all its diversity and creativity, is reflected in our quest for knowledge. Furthermore, we must anticipate and prepare for the ethical dilemmas that may arise from our discoveries. For instance, what would happen if we were to find evidence of life on another planet? Such a discovery would be nothing short of revolutionary, challenging our very understanding of life itself. It would raise profound questions about the rights of these extraterrestrial life forms, how we should protect them, and whether our actions could harm them. Ethical exploration requires that we have frameworks in place to thoughtfully address these complex scenarios, ensuring that we approach any potential discoveries with care, respect, and responsibility. Ultimately, as we push the boundaries of human knowledge by exploring the cosmos, our commitment to ethical principles must remain at the forefront of our actions. Our journey into the universe should not merely be about seeking answers to our most profound questions. It should also be about doing so in a manner that honors the intricate web of life that exists in the universe. By prioritizing respect, inclusivity, and foresight, we can ensure that our explorations of space are not just groundbreaking in their scientific achievements, but also responsible in their impact on the future of humanity. Incorporating the study of the universe's edge into school curriculums can ignite curiosity and expand students' understanding of fundamental scientific concepts. Teachers can introduce the concept of the universe's edge not as a physical boundary, but as a conceptual one tied to the observable universe, the portion of the universe that we can see and study. Starting with basic astronomy lessons, students can begin to grasp the vastness of space and the evolving nature of galaxies. Engaging activities like stargazing with telescopes or utilizing planetarium programs can help students visualize the cosmos and foster a sense of awe and wonder. Teachers can also encourage students to map constellations, allowing them to visualize their own place within this expansive universe. Next, discussions surrounding the Big Bang Theory can help contextualize how the universe has expanded over time. Educators can explain that the light from the most distant regions of the universe took billions of years to reach us, and thus these regions represent the edge of the observable universe. Classroom experiments or simulations demonstrating cosmic expansion can further clarify these abstract concepts. Integrating technology into the classroom, such as virtual reality programs that allow students to explore space, can make these complex ideas more tangible and engaging. Projects on topics like dark matter or the cosmic microwave background radiation offer students a hands-on approach to the complexities of cosmology, giving them a deeper understanding of the universe's inner workings. Classroom discussions can also delve into the philosophical questions that arise when considering what lies beyond the observable universe. These thought-provoking conversations can spark critical thinking and inspire students to grapple with the mysteries of the cosmos. By blending scientific understanding with creativity, students will gain a well-rounded perspective on humanity's quest to understand the universe's edge. This approach will not only make learning about space exciting, but will also make it deeply relevant to students, helping them transform curiosity into knowledge. Online platforms are vital tools in spreading knowledge about the universe and its mysterious boundaries. Imagine a digital library accessible to anyone, anywhere, filled with articles, videos, and discussions about cosmic phenomena. These platforms enable experts and enthusiasts to share their insights and discoveries, fostering a global community that transcends geographic borders. Through social media, educational websites, and video sharing platforms, curious minds can engage with complex topics, such as black holes or the expanding universe. Simplified explanations paired with stunning visuals make these scientific concepts more accessible to people of all backgrounds. Additionally, online platforms provide real-time discussion forums and comment sections where individuals can interact, ask questions, and receive answers from knowledgeable sources. This helps cultivate a culture of inquiry and learning. Live streaming events like lectures from astronomers or discussions about recent space missions bring space exploration to life, making it feel immediate and relevant. The excitement generated by the release of new images from distant planets or stars ignites a collective thrill, encouraging future generations to explore the universe further. In this way, online platforms democratize knowledge, allowing everyone to engage in the quest for cosmic understanding. Interactive workshops offer a powerful way to engage people with the concept of the universe's edge. These workshops provide hands-on experiences that make abstract concepts more tangible. Instead of simply listening to a lecture about distant galaxies, participants can interact with models and tools that illustrate these ideas in an engaging and relatable manner. Imagine a workshop where participants can manipulate a globe-like model of the universe, gaining a better understanding of the vast distances between celestial bodies. They could simulate how light travels across these immense distances, experiencing firsthand the delays and challenges faced when light crosses such vast expanses. These types of hands-on experiences deepen comprehension and make learning enjoyable. By connecting personally to the content, participants can engage more deeply with the material, helping them appreciate the complexities of the universe and our place within it. Collaborative activities within workshops play a pivotal role in fostering teamwork and sparking discussions among participants. By encouraging learners to share ideas and ask questions freely, these activities create a dynamic space for curiosity to flourish. The open exchange of thoughts often leads to deeper discussions on complex topics such as black holes, dark matter, and the origins of the universe itself. When participants feel they are part of a community, one that is collectively exploring the mysteries of space, they are far more likely to stay engaged, continuing their explorations long after the workshop has concluded. Moreover, incorporating cutting-edge technology like virtual reality, VR experiences can significantly enhance the learning environment. Imagine being transported to the edge of a black hole or navigating through a nebula. VR simulations allow participants to fully immerse themselves in the wonders of the cosmos. This level of engagement makes abstract concepts more tangible and brings the far-off and unfathomable closer to home. These immersive experiences captivate the imagination, making it easier for participants to grasp the enormity and complexity of the universe. Interactive workshops create a unique environment in which curiosity thrives. By empowering individuals to engage directly in the exploration of space, they offer more than just knowledge. They foster a sense of connection to the universe. As learners interact with one another and their surroundings, they form bonds, challenge one another's assumptions, and spark new ideas. This spirit of collaboration promotes a deeper understanding and a lasting interest in cosmic phenomena, pushing learners to seek out more knowledge on their own. Looking ahead to the future of public lectures on cosmic exploration, we can anticipate a remarkable evolution in both format and content. Gone are the days of monotonous, one-sided lectures. Picture an engaging presentation where science is brought to life through live demonstrations, interactive elements, and state-of-the-art technology. Audiences could experience virtual space travel, enabling them to explore distant galaxies and nebulae firsthand. Such immersive encounters provide an unparalleled opportunity to comprehend the vastness of space, a scale that is often difficult to convey through words alone. In addition to VR, stunning visual aids, such as realistic graphics and animations, would help depict complex concepts like the cosmic horizon or the fabric of space-time. These visuals could make the unimaginable more accessible, turning abstract notions into something that feels concrete. Presenters might also embrace storytelling, weaving together real-life discoveries and breakthroughs in astrophysics to capture the audience's imagination. The journey of telescopes capturing light from the earliest stars, for example, could ignite a sense of awe and curiosity, connecting participants emotionally to the subject matter. Furthermore, as communication methods evolve, we could see a greater emphasis on dialogue and discussion. Rather than passively absorbing information, audiences could ask questions, share insights, and engage in real-time debates with experts. This interactive approach not only deepens understanding, but also fosters a sense of community among participants. And with the rise of social media and online platforms, these lectures could extend their reach to a global audience, bringing the mysteries of the cosmos to people around the world. Science fairs, too, provide invaluable platforms for young minds captivated by space and the mysteries of the universe. These events ignite curiosity by offering an interactive environment where students can dive into space-related topics and design their own projects. Whether they are researching the physics of black holes, the search for exoplanets, or the origins of cosmic phenomena, students are encouraged to explore and ask questions. This hands-on approach promotes critical thinking, a key skill for anyone seeking to unravel the vast complexities of space. Presenting their projects at science fairs also allows students to articulate their ideas and share their findings with others. When peers, mentors, and judges show interest in their work, it boosts their confidence and fuels their desire to pursue careers in science and technology. The process of investigation and discovery becomes a personal journey, one that transforms abstract scientific concepts into tangible knowledge. And as students collaborate in teams, they simulate real-world scientific endeavors, honing essential skills like problem-solving, communication, and teamwork. Mentorship is another crucial aspect of science fairs. Interacting with teachers, local scientists, or researchers helps students gain insights into the latest advancements in astrophysics and space exploration. These interactions enrich their understanding and inspire them to push the boundaries of what they know. In this way, science fairs nurture the next generation of astronomers, physicists, and engineers who may one day be responsible for unlocking the secrets of the universe's edge. The exploration of space not only serves as a scientific endeavor, but also invites us to confront profound existential questions about humanity's place in the universe. At the boundaries of the cosmos lie some of the greatest mysteries we've yet to understand. Areas filled with dark matter, remote galaxies, and phenomena that challenge the very foundations of our knowledge. This vast emptiness evokes both awe and fear, stirring questions about our significance in the grand scheme of existence. Looking into the night sky often prompts feelings of curiosity. Humans have an inherent drive to explore, and the mysteries of the cosmos fuel that instinct. The quest for knowledge is rooted in our deep-seated need to understand the unknown, questions about our origins, our future, and our place within the vast expanse of the universe. Exploring these frontiers forces us to confront the nature of time itself, as many astronomical phenomena unfold over incomprehensibly long periods. This vast scale makes our human lives seem fleeting, challenging our perception of mortality and the passage of time. The contemplation of space also has a unifying power. When we glimpse the universe's grandeur, we are reminded that we are all part of a shared cosmic journey. This sense of unity transcends borders, encouraging cooperation and collaboration as we face the vastness of the unknown together. It is a reminder that the mysteries of the universe are not confined to any one individual or nation, but belong to all of humanity. Delving into the universe's edge invites a reflection on the very essence of humanity, our curiosity, our fears, and our yearning for connection. It pushes us to rethink what it means to be human in a universe that is both magnificent and confounding. As we explore the unknown, we stretch not only our minds but our hearts, embracing both the wonders that lie ahead and the inner struggles that define us. The journey into this vast unknown calls us to discover not only the universe, but also the depths of our own humanity. The mere act of contemplating the boundaries of the universe challenges our understanding of reality itself. We are compelled to confront the idea of infinity, something that defies our typical understanding of space and time. We are accustomed to thinking in terms of the finite, but contemplating an infinite universe forces us to step beyond these limitations and imagine a reality that stretches far beyond our grasp. This shift in perspective also leads to a humbling realization. We are not the center of the universe. Instead, we are just one part of a much larger cosmic tapestry. The idea of being surrounded by galaxies, stars, and celestial phenomena encourages us to consider our place within this grand structure, evoking a sense of connection to something much larger than ourselves. Additionally, contemplating the shape of the universe, whether it is flat, curved, or takes on some other geometry, forces us to reconcile our scientific understanding with deeper philosophical questions. What is the universe's fate? What lies beyond the edges of what we know? These questions challenge us to expand our thinking and question assumptions about existence, reality, and the nature of time. As we venture further into the unknown, questions arise about the very nature of time itself. If the universe had a beginning, what existed before it? If it continues expanding indefinitely, what will that mean for the future of the cosmos? Such inquiries challenge our understanding of causality, linear progression, and the very nature of existence. These paradoxical questions push us to explore ideas that may seem contradictory, yet they spark a deeper curiosity and drive for discovery. Ultimately, exploring the universe's boundaries not only reveals the limits of human understanding, but also the boundless potential of our imagination. The more we learn about the cosmos, the more we are confronted with its mysteries. And with those mysteries comes the urge to venture ever deeper into the unknown. The vastness of the universe invites us to contemplate possibilities that stretch far beyond our current reality and to imagine a future that may one day bring us closer to the truth. For those who dedicate their lives to studying the universe's edge, the journey is not without psychological challenges. The scale of the universe can provoke feelings of insignificance, a reminder of how small we are in the grand design of things. This humbling realization can lead some to experience anxiety, existential dread, or even despair. Yet, it is also this sense of smallness that can spark a deeper appreciation for the beauty and complexity of the universe, and for the role that each of us plays in this endless journey of discovery. Moreover, the very act of grappling with the profound mysteries of the universe often becomes a source of frustration for researchers. They may find themselves confronting concepts that push the boundaries of current understanding, leading to moments of helplessness as they face the vast unknown. The more one learns, the more it seems that an overwhelming expanse of knowledge remains unexplored, fueling a sense of being adrift in an ever-expanding web of information. This feeling of being lost in the limitless universe is a psychological challenge faced by many who seek to unravel its deepest secrets. Isolation presents another formidable challenge. The universe's edge is a concept so distant and abstract that it often becomes nearly impossible to share one's thoughts and discoveries with others, especially those who may not share the same level of understanding or interest. This disconnect can deepen the sense of loneliness for those deeply immersed in the subject, as their intellectual journey takes them further from conventional points of view. The vastness of the universe, both physically and intellectually, can leave them feeling isolated, as though they are solitary travelers in an infinite sea of unknowns. Additionally, the pursuit of knowledge about the universe's limits can profoundly affect an individual's worldview. Encounters with groundbreaking ideas, such as the possibility of a multiverse or the concept of the universe's eventual end, can challenge and even shatter previously held beliefs about existence, reality, and the nature of life itself. For some, this clash between new scientific theories and deeply ingrained personal beliefs can lead to a state of cognitive dissonance, where they are torn between the facts of science and the convictions of their own minds. These moments of inner conflict can be mentally taxing, leaving one to question not only what is known about the universe, but also what is real. Furthermore, the intense imagination required to even begin to conceptualize the edges of the universe can take a significant toll on mental health. The act of visualizing concepts that stretch beyond human comprehension demands immense cognitive resources. Without proper balance, this mental exertion can lead to burnout. The complexity of these intellectual explorations, coupled with the need to engage deeply with abstract concepts, can overwhelm the mind. If not managed with periods of rest and relaxation, such intense thought processes can leave individuals mentally fatigued, unable to fully recover from the mental strain of such vast contemplation. Understanding the universe, particularly its outermost boundaries, demands more than just intellect. It requires emotional resilience, the strength to navigate both the awe and the uncertainty that accompany such knowledge. The universe stretches infinitely in every direction, and contemplating its boundlessness often evokes a profound sense of wonder. This sense of wonder, sparked by the sheer magnitude of space and the mysterious phenomena that lie beyond our planet, can have a significant impact on mental health. As people reflect on the stars, the galaxies, and the endless possibilities beyond, they often experience a shift in their perspective. The vastness of the cosmos can shift their worldview, fostering a sense of belonging to something much larger than themselves. In turn, this connection can diminish the feelings of isolation or insignificance that many individuals grapple with in their daily lives. Experiencing such awe can in fact be therapeutic. It can help to boost emotional well-being, offering a sense of connectedness with something greater. This sense of connection to the cosmos may encourage curiosity, prompting individuals to seek answers about their place in the universe. Such inquiries can lead to greater creativity and motivation, improving not only intellectual resilience, but emotional strength as well. In this way, the very act of contemplating the vastness of the universe can offer a natural reprieve from the stresses of everyday life. Gazing at the night sky serves as a form of mindfulness, providing a much-needed break from the constant churn of daily concerns. This moment of reflection allows individuals to step back and gain a greater perspective on their problems, helping to alleviate anxiety and negative thought patterns, while offering peace and clarity in the process. Ultimately, the awe inspired by the boundaries of the universe can foster a deeper appreciation for life itself. It encourages individuals to explore, ask questions, and seek meaning not just in the vastness of the cosmos, but in their daily existence as well. This pursuit of understanding, both cosmic and personal, serves as an ongoing journey that contributes positively to mental health. By nurturing a sense of wonder, individuals can experience personal growth and emotional well-being that comes from embracing both the known and the unknown. Curiosity about the universe's edges is more than just a pursuit of knowledge. It is a powerful catalyst for cognitive development. When we question the cosmos, we engage with ideas that challenge the very foundations of our reality. This spark of curiosity initiates a deep sense of inquiry that pushes us to explore not just the distant stars, but also the very way we think. In seeking answers, we learn to interpret complex ideas, evaluate evidence, and think critically. For instance, contemplating what lies beyond the furthest galaxy forces us to develop imaginative reasoning, to hypothesize, and to engage in processes of mental exploration that stretch the limits of human cognition. This process in turn stimulates intellectual agility, allowing individuals to connect abstract concepts with logical reasoning and scientific principles. But the benefits don't stop there. Discussing and grappling with the mysteries of the universe often leads to greater emotional engagement. Feelings of awe and wonder encourage creativity, driving exploration in diverse fields like science, philosophy, and the arts. As curiosity deepens into understanding, it nurtures essential cognitive skills like problem solving, adaptability, and critical thinking. Each question leads to new inquiries, forming an endless cycle of learning that sharpens the mind. In this way, exploring the universe's boundaries does more than provide answers to cosmic questions. It also nurtures the mind's capacity for growth, expanding our intellectual horizons. The journey into the universe's unknown territories is an act of engagement with the infinite. It is not only about solving scientific riddles, but about fostering a mindset that is open to discovery, learning, and adaptation. This ongoing journey enriches our cognitive capabilities in profound ways, contributing to a constantly expanding worldview. It is this pursuit of knowledge, with all of its complexities and challenges, that sharpens the mind and enriches the human experience. Emerging technologies, especially in the realm of advanced telescopes, are helping us push the boundaries of our understanding of the universe. These next-generation instruments are designed to observe distant cosmic objects with unparalleled clarity. By capturing light from the farthest reaches of space, these telescopes may reveal unprecedented details about galaxies, black holes, and the very structure of the universe itself, details that were once beyond our reach. Artificial intelligence, AI, is also playing a pivotal role in our quest to explore the universe's edge. AI has the potential to analyze massive amounts of data collected from space missions and observatories at a speed far beyond human capability. By identifying patterns and anomalies in the data, AI can assist scientists in discovering new celestial phenomena and even predicting cosmic events. This level of automation and precision will undoubtedly expand our understanding of the universe, offering insights that were previously unimaginable. These technological advancements offer an exciting glimpse into the future of cosmic exploration, pushing the boundaries of what we can observe and comprehend. Moreover, the relentless advancements in spacecraft technology are poised to extend humanity's reach far beyond the boundaries we have known, opening up previously unimaginable possibilities for exploration. The development of faster and more efficient propulsion systems could revolutionize space travel, potentially allowing missions to travel to distant planets and moons at unprecedented speeds. This could drastically reduce the time it takes to explore the farthest corners of our solar system and beyond, and enabling us to send probes and even crewed missions further into the vast expanse of space than ever before. As we gather firsthand data about the universe's outer edges, our understanding of the cosmos could expand dramatically. In parallel, the advent of quantum technologies holds enormous potential to reshape the way we interact with the universe. One of the most exciting developments in this field is quantum communication, which could enable us to transmit information across vast distances with near instantaneous clarity. Such a breakthrough would allow for real-time data sharing, transmitting cosmic observations from the far reaches of space back to Earth with virtually no delay. The implications for science, communication, and our understanding of the universe would be profound, offering new opportunities to study and share knowledge in ways previously thought impossible. At the same time, the study of gravitational waves is opening up a new frontier in the way we observe the universe. These ripples in space-time, caused by the movement of massive objects like black holes and neutron stars, offer a new method of exploration. As detectors become more sensitive, we may be able to gain insights into some of the most violent and enigmatic events in the universe, such as the collision of black holes or the merger of neutron stars. These observations could unlock new secrets about the very structure and evolution of the cosmos, providing a deeper understanding of the forces at play at the universe's edges. Together, these groundbreaking technologies promise not only to refine our current understanding of the universe, but also to unlock entirely new realms of knowledge. With each advancement, the boundaries of exploration are pushed further, leading to a more intricate and detailed picture of the universe we inhabit. As humanity continues to evolve and develop new tools to explore the cosmos, the concept of the universe's edge may also undergo a significant transformation. We currently understand the universe as having no tangible boundary, expanding endlessly in all directions. However, as civilizations in the future develop a deeper grasp of cosmology, they may begin to view the universe's boundary not as a physical wall, but as a limit of comprehension, much like how we perceive the horizon on Earth, a point where our vision ends, but that does not signify an end to existence itself. With the development of advanced technologies and enhanced space exploration capabilities, future civilizations might propose theories suggesting that what lies beyond this perceived boundary could contain entirely new dimensions or realms, offering a glimpse into the possibility that our universe is merely one bubble in a vast ocean of multiple universes. This idea could ignite philosophical and scientific debates about the nature of existence, sparking questions regarding whether we are part of a much larger cosmic tapestry, stretching our imaginations to contemplate the possibilities of multiple coexisting realities. As these future civilizations push the boundaries of their exploration, they might also recognize that the universe's boundary represents not a tangible end, but a limit of observable space. With the realization that surpassing the speed of light is not just a physical impossibility, but also a barrier to both experience and knowledge, they may come to understand that the boundary is an illusion created by the way light travels and time functions. In their ongoing quest to unravel the mysteries of dark matter and dark energy, future societies could discover that the boundary we perceive may not even be a true limit at all. In the end, civilizations of the future may find themselves not confronting a hard boundary, but embracing the mystery of the universe, viewing the limit as an invitation to further exploration rather than a confinement. This shift in perspective could lead to an appreciation for the journey of discovery, fostering an ever-deepening desire to push the boundaries of knowledge and explore whether the universe has an ultimate end or is simply part of a boundless cosmic adventure. The fate of the universe, while a subject of intense speculation and intrigue, remains a mystery that stretches the imagination far beyond what we can currently observe. One theory posits that the universe may continue to expand indefinitely, with galaxies slowly drifting farther apart as time progresses. In this scenario, the light from distant stars would eventually fade, leaving behind a dark, cold expanse in which only the faintest remnants of energy linger. This state, known as the heat death of the universe, would mark the point at which all matter and energy reach a uniform, featureless state, resulting in a universe without motion or complexity. Another possibility, known as the Big Crunch, suggests that the expansion of the universe could one day reverse, with gravity pulling matter back together. This collapse could lead to a singularity, where all of the universe's mass is concentrated once again, potentially setting the stage for another Big Bang and a new cycle of cosmic expansion and contraction. Alongside these possibilities, the theory of the multiverse suggests that our universe may be just one among many, each with its own distinct set of physical laws, dimensions, or timelines. In this view, the observable universe is but a small part of a much larger reality, and other universes may exist with entirely different properties. Some universes might collapse, merge, or even exist in parallel, creating a complex web of universes that stretches the limits of our imagination. Lastly, some theories propose that the universe might reach a state of maximum entropy, where everything becomes so spread out that individual atoms and molecules drift apart, and time itself loses meaning in this vast, cold wilderness of existence. While these scenarios remain speculative, they inspire a sense of wonder and contemplation about the nature of time, reality, and the profound mysteries of the cosmos. Each potential outcome invites us to reflect on the unknown and expand our thoughts beyond the boundaries of observable space. As humanity continues its quest to understand the ultimate fate of the universe, we are constantly driven to explore, discover, and reflect on what lies beyond the stars. Uncovering the universe's edge, or the limits of our observable universe, could fundamentally alter our understanding of humanity's place in the cosmos. While evolution is often viewed through the lens of biological processes that unfold over millions of years, shifts in knowledge and understanding can similarly influence how we perceive ourselves and adapt intellectually and culturally. If new information were discovered about what lies beyond the observable universe, it could spark a wave of technological innovation, giving rise to new fields of research and potentially revolutionizing space travel. Such breakthroughs might open up entirely new realms of exploration, such as the colonization of distant planets or even contact with extraterrestrial life, pushing humanity into new frontiers of existence. In parallel, the discovery of the universe's edge could provoke a philosophical and ethical transformation in how we view ourselves and one another. Recognizing that we are part of a vast, possibly infinite universe might inspire a collective sense of unity, fostering empathy and cooperation as we confront shared challenges like climate change or resource scarcity. As we look outward, understanding our place within the grand cosmic order could encourage humanity to work together more harmoniously, bridging differences in the face of the common challenges we all share on this fragile planet. Moreover, as we expand our understanding of the universe, it is likely that we will develop new technologies that enhance both our cognitive and physical abilities. Innovations in genetics, artificial intelligence, and virtual reality could converge with our pursuit of knowledge, leading to a profound evolution in how we think, experience, and understand life itself. The edge of the universe, while serving as a physical boundary, also represents the forefront of human curiosity, the very frontier of exploration. With every new discovery, humanity moves a step closer to understanding not just the origins of our existence, but also the potential pathways that lie ahead for our future evolution. These technological and intellectual advancements will shape not just how we live and perceive the world, but also how we as a species adapt and grow in the face of the immense mysteries of the cosmos. Thus, the journey to the edge of the universe may well drive a transformative shift in how humanity evolves, guiding us not only biologically but also culturally and intellectually as we reach ever further into the stars. Scientists and artists alike are drawn to the unknown, crafting visions of what may lie beyond our current understanding. While scientists explore the concept of an ever-expanding cosmos, artists use their imaginations to envision intricate, colorful landscapes filled with celestial bodies, swirling nebulas, and strange new planets. These creative depictions inspire curiosity and remind us that science has not yet exhausted the boundaries of creativity in its quest to understand the universe. This collaboration between scientific inquiry and artistic imagination is what makes the search for the universe's edge so compelling, as both fields work to push the limits of our knowledge while fueling the creative spirit that drives us to explore what lies beyond the stars.